we are really glad that you are joining us today for some really good talks. I want to introduce myself. So I'm going to be emceeing today for the track, and I've been leading some workshops yesterday. And my background is basically I'm with one of the sponsors and co-organizers of ETHDubai, which is Jeton Capital. And I just wanted to give you some brief introduction about what we do. So there is some information about myself, but my background is basically non-technical in management and marketing, but I've switched to programming a couple of years ago, and with this experience, I've managed to learn how to work with the teams of developers and make them actually deliver something. So some time ago, I've joined Jeton, and currently we are trying to build some pretty good stuff because we are generally a DAO and a real one. So, you know, we really have to follow what is happening with the proposals. So we don't do anything without the consent of our users. And basically our main goal is to learn how to better manage our treasury so that we can maintain the price of the token, as well as deliver some real products that the users are going to use. And at the core of what we do is basically an algorithmic treasury management protocol that is called Pathway. You can read up a lot of details about it on our materials like website, Discord, Telegram, etc. So I'm not going to share all the links with you because they are easy to find. But currently we are finishing up the development of the core of our protocol and all the key pieces that allow us to grow our ecosystem. And in general, in the roadmap for this year, we've got big plans, and like the pinnacle of all of that is basically creation of our own chain so that we can attract other developers to build with within our own ecosystem. So if you are interested, just go to the jeton.capital website. You find all the information and links there. And we are always happy to chat. So if you join our Telegram, Discord, we are always there and always ready to answer. So thanks a lot for your attention. And let's start with our speakers' presentations. The first one is going to be delivered by Sasha Shilina, and this is going to be an interesting talk about the NFTs. So please welcome. We are ready to present. So here you go. Guys, sorry for small technical problems. We're trying to figure out how to work the presentation. So here we go.
Hello, everyone. My name is Sasha. I'm a researcher at Paradigm and Humanoid. Also, I'm an artist and a PhD in journalism. So today I want to give a talk that will link all the topics I'm interested in. Okay, Sanchal? Okay. So today I will give a talk that will link all the topics I'm interested in, such as art, technology, and mass communication. The lack of concrete and systematic review and conceptualization of NFTs communication model was a limitation that was a main driver for conducting this research that combines to a deep understanding of NFT technology, blockchain technology, and gives an overview of their potential positive impact on the communication process in the creative industries. So, in particular, here I try to address this by answering the following questions. What is the potential and the benefits of blockchain technology? and NFTs for creative industries. How has NFTs emergence and spread in the last couple of years transformed the principles of communication in creative industries? First of all, let's take a quick look at the creative industries concept. Originally, creative industries were developed from cultural industries that are considered as those that combine the creation, production, and commercialization of contents which are intangible and cultural in nature. The term was coined in the late 1940s by the German philosophers and critical theorists Theodor Adorno and Max Horkheimer, who used the term in their book Dialectic of Enlightenment. They were the leading members of Frankfurt School and Marxists, so being leftists, they criticized popular culture, which is, they thought, akin to factory producing standardized goods like press, music, films. And they thought that they manipulate mass society into passivity and used the term in contrast with authentic culture. Later on, in the 1960s, researchers started realizing that commodification did not constantly or essentially damage cultural expression, and by the 1980s, the cultural industries began to be used positively in academics and policymaking. In the 1990s, policymakers converted the term cultural industry to the term creative industry, one of the concepts that marked the beginning of the digital era. So today, cultural industries are best described as a cross-sector with creative industries that is considered as a variety of economic activities which involve the generation and use of knowledge and information and include art, design, music, film, fashion, and others. Considering different approaches to defining creative industries, the researchers usually used four groups. You can see them on the slide. The first approach is supported by researchers who put creative industries on par with other industries. The second approach is reflected mainly to the concept of the creative class, the term proposed by American theorist of urban studies Richard Florida, who says that creative class is a key driving force for economic development in post-industrial cities. The third approach provides places, includes the concept of creative city. And the fourth or last approach views the creative industries as an important part of the broader economic system. It is worth noting that modern researchers emphasize that creative industries should not be viewed simply as a sector of economy or an isolated area, because there are forms and practices with which creative industries are inextricably linked, such as creative networks, creative spaces, and events. Moreover, today, art, design, music, video, and other creative products, as well as the process of their creation, are often presented in digital forms and spaces that are greatly influenced by emerging technologies which transform the communication between industry actors. But before talking about the current communication model that dominates today, I will pause for a moment on the stages of its evolution that can be distinguished into three stages. At the first stage, the emphasis was clearly in linear one-way communication, and the main term was manipulation. This type of communication is common in Western culture. Aristotle was the first to take an initiative and design the communication model, and according to his model, the sender is active member and plays a role in communication, key role, and the receiver is a passive one. In its modern form, this model was developed by the American mathematicians and scientists Claude Shannon and Warren Weaver in the late 1940s in their book, The Mathematical Theory of Communication. This model describes communication as a linear process and is called as the mother of all models. The communication models developed in the second phase were largely aimed at addressing some of the previous shortcomings, conceptualizing communication as a two-way process, the interaction between communicator and the receiver. It was best described by the American theorist of mass communication, Wilbur Schramm. Most importantly, this model accounts for how people interpret the message. Schramm argued that a person's background, experience, and knowledge are factors that impact interpretation. The third model sees communication as interaction in specific social cultural contents through shared meanings. This transactional model is the most dynamic of these communication models and implies that communication is achieved as people both send and receive messages. There are also levels of problems of communication. There are technical problem, how a channel causes a problem. Semantic problem is the meaning of message sent and received very different. And effectiveness problem, how effectively does the message cause reaction. The invention of the internet and social media greatly simplified the interaction of creative industry actors. However, part of the interaction is still the shadow activity. Established in recent decades, the communication model remains beneficial only to third parties, remaining problematic and dishonest to content creators and their audiences. The ability to change this situation appears with the proliferation of new technologies such as blockchain and NFTs. So what is an NFT? I guess many of you know, but I will briefly describe for those who are not completely familiar with them. Adjective non-fungible is usually used in economics to denote the possession of unique items and to describe things that cannot be replaced by others because they have a set of exceptional properties. A token as a unit of account is a record on the distributed ledger that is controlled by a computer algorithm of a smart contract in which the values of the balances of token holders are recorded, making it possible to transfer them from one wallet to another. So the term NFT refers to crypto assets that represent intangible digital files such as images, audio, video, in-game collectibles, and other creative products. In 2021, you all probably saw this NFT hype as the market and the ecosystem grew at an unprecedented rate. And now the global NFT market is expected to grow from $14 billion in 2021 to $21 billion in 2022 at a compound annual growth rate of 52%. Here you can see the main industry players by categories. The main types of non-fungible tokens are art, collectibles, gaming, metaverses, sports, utilities, and others. Art is the most common use case for NFTs. Sensational high-profile auctions of NFTs linked to digital art have received considerable public attention recently. The most expensive sales hit the headlines as they fetched millions. In 2022, the most expensive art NFT with a price for about $92 million was the work Merge by a pseudonymous digital artist named Pak. And Beeple's Everyday is now the second most expensive NFT with a price of about $69 billion. The most visited and used platform for hosting NFTs is OpenSea Mass Marketplace, a universal platform that allows users to trade NFTs, create them, view data on them, and check statistics. One of the reasons it is so popular as it is self-service based and not created like, for example, Nft Gateway or Super Rare. Music NFT also have a large devoted community and are on the way to adoption. One of the biggest decentralized music platforms is Audios, with about 12 million monthly users. There are metaverses, are networks of 3D virtual worlds focused on social connections, where users can create content and interact with one another. Some of them organize regular events for users. For example, CryptoVoxels, the first blockchain-based virtual world, has several art galleries where users can buy art in form of NFTs. So in a nutshell, the main benefits of the blockchain technology are as follows. Each NFT is unique and limited in quantity, as well as not replaceable with similar tokens. Ownership records are stored on the blockchain. Every NFT has an owner, and this is of public record. Content creators can access global market, easily reach to collectors and the community of like-minded people. And due to the advantages of the blockchain technology, content creators can claim royalties directly. The advantages NFTs propose for changing the current communication paradigm in social fields and hence in creative industries have already manifested themselves, locally transforming an indirectly hierarchical model. First and foremost, NFTs have created the possibility to eliminate intermediaries from the communication process, allowing content creators to connect directly to their audience. There are no more third parties in face of large distributors, labels, art portals, restricting the rights of content creators of digital goods. Artists just upload their content to the NFT platform, mint tokens, and choose a selling method. It could be a fixed price auction or an option or auction, and NFTs create the environment to direct communication between artists and their potential customers. Only NFT marketplace plays the role of communication mediator. Also, with NFTs, artists have now an opportunity to honestly monetize their work, as it is now possible to automatically pay royalties fairly distributed in accordance with the contribution to the creative process of each of the participants. Due to the blockchain technology, each actor can now see the exact time of creation of each digital object and the number of interactions with it, what income it brings, and who gets what percentage, which makes communication across industries direct and potentially fair. NFTs open up new monetization opportunities for artists. If in traditional art world, content creators usually didn't receive a percentage of secondary sales, thanks to NFTs today, digital artists can receive them in a fully automated way. What's more, blockchain platforms are designed to make the experience interactive and profitable not only for artists but for the audience as well, by offering all kinds of incentives, for example, for compiling personalized collections, contributing to increasing the database of artists, venues, or events. These improvements are to lead to a more diverse and transparent industry. However, despite the apparent advantages of NFT solutions, it is still difficult not to pay attention to several problems. As for the audience and consumers, it is still more common to use familiar major services, as well as for the majority of non-techie artists. For example, to use Spotify instead of audios to listen to music. There are also still no official public registers of copyright and no global standards of licenses, since different rules applies in different regions. The problem of NFT storage still remains. It is expensive to store NFT on the blockchain, so they are usually stored in distributed file systems like Airweave or IPFS, or even on centralized ones, so any NFT can be potentially manipulated. It is still difficult, there is still difficulty in assessing the uniqueness and understanding how many copies exist, as well as difficulty in finding the original owner of the NFT. Copyright protection issues are rising more and more often when uploading content to an open, non-curated platform. Now stop wondering that absolutely any media file can be sold on your behalf, no matter if it's a selfie taken a few seconds ago or a masterpiece of a well-known artist. There are also some environmental concerns, as the majority of NFT platforms are Ethereum-based, which uses proof-of-work algorithm and consumes a lot of energy. and difficulty in determining the value of the NFT. All these problems still exist, and researchers and engineers are puzzling over their solutions. Some known solutions are Ethereum transition to proof of stake to eliminate sustainability problem, and for example, crypto biometrics to solve the originality and ownership problem by creating biometric identifiers that can be used as an option for user authorization, which are developing by Humanoid project, for example. Well, that's it. Thank you.
Any questions? In general, can you please describe us like your background in NFTs? Like what exactly do you do with Paradigm, etc.?
I'm a researcher at Paradigm, so in NFTs, I use NFT platforms as an artist, so I was involved in the process of creating, minting NFTs.
Okay.
And researching the space, not only for Paradigm, but for my needs.
Yeah, I see. And are there any links to the stuff that you've created? So maybe we can...
Links, you can see me by this username everywhere.
Okay, so we'll probably find a way to share the presentations of our speakers with you so that you've got access to all the materials, and you can find the handle of Sasha over there, so please subscribe, follow, etc. Yeah, we probably need the microphone for this.
Hi, thanks for your talk. Alex here. What's your take on NFTs, not only as an image, but maybe audio, video, other mediums? So are they harder to create? Where do you see the future there? In not only images, graphics, but audio and, yeah, animated.
Okay, thank you for your question. So I think if you're an artist, it is not hard for you to create an audio or MP3, and to mint a token on NFT platform is really easy without any, experience in computing experience.
Okay, no, I shouldn't probably.
There are a few platforms that trade audio NFTs, and the majority of the mass marketplaces also trade them. Thank you.
Okay.
So I was wondering, thinking about what's next in NFTs, what are your thoughts on dynamic NFTs?
Sorry, can you repeat the question?
Like dynamic NFTs, I was wondering, like, what do you think about where dynamic NFTs are going, and like what's adoption looking like there?
I think it's the point of further research, but I guess we'll have a big future.
Okay, thank you.
Thank you.
Yeah, one moment, please, because we need the people on the live stream to be able to hear the questions.
You touched upon the topic of NFT fingerprinting to go through the provenance and all of that. Can you elaborate a bit more on that?
Sorry, can you repeat?
Sorry. You touched upon the topic of NFT fingerprinting.
Fingerprinting?
Like to look at the provenance of an NFT to identify who owns it, who does it, and how does it go, or watermarking or something like that.
Sorry, I don't get it.
It's okay.
Okay.
Yeah.
So, anyone?
Who's next?
I'm speaking next. I don't have a question. Sorry.
I'm asking about the questions. Any? Then we can move on.
Thank you very much for the presentation. And the next one, yep. So I have to prepare technically a little bit to what we're about to present. One moment. Stage 1. So next up is Lewis. It's probably better if you introduce yourself. Yeah. And we can present with like, come on, yeah, here we go.
Hey everybody, is this one on?
Yeah, it should be. What's the problem with him? We can probably use the other one that we've been using for the, yeah. Does this one work? Okay.
Test, GM, yeah, works. GM, everybody. Today I'm going to present to you Web3's automation protocol. I'm Louis, I'm founder and legendary member at Gelato. You might also find me as Git pusher on Telegram and Twitter. So let's start with an example contract here. Some of you might be, I think now this one is off again. Oh yeah, now it works. So some of you might be smart contract developers here. And this is a very simple contract. It's auto token payout. So let's explain Gelato or the need for Gelato by the example of this very simple smart contract. Say you have children, the receivers, and you want to pay them lunch money once every day. Say you want to pay them 10 Shiba Inu every day to buy some lunch somewhere. Now, the problem is that the smart contract itself cannot automatically pay out your children. So you would have to go and click a button every day to pay each of them their lunch money. So smart contracts are lazy. They only define certain logic and states, and the logic only gets triggered after an EOA, like an externally owned account, sends a transaction to them. So if no one actually sends a transaction to the smart contract, nothing will happen. So I think there's some common misbelief that smart contracts are like super smart and they automate everything by themselves, but actually at the end of the day, there's always a human or a bot who sends a transaction to trigger the code and execute some function on a smart contract. Smart contracts cannot self-execute, they cannot execute conditionally or recurringly, and this is very different to Web 2 applications like JavaScript servers, Node.js servers that run in infinite loops and can respond to incoming requests for always, basically, right? A smart contract cannot do that. So how do we automate with them? Well, Ethereum doesn't support automation. Ethereum doesn't support conditional or recurring executions. And the same goes for any other EVM-compatible chain or blockchain, for that matter. The reason why that's not supported as part of the execution model is because of gas limits. So in a blockchain, you want to be able to sync a network of nodes on a state transition in a very short amount of time. And this is a global distributed network of nodes. So basically, you have to form a block, and everything inside of this block has to be synchronous. You cannot basically have arbitrary code execution. The execution has to be finite, and that's why you have to define a gas limit. And the gas limit corresponds to computational units. And once your gas is used up in a smart contract, you're charged for it, your transaction is included in the block, the miner gets their money, and the block is done. You can't do anything else after that. So that's why we can't have things like set interval in JavaScript, or I don't know what programming language you use, but you can't have these basically web server loops that you would be used to from Web 2 development. Now, there are some people that are maybe like heavy, like Solana fans or something, and they're a big fan of beefy nodes, and they might say, hey, but why don't we just let Ethereum clients, miners, or full nodes simply, monitor networks for these conditions, for everybody's conditions, and then automate tasks for them as part of the block creation? Well, this would make those nodes computationally super expensive, even more expensive than they already are. And at Ethereum, at least, the ideal we have is that everybody should be able to run one of these nodes by themselves one of these days. And believe me, like running a Gelato node is already quite computationally expensive. We have a DevOps guy here who can prove that to you. He's in the crowd, so yeah, if you want to talk to him about that, it's not easy. So yeah, probably not a good place to put it on the Ethereum client itself. That's why for recurring transaction execution, for smart contract automation, you do need an off-chain external network. In Web 2, automation is very common. So there's cron jobs for Linux kernels, and there's cloud-based job schedulers. You're probably using some app that is completely automated in Web 2 every day, like your messenger apps, all the software as a service application. They all have automations, and they're all using frameworks like AWS Lambda or some other APIs. So why can't smart contract developers simply just also use AWS Lambda or whatever, their own scripting to automate their smart contracts? Well, smart contracts and blockchains can be a bit of a pain in the butt, to be honest. There's a lot of things that can go wrong at any time. So first of all, what do we want the system to do, right? We want it to listen to events. We want to check if they're executable every block. Then if we want to write our own script to automate our own smart contracts, we have to put our private key on a server somewhere, make sure that it always has enough ETH on there to execute all the automations we want to execute. Maybe if you're just automating for yourself, that's not such a big issue, but if you want to automate for like a multi-user application, you might have some pretty big ETH balances on there, unfortunately, because gas is expensive on Ethereum. So that also gives you like this sort of security risk. You know, you have to put a lot of funds on a key that's on a server. You have to get really good at like security operations for that to be safe. And then there's nasty things like chain reorgs, especially on like Polygon. They can be really deep. BSC, don't even get me started on that. I've seen reorgs there that are like 200 blocks deep. So a reorg is basically when your transaction gets included and you think it's included, but then the chain somehow moves to another chain and it's not included anymore. If you run a programmatic application that is supposed to track of what task has been executed over time, you need to have like a final result, right? So to deal with reorgs is really hard. You have to add a bunch of code to your application to make sure you do that properly. You have to simulate transactions before you send them in order to make sure that they don't revert. Otherwise, you're paying costs of the network for basically a non-execution. You have to handle with all these RPC unresponsiveness. Like, you know, Infura has been down in the past. So how do you handle with that? If you want to guarantee your users 100% uptime, then you have to add multi-chain support to also be available on every chain. You have to take care of efficient gas price estimation. You have to take care of resubmissions of transactions when they get stuck. It's a pain. So I think serverless is a great model of the last 10 years, and I think we can also have serverless applications on Ethereum. So basically, if you don't have serverless applications, if you don't have Gelato Network, then it's very time intensive to build a system and maintain it from scratch to support automation in your application. It creates a lot of overhead. You need like a dedicated DevOps team to basically ensure 100% uptime. It's very hard to guarantee this uptime. And you have to also do monitoring, you have to execute multiple jobs, and it gets exponentially more complex the more networks you add to it. And even if you achieve that, even if you are that 10x engineer, at the end of the day, you are then the single point of failure of your whole application. And probably in decentralized applications, you don't want to build applications where everything relies on your script somewhere on Heroku or wherever you deploy, right? So we do need a Web3 job scheduling solution for everybody. And that's basically Gelato. We started Gelato 3 years ago in 2019. And we had this vision to become Web3's automation protocol. And basically, it's still the same vision today. We saw this future, and it's really developing now. There's more and more automated applications. If you think about limit orders, if you think about auto-compounding of yields, Yearn is a great project which also has automation built in, right? And there's so many projects using us today already, and we see it growing every day, that it's pretty clear that actually this vision of needing a separate external protocol to automate smart contracts is for real. So Gelato works by basically having job schedulers and resolvers. The resolver is the part that you as a smart contract developer would need to write yourself in order to integrate with the protocol. And a job scheduler is just either an on-chain smart contract or an API that you can submit your tasks to, and the resolver will tell the Gelato network when your task is executable and what payload to execute it with. So Gelato then under the hood is just a bunch of clients that people can run. They have event listeners to listen to the events that you define that they should react to. They have checkers to check certain conditions that you can define. Like for example, for a limit order, is the price of that user's limit order reached on Uniswap? If so, then please execute it. And then you have the executors, which are very, very specialized software modules to get thousands of transactions mined reliably on chain in like a reasonable amount of time. So yeah, the client is quite heavy, and actually we were working on our private beta, and we will release this beta this summer. It will be the first stable release of this client, and we will onboard more node operators to the network and grow it from there. So the benefits of using Gelato is that you don't need to self-host servers on AWS or other cloud providers. You have these really cool RPC aggregation and multiple fallback methods, so you never rely on just Infura or one RPC only. Basically, these bots aggregate all of them for you. Some of these bots even run their own nodes. I know that the Gelato bot, for example, runs BSC nodes, Polygon nodes, Ethereum nodes, all of that. And it has multi-chain support. It works on all the most popular EVM-compatible networks. And there's also no single point of failure. So the protocol is open, executors can join it. We have a gel token. Soon we will release staking of that token. So anybody with stake can join. At the moment it's still a permissioned whitelist, but we want to move to a more open model with this token. And yeah, there's reliable transaction relaying. The transaction always gets fast, gets mined fast. And you don't need to self-manage any of the private keys anymore on your servers. The whole thing catches reorgs for you. You don't have to worry about that pain. And what's also really cool and what's like the original vision of Gelato is that bots come together and they are actually coordinated in a consensus network to avoid them racing each other to execute your tasks. So an old system like MakerDAO, for example, actually had an open keeper system. And there basically the idea is that anybody that wants to liquidate a Maker vault can do so. But what ends up happening is that all of these bots are trying to get the penalty. They're all racing each other. There's like, I don't know, maybe 10 of them or something. And only one of them wins. It's a winner takes all. And all the others have their reverted transactions. They have huge costs. So the whole system bleeds so much value to the miner, it's not really sustainable. You need a protocol to coordinate these bots efficiently, to tell them, now it's your turn to execute this transaction, now it's your turn, now it's your turn. And that's basically what we've built, a fully parallelized algorithm to coordinate bots in the network. So yeah, let's talk about some products, some of the bigger ones that Gelato has shipped. So GUni is an automated liquidity management platform, which is actually an application in and of itself. It started out as a pilot project, so we're currently spinning it out into its own project. It's not infrastructure, it's just like an application on top of Uniswap, but it's really cool for Uniswap v3, automated liquidity management. Then Gelato Ops is really like the core general framework that developers should give a try. It has a nice UI. It's a bit like GitHub Actions if you think about it. And you can go there and basically automate any smart contract. And then we have the multi-chain relay API, which is used by bridges to just relay transactions in real time across networks. So yeah, Gelato Ops works like this. You basically can define a contract that you want to automate. For example, a vault that you want to harvest. Then you can define, like in the simple case, you can define, okay, let's define a time interval. I want to call this harvest function every 3 days. You create the task on the UI and it's done. Every 3 days your vault will get harvested, and you can imagine this with any smart contract. The logic you can define as a developer in your resolver is arbitrary. Anything you want automated, you can automate with this very simple UI and just by deploying your own resolver. If you need help doing that, there's documentation, and also we are more than happy to help you in our Telegram. So we have some cool jobs live today already. For example, a lot of people use Gelato Ops to rebase algorithmic stablecoins. I know that on Phantom there's a lot of stuff going on there. There's compounding fees and yield farming vaults, and people also use this to auto top up their accounts. Maybe you even run a bot yourself and you deplete the balance there, and you want to use Gelato to just automatically top up the balance from like some secure multisig or something. And then Maker, for example, uses this to update their debt ceilings periodically. Someone built an Aavegotchi petting service, which I think was really cool. So you can also automate gaming, NFTs, and all of this. Yeah, and distributing convex rewards, redeeming Olympus bonds, and claiming weekly staking rewards on synthetics are some of the things we've seen. but there's more added every day. Some of these use cases really we never thought of that are built on top of Gelato Ops. And the cool thing is you don't even have to, it's permissionless. You don't have to talk to us. You can just deploy your resolver, use this UI, and just start the automation. Sometimes we see some new transactions on the network. We never talk to the people that automate them. The multi-chain relay API is basically for bridges, for games or NFT platforms that want to support gasless transactions for their users. And general bot operators. So if you have a relay component in your application, then basically you can replace it with Gelato's relay API so that it's serverless. You don't have to run that server anymore. You can trust on a network of nodes to do it. You have all the benefits. It's very scalable. You can, for example, offer your users to pay in your own token or any ERC20 instead of ETH or Matic or whatever. And it works on all the popular EVM networks. And yeah, so some cool use cases, for example, would be user onboarding for games. Your users don't need a wallet, they don't need to go to an exchange to buy some networks token to start playing. They can, if you integrate this multi-chain relay API, they can get started by like submitting signatures to off-chain to the network, and then some bot on the network will do the transactions for them if the developer is willing to pay for the user's transactions, which many developers are these days, I think. So yeah, a very simple, quick snapshot of the API. It's you just specify the chain, the destination address of the contract, the payload, the token address you want to pay with, the fee, and bam, your transaction gets mined on this chain in a very reliable and quick manner. So GUni, that's the automated liquidity management, definitely deserves mention here. It is its own project now, but it started as inside Gelato, and what it enables you to do is to automatically compound the fees you earn in a Uniswap v3 pool. Uniswap doesn't support that natively for LPs. And it also automatically, like in the future, we will do automatic rebalancing around the price, so you can have very efficient concentrated liquidity and maximize your yield. And that's also being heavily used by a lot of projects already. Actually, it amassed a TVL of half a billion, depends on the price, of course, of the tokens. And yeah, so this was already announced. We spun this project out into Arrakis. You should, if you like Uniswap v3 automation, you should visit Arrakis to see what we did there. So today there's a bunch of projects using us already. This wasn't updated. I think we started in 2019. Our first version was out in 2020. And since then, Spooky Swap on Phantom, for example, Spirit Swap, PancakeSwap on Binance Smart Chain, on Ethereum, Maker uses us, Aave has used us, Beefy Finance. A lot of cool dApps already use us for automation. So if you want to join the Gelato gang, if you want to build automated dApps yourself, you will be in good hands. And we're more than happy to welcome you to the community and help you build these apps. So yeah, if you want to reach out, send me an email, Luis@GelatoDigital. Might be wiser to send it to hi@GelatoDigital. I've been a bit slow with my emails recently, but otherwise just jump into our Telegram on gelato.network. You will find all the links to our social. Thanks a lot for listening, and yeah, let's build some automated dApps together.
Thank you very much. I've got a question of my own. So, what about front-run protection for jobs?
Very good that you mentioned it. Yeah, actually that's not on the slides. There are some cool things that are not on the slides. On mainnet, we already support, like all our transactions go through Flashbots. So we were quite close with the Flashbots team. And the problem is that Flashbots doesn't exist on every chain yet. So as soon as it's rolled out on other chains, we will use it by default. I think like I came to this realization myself. I've been in Ethereum for a long time, and at first I thought something like Flashbots is not so great because it's like using private relayers to the miners and so on. It seemed a bit weird. But now that I understand MEV and so on, going through a public mempool is just crazy. Even for like some little things, we never thought there would be MEV, but we got front run on like some relay transactions and so on. So yeah, we're using Flashbots on mainnet, and on other chains we have to design the application in certain ways that they don't emit any MEV during the execution.
Thank you very much. Any more questions?
Hey, which chains are supported right now by Gelato?
We are on Ethereum, Polygon, BSC or BNB chain now, Phantom, Avalanche, all the EVM chains, Boba, Optimism, Arbitrum, Gnosis Chain. Yeah, and I think we are deploying to Starknet soon, and also looking into Solana and so on.
And what about Solana? So, is it more complicated or not?
To be honest, I'm not an expert yet, so we'll see. But definitely people at Solana, I think they're more in the camp of, okay, these nodes can be quite beefy. I don't think the nodes would ever support like automation built in there as well, because that's just adding so much more complexity to them outside of the normal consensus protocol. So, but yeah, in any camp of people that think that a lot of people should run these nodes and that should be kind of lightweight, building something like Gelato into the core client is not really an option, I would say. So you will always need like this external middleware that we have built.
Okay, thank you.
Hi, and what about the gas fees? How can I set the gas fee? I've seen that you have the protocol fee, but I know that Flashbots, they take the separate fee, and you pay that fee directly to miner. And how can you set that fee? Because in fact, some people can front run you even in Flashbot private relay when they know that your transaction is scheduled for some time. They can set the lower fee than you set, and then basically front run you inside the private pool. How can you handle that?
Yeah, so just in general, front running is like not a huge issue for us in like the popular sense where you think about, I don't know, sandwich trades on Uniswap or something. Like all the applications we build are usually sort of front run protection in the protected in the application design. Like limit orders, for example, the amount of MEV you can extract is very minimal. So first of all, you have to start there. Your application should ideally be designed with MEV in mind and not be front runnable. There shouldn't be any MEV leaks to an arbitrary message sender, and that's how you can prevent anybody from sniping your transaction. And a lot of protocols already use Gelato like as the platform of their decentralized relayers, so they even have modifiers like only Gelato can call this function, and then nobody can snipe us in the mempool, only Gelato bots can. But to your question, you can specify a gas price. You would have to build that into your resolver and define like at least like a maximum gas price or a minimum gas price to be used. I think inside Flashbots, the point is that it's a sealed bid auction, right? It's private. So, I mean, the gas you pay actually also goes directly to the miner. So we're sending transactions via Flashbots that don't have this block.coinbase, whatever. They just pay normal gas fees. Gas fees are also MEV, right? So yeah, we didn't have any issues there. Yeah, good question. So there is a protocol fee. Gelato actually has been a revenue generating protocol from day one, and usually it's around 10% on top of the normal transaction fee. So if you schedule, for example, some automated compounding or something, then it would be, and that would normally cost you $1. With Gelato, it will cost you $1.10 for the service. Now I have trouble with the acoustics.
Okay, and when the gas price in mainnet is 400 GWei and my transaction is set for 200 GWei max gas price, what happens when it is supposed to be sent but it can't be, it's waiting, or what?
These are very, very detailed questions, I have to say, but that's good. So yeah, I mean, if the mainnet gas price is 400 GWei and your transaction is at 200 GWei, then it simply it won't be sent to the network. But yeah, this requires some custom logic actually for gas price specification. You're right about that, yeah.
And do you have the tools to set this custom gas price in your Gelato network?
Yeah, actually the first use case we did was minting Qi gas tokens. That was before the EIP. Yeah, so that was also like you specified the gas price that you want, like a lower gas price to mint them, because that would give you some profit later on if the gas price goes up again. So yeah, we have built these things. To be honest, we haven't done so in a long time. And I know it's possible, but recently no one has requested it. But it's definitely possible. You can do it in the smart contract level, or like you could also specify it at the back end.
Thank you.
You mentioned that G-Unit allows automated rebalancing on Uniswap v3. I was curious, what kind of algorithm does it use to create a new price range for the LP position once price goes up?
Sure, you want the alpha. So, I mean, to be honest, I think part of the reason G-Uni is so successful, or I should say Arrakis now, it's called Arrakis now, is because we realized very early on that people get wrecked if you try to auto-rebalance them. They get absolutely wrecked. And the answer is there is currently at least no known formula or good algorithm to solve it. There's a bunch of really smart people working on this, Arrakis included. But yeah, actually, at the moment, all of the G-Uni pools, they still just auto-compound the fee. We switched off the auto-rebalancing a while ago because it wasn't too good for the users. But now we have a research team working on these algorithms, but I actually don't know the exact algorithms, and I'm not even sure if they will be like published or not, but there's like a team working on this to ship this to G-Uni users. All right, I think that's a wrap.
Yeah, thank you very much for your speech.
Thank you very much.
Really useful and probably a really good tool for everyone to use if you need some sort of automation, because I know so many people who've got like 10 tabs open just to claim the rewards every day.
Yeah, don't do that. Use Gelato.
Yeah, exactly.
You want to save some time there.
Thank you. Okay, so I think we're supposed to have a small break right now, so we are to reconvene here, I think, in 15 minutes?
In 30 minutes.
In 30 minutes, so
Yes.
please come back.
At 11:30.
Thank you. Okay, guys. So, oh yeah. We are about to start once again, so just waiting for the presentation from our speaker. So.
Pam pam. We're having some technical reset right now for 2 more minutes.
Yeah, sure. 2 or 3. Cool. How do I, like, is there a projector?
Yeah, it is. Just switch it.
All right. Sorry for keep you waiting, guys. Stuff happens, right? So basically, I'm not Nether, although I might look as big as him. But he had to catch a flight. So anyways, we'll be discussing about the graph. Yesterday, we had a live demo as to how do we create a subgraph. And today, we'll be discussing what's the mechanism, how to index blockchains in the most decentralized ways, right? So it's like we normally say that the graph, in general, as an analogy, is like what Google does to Web2, is what the graph does to Web3, right? But we'll understand what's the nuances that we'll have to make sure for the indexing in Web3 to happen, right? It has to be decentralized, plus there are lots of call handlers to be handled and 100 different things. So we'll be understanding technically how the graph is able to index such a complex structure like a blockchain, which has a linked list, a block in it, and different transactions to actually make things work, and of course, in the most decentralized fashion. All right? I hope you have fun. So basically, it's a very well saying that currently we have built Ethereum, right? And we are deploying decentralized applications on Ethereum and having a lot of fun. But the biggest problem is that currently, with just 0.65% of the world population using Web3, we are still broke, right? What that means is that even if there is a short, increment in the population of people using Web3, infrastructure starts breaking. And the reason behind that is that we have not done things the right way. Most probably what we have done is used Ethereum as an API aggregator for us and called ourselves a decentralized application. But that's not how it works. A decentralized application is not just decentralized by making your application deploy on something like Ethereum or any of these blockchains. There has to be no single point of failures to make a decentralized application a decentralized application. What that means is that whatever information is coming inside that particular blockchain has to be in a decentralized fashion. Whatever information is going outside from that blockchain has to be in a decentralized fashion. That's what the graph does. Whatever what we call as notification that's pushed to your particular application as a mobile thing has to happen in a decentralized fashion. Whatever hosting domains, everything that you're doing has to happen in a decentralized fashion, and that's why we cannot host our Ethereum decentralized applications on centralized stuff. I know it is tough to make a Web3 stack of its own, but that's what we require, right? I personally believe that eventually Web3 will be the new internet, but if we just compare the statistics, right now only 0.65% of the world uses Web3, while 70% of the world uses internet, right? So if we have to reach that kind of mass adoption, we'll have to make these kind of conscious choices so that we are fault-proof, as well as making the internet happen in the most decentralized, sufficient way possible. So as of now, there are lots and lots of single points of failures that exist, and that's why the Web3 stack, the infrastructure layer of Web3 is being built. Although it's a little unfortunate that we had Ethereum and we had AWS S2 and things like that to start off things, but I think we'll eventually have to migrate our infrastructure knowledge, our building knowledge, our stack knowledge. And that's why the graph is developing something which is a part of the Web3 stack and is used to index blockchains. What that means is that whatever information you store inside a particular blockchain, that has to be posted outside to the world, right? In a decentralized fashion. And that's for what we use the graph is. You create a subgraph of your particular application, right? Put it on a decentralized graph network, get the information outside via GraphQL API, and use that to put in the front end. That is what the graph does. All right, we'll discuss a little detailing of how this happens and why is it decentralized, but I'll start with this. So as of now, what people do in current dApp architecture is that they have centralized entities known as servers, which are either indexing a particular application and then putting things outside to the world. And that's not something that we want, right? Again, if a server fails, everything fails. In Web 2, why these things still work is, first of all, it's centralized, and secondly, it is being run by data centers in the world. While it's just 3 or 4 people with a S2 server, which are running it in a Web 3 world. When mass adoption happens, these servers start failing, and then we are like, oh, we are still early, we'll have to wait, no, that's not how it is. That's why, this is a wrong way to index a blockchain. Second way to index a blockchain, which is not centralized, but it's super slow, is that you start tracking every event that happens in a blockchain. You keep a check of whatever is happening in a particular blockchain and get that to a particular application. So if I want to know that, okay, 10 days ago, I did a trade on Uniswap and converted my USDT to Ethereum, and I run a program like this, it will take me 5 more days to get the result, right? Again, that's not the correct way of having a UI in those sense, although it is decentralized, but, right, if I start opening a page today and it opens after 5 days, I'm sure it will be of very less use to me. So that's, again, a wrong way to do it. And again, it looks like this, as shabby as it can be. If we directly, query a particular blockchain and try to get information that we want. Not the correct way, not the best use, and always we'll be rupturing the RPC like anything. Making 100 different calls for a single transaction. Not the most proficient way to making things happen. Right? And that is the reason we have something like the graph. The graph indexes blockchain like no other. You create subgraphs for your particular application, right? Put it on a decentralized network, currently only supporting Ethereum, and it will be indexed by 150 odd indexes that we have on the network. This not just gives you decentralization, but also makes your application indexable, and that's what we want right now, right? In Web 2, we do more reads than we do writes, right? I gave this example that on Instagram, for example, how many pictures do we post? It's like 1 in thousands, right? I mean, 1 in 10 days. If somebody looks like me, maybe 1 in 100 days, right? But how many reads do we do? We do it every day, 1,000 times. The world right now of blockchain is focusing on doing the layer 2 stuff, doing the right stuff on the blockchain. And that is only possible because the read is happening efficiently using the graph. If the reads start failing, we'll have to scale them up, and that's not possible via a server. We'll have to use the graph to make the reads 100x more scalable than we are trying to do for layer 2s with the modular structures and stuff like that. And that's why the graph has eventually become an essential part of the Web3 stack to index any blockchain. If you are making a decentralized application, you will have to use the graph to get your blockchain indexed and putting things outside to the world. So this is the architecture of the graph, and this is how it looks like. I don't want to go in details, but I'll just tell you in a very, very short, simple manner that, okay, you write a smart contract, it has events. The events are seen by a graph node. They actually listen to the events that for your particular smart contract and store it in a database, right? And that database is thoroughly processed so that you can query that database using GraphQL APIs, all right? I know it might be a little hard to take in, but do click a photo of this. This is a marvelous architecture through which we have been able to achieve scale like no other. And that's why, because of this architecture, this is how, from something like this, we have been able to query a blockchain just like this. Beautiful, simple, elegant as it can be. Right? So, as I told you, indexing Web 2 is like, okay, we have Google, we need to scrape every part of the data in the Google, get the information out, and put that to the world. That is possible in Web 2 because there is a central entity doing that. It has all the rights to do whatever it wants. If it wants to index something, it will. If it does not want to, it will not. But because of this, we lose the autonomy to the internet, right? And that's why we need something which is decentralizing the indexing layer as well. We just don't want to decentralize the information going inside layer. We also want to decentralize the information coming outside layer. Otherwise, what will happen is that we are back to what we were, centralization, censorship, and all the 100 problems that exist because of that, right? So as of now, just to solve that confusion, the graph has a hosted service and the graph network. The hosted service is a SaaS product. It was the first product market fit to make any decentralized application happen, but definitely it was a SaaS. But now the graph has the graph network, right, which is currently live on Ethereum, and you can index a blockchain in a decentralized fashion using the graph network if you use Ethereum right now. The graph currently powers most of the DeFi as well as NFT architecture that exists in the world. And I told you, it is not easy to create an indexer of your own, right? And that's why you have to use something like the graph, which is taking care of the indexing bit with the graph node created, with the whole architecture of the 150 indexers, 1,000 delegators, 600 odd curators, to making your indexing, your particular subgraph indexing possible. And that's why we have something like the graph. The graph, this particular page, you all might have seen. What is it? Anybody? This is Uniswap info page. And if you go to the networking part, you will see it is api.thegraph.com/subgraph/Uniswap v3, which powers all the information that is coming to this particular page. So that's the importance of the graph in a Web3 stack. All right? So this is a great way to actually understand how it works, right? In a particular block, there are hundreds of transactions happening. But let's say you have deployed a smart contract which only caters to the green part, right? You have a Uniswap smart contract that you have deployed, right? And all the Uniswap transactions that are happening are only the green bit. The others are other like, application transactions that are happening. And you just want the green bit, right? For that, you have to use the graph, so that graph node using the YAML file that you create can cater to this green part, segregate everything else, put it in the best data base possible, and query it to your particular API using the GraphQL, to your particular front end using the GraphQL API. So this is most about it. I know when you're creating a Web3 stack, there are different challenges that occur. Firstly, scaling, of course, right? Indexing a subgraph, which is as heavy as Uniswap, QuickSwap, all these. Indexing something which is as fast as Polygon or Phantom with the 1 second block time is really tough. Because just imagine, every event that is fired, you have to get the graph node information and then put it outside. It is very quick, 1 second thing, right? While in Ethereum, you are given 7 seconds to process that data and put that stuff outside. So we have identified that definitely indexing performance is something that we have to work on. If it takes a QuickSwap subgraph to index 10 days, we have developed a core team at the graph which has Streaming Fast, Figment, Agent Node, the company I represent, as well as the guild to making this happen. And for the same reason, we have been trying different architectures out to make it happen. And the R&D roadmap recently released, which definitely suggests how we will make it happen eventually. How will we index a blockchain which is as fast as using a centralized indexer, but with the power of decentralization, so that people don't have to give up their developer experience. They don't have to give up their convenience, and they don't have to give up performance for the name of decentralization. Decentralization is something that should happen in the backend. It should be very well pronounced, but it should only be shown as effects and not as something we capitalize on and create philosophies about. And that's why the graph is a product in making. We are live on 27 EVM chains, as well as the graph recently released a non-EVM chain integration with Near. And soon we are going to come up with Arweave, as well as Solana integration that Figment team is working on, as well as doing some data sourcing so that we can get off-chain data to the graph using something like, let's say, Ceramic. That's all from my side. I'm really sorry I was late, but I hope I could make you understand that if you are making a Web3 app, you have to use the Web3 stack. Thank you.
Thank you very much. I've got one question. So what about indexing testnets?
The graph indexes Rinkaby, as well as all the Ethereum testnets, as well as all the EVM chain testnets, like Polygon Mumbai, as well as Phantom testnet, as well as BSC testnet, which is Chapel. So yeah.
Do you have any problems with like Phantom, etc.? Because, so for example, if you can find the testnet NFT marketplace like on OpenSea, which works for Ethereum testnets as well as Mumbai, but for Phantom, there is no such tool.
It's more so like a Phantom chain decision to not have such kind of a thing. But the best part about creating a subgraph on the hosted services, that it's a free service. You can create it, make changes, use Mastic to do the testing, the unit testing, and still come out with things. So that's the reason why the graph is created such that if there are issues, you can always do something like grafting to have your subgraphs indexed all the time. I know, it's, as I told you, right, creating a layer 1 right now is one of the easiest things you can do. Just create one, have an economic model which is same as Ethereum, have a token, and boom. But if you're creating a Web3 stack, which really matters, if you are creating something which empowers Ethereum and all the infrastructure of Web3, you will have to do innovation. And that's what the graph has been doing, from the network economics to even doing state channel payments using something like Connect state channel payments, right? So, yeah.
Thank you very much. Any more questions?
All right, maybe it was too good.
Yeah, but I really like the speech. And I really want to use your service as well, probably for some NFT stuff on Phantom, because yeah, this is the niche that I see that's not occupied yet.
Definitely, definitely. And with the data source filing that is coming, you will be able to index the metadata as well as query that using full text search. So watch out.
Yeah, really good. Thank you very much.
And the next speech is from Josh from Uncurrent. He's coming. Can you help? Yes. And again, 2 minutes for setup.
He wants this one. Okay, let's try.
Thank you for coming. I just need 1 second to get set up here, and we'll go at noon. Yep, 1 second. I'm doing it now. Yeah, I know. Okay, yeah, yeah. Yeah, I had one. I have an adapter too. I wish I knew that was. Oh wait, what? I have a direct HDMI. Yeah, I have an HDMI. But it's on the other side. Okay, cool. All right, we're good to go. No, we're not. Yeah, we're good. Sweet. Thank you for coming. I'm going to go ahead and get started here. So my name is Josh Stein. I work with Anchor. I'm a developer advocate, and I'm going to be demoing one of our new features with the premium plan, which is our hybrid infrastructure. Yeah. So I guess first, what is Anchor? Anchor is a decentralized network of infrastructure, and we're aiming to do a few more things here going forward. So what is infrastructure? For us, it's compute power, networking, and storage. We provide nodes, archive data. We have an enhanced API that we're working on. And we also have a gaming SDK that just came out that's compatible with Unity and Unreal. We also have a multi-chain scanner at anchorscan.io. And we're also really trying to stay true to the community, and we have a community-first approach. We're releasing Anchor Learn here soon, and that's going to be some really good developer documentation. We're trying to bring the developer experience of Web 2 to Web 3, and in the spirit of decentralization, we're also working on Anchor DAO. So I'm going to show off some of the new feature today. It's called Anchor Hybrid Infrastructure. It's basically a way to control your gas usage to reduce any throttling or limitations you might run into with infrastructure and provide a backup network of nodes. So this will give you extra resiliency and security and basically pay-as-you-go pricing rather than paying for traffic that you might actually not use. I'm going to skip through this a little bit quickly just so I can get to the actual demo. But basically, you can deploy your own nodes on our network. You can also add nodes from other networks to our, basically aggregate to one endpoint. And this kind of reduces the need to outsource and lets you keep everything in one place. And then in case of anything going wrong, it allows you to basically have a backup plan in case anything goes down. So I'm going to just do the demo here because I don't have much time. So we have public RPCs here. They're free. Like you can go and copy the endpoint. Pretty simple, like rpc.anchor.com/ETH is our Ethereum endpoint, and you can send 1 million requests a day. So I guess if you're a developer, if you're building, it's a good way to get your dApp connected to the blockchain. We also have a premium plan that you will be able to access by connecting a wallet. I already have it on here, so I'm going to go ahead and verify that I have the plan. We're going to go into the premium plan here, and it's going to verify that I have staked Anchor token. For this demo, we're going to be using Ethereum, and basically, we have a load balancer for RPCs. So I have a quick node, or not quick node, an Infura and Alchemy endpoint set up. And I'm going to go ahead and copy those keys, and then we're going to send some requests to basically test out the... So yeah, I'm adding the endpoint right now. It's sending a batch request to verify that that endpoint actually exists. We're going to go ahead and copy a request from Postman and send that in the terminal. It's a curl, so that transaction just went through. So we should see a get balance request appear here on the dashboard of Alchemy. I'm going to go ahead and speed through this real quick, and we're going to copy the endpoint from Infura, and we're going to send a different request there after I add the endpoint. When this is loading in loading state right now, it's verifying that the endpoint is real and it actually works and that it exists. So now we have both of these endpoints on there. So we can see down here in the dashboard that we have, sorry. We're going to wait a second. Okay, yeah. The get balance request went through, so we can see that on the Alchemy endpoint. We're going to go ahead and delete this endpoint to simulate basically the network going down. And then we're going to run another request that should go through default. It'll skip the first endpoint and then go down to the second, which is Infura, and we'll see that reflected in the dashboard. So I'm sending another curl. It's a get blocked by number. So we see that go through, and then we're going to go ahead and check back in the Infura dashboard, and we should see that pop up in just a second here. This takes a little bit to show up, but as long as it didn't go into the, well, Alchemy's gone. But yeah, we should see that pop up here in a second. So this is a batch request. That was just to verify that the endpoint is real and it actually exists. And then last time I did this, it took like 3 or 4 minutes to show up in the dashboard, but it has gone through. So yeah, that was it. I don't have much time, so I don't want to stay on the stage too long. But yeah, thank you.
Thank you very much. And we are about to welcome our next guest for the presentation. And it's supposed to be Cortese. So.
Don't you want to ask for questions?
Oh yeah, are there any questions? And we might see this come through in a second here.
So for these little talks, we've got like 1-2 questions maximum. So you can go ahead and ask. Okay, probably no questions for now. Yeah, but cool infrastructure actually. So we are constantly having some issues in Phantom, our main chain for now.
Yeah.
And yeah, so we'll definitely try your services as well, because yeah, we need fallback scenarios.
Cool. Yeah. So this is basically a fallback scenario.
Great. Thank you very much.
Yeah. Thank you, everybody.
And the next speaker is supposed to be from Cortese, right?
Mike. Thank you. And we've got the presentation. Okay. It's not yours. So here is the presentation. Here we go.
That's not us either.
Oh, is it?
It's I think it's a
PNS. Okay.
No.
Yeah. We've lost it somewhere. Who was that actually? PNS?
Yeah.
Either PNS here. Okay. Do you have the link to it?
No. I think we sunk it by email.
But it's
not a drive, it's a PDF.
It's Patrick's laptop, so we'll see. Thankfully he's here.
Yeah, should be.
These, yeah?
No, that's the work.
Okay. Probably. Okay.
Should be like yesterday or something.
Yesterday? 29. Actually, it's not here. It's not.
Can you type Payout in there? Just the name. We're not Cortese.
Okay, good here. It's just. I'm not sure where to find it, so we've got the wrong presentation here.
That is wrong?
Yes, because it's the PNS and not.
Can you send it to me on Telegram, the correct one?
Okay, maybe you can that I use in the criteria are basically nodes.
Yeah, good question. No, you could run your own node, but essentially you can also eventually we would like people to be able to push their applications to a set of nodes, a fully decentralized set of nodes. So yeah. And yeah, initially our first product was more of a computational oracle, which is you send data and you receive data back without having a continuous flow, and the rollups take that a step further basically. So you can continuously update the state. Any other questions, or I think best to pop by the booth.
Yeah, sure. But maybe someone from the audience.
Yeah, it's a lot to take in, I think. I hope this raises some questions, though.
One moment.
So all the blockchains are actually optimizing data in different ways, and they are already very bad with speed. So how you guys will gonna solve that with full Linux OS on blockchain? Do you guys can give some hints on that?
Yeah, it's a good question. Well, everything is basically computed off-chain, right? So we don't put everything on the layer 1. It's only the endpoints that will be checkpointed and aggregated on top of Ethereum. It's similar to what other rollups do. The main advantage here is that we have this RISC-V based architecture, virtual machine that boots a Linux OS. And yeah, we're not running Linux directly on top of Ethereum. That would not work, right?
Thanks.
So probably no more questions for now. So, oh yeah, one more? No? Yeah.
Thank you. What are some examples of applications that are currently hosted on your platform? Or that you use it?
Yeah, good question. So we're still in alpha, so it's more like proof of concepts that we're developing. We recently launched a fully decentralized poker game on top of Cartesi. I think it was developed in C++. I'll have to check that, but that's just an example. You can use it, you can download it as well and play around with it. And yeah, we're working on a few other proof of concepts to also showcase what we can do. But our key priority right now is kind of finalizing the core technology. All right, thank you.
Thank you very much.
And the second speaker is from CoinMana, right? CoinMana.
Hello, everyone. So my name is Talal Tabba. I'm the CEO, one of the founders of CoinMina. We're a centralized exchange regulated by the Central Bank of Bahrain. I guess prior to CoinMina, I used to build products on Ethereum, built a wallet, Block Explorer, and a DeFi product called Tranche Finance. But the reality is, in the Middle East, all people wanted to do was buy ETH, buy Bitcoin, and basically speculate on shitcoins. No one really was interested in DeFi services or DeFi products in general. So we decided to, I guess, follow the product market fit and build what people want as kind of a Trojan horse into DeFi. And that's why my title today is All Roads Lead to DeFi. Because the reality is, people sitting in this room won't have an issue storing their private key or paying gas for a transaction. But the reality is, if you ask any retail user, the reality is very different from the world that we live in. People basically don't want accountability. They don't want to be liable for possibly losing their funds, no matter how efficient those DeFi services is, whether it's lending, borrowing, trading, or any other feature. So, as you can clearly tell, presentation is not ready, but we'll wing it. I guess one of the biggest differences is it's so much more efficient than centralized applications, and I think this example is definitely overused, but it's super relevant. If you think of, like, we're comparing Uniswap to Coinbase, which is technically a crypto company. If you wanted to compare Uniswap to something like the Dubai financial markets, when you actually, like, I tried to buy a stock in Dubai and I was shocked. That was like 2 years ago. And I had to fill out like a freaking physical application. And they had to mail me something. Here, this comparison shows Uniswap versus Coinbase. But if you try to compare it with traditional stock markets, it is insanely different. But I guess one of the topics that I like to talk about often is something called technology infrastructure inversion. And that's basically when a new technology comes out, it uses infrastructure that was there from the technology before it in order to reach people. And then once that new technology becomes important enough, you see that flip in technology infrastructure. So maybe what I said is a bit vague, so I'll give a couple of analogies to give it some context. Internet. I'm sure here everyone remembers when we used to use landlines to basically get internet across. Like, if someone picked up the phone at your house, your internet connection would drop. It was a shit way of getting internet across, but everyone had landlines. So, like, okay, how do we get internet to everyone? Yeah, we used outdated infrastructure to get this new technology across. That's why people use centralized exchanges today. Most people have bank accounts, debit cards, outdated financial infrastructure, but that's what's going to allow us to bring 100, 200, 500 million people into crypto. And then once you realize that, okay, shit, why am I using that outdated infrastructure in the first place? Then you'll see the infrastructure inversion. So I think cars is also a good example. When cars were first made, and they exported cars from the US to the UK, the UK had a requirement that someone had to like carry a red flag and walk in front of the car because the car was seen as a death machine, like it could kill people. And then slowly but surely, people realized, okay, cars are actually useful. You can get you from point A to point B way better than walking or a horse. Then we started seeing asphalt roads, and yeah, I guess the point that I'm trying to make here is, in 5 years' time, we will drop the outdated infrastructure. Like, as a centralized exchange, we have very high dependencies on outdated systems like SWIFT. For us, like someone deposits money in the UAE in dirhams, and we need to sell them ETH. Where the hell are we going to get that ETH? We need to get it from one of the liquidity providers who has accounts either in Silvergate or some other Web2/traditional infrastructure. So we have to depend on the SWIFT system, and sometimes wires get lost for days or weeks. So yeah, I guess going forward, you'll start sourcing that ETH or Bitcoin or other crypto locally. Yeah, don't worry, I won't stay longer. And I'm not going to keep everyone away from lunch, because I know that's ready. But yeah, I'm not going to talk about DeFi applications. I think everyone here is quite familiar with it. So how can I get involved? I guess one of the things that we're looking to do at CoinMina is allowing people to stake their ETH. You know, this is, for me, one of the most win-win situations out there. If you don't need liquidity, actually, even if you need it to be liquid, you can still do it. But it's the equivalent of putting dollars in your bank and not putting them to work. Because by holding Ethereum, you technically have the credit risk of Ethereum itself. So if Ethereum 2 doesn't really work out, then you're screwed anyway. Or we're all screwed anyway. So I guess the point that I'm trying to make here is you should definitely stake your ETH. And at CoinMina, we're planning on making that process extremely simple, where you can go from a dirham wire transfer into staked ETH. Cool. If any of you are UAE residents or live in the GCC, sign up on CoinMina and feel free to pass by our booth if you have any questions on how to get your money from the rest of the world into somewhere safe like Dubai. Thank you.
Thank you very much. Any questions? Everyone is probably filling in the application.
Yeah, I think it's, what is lunch is my question. Thank you.
Thank you.
The next speaker is from Syscoin.
Okay, my name is Nathan with Syscoin. I'm business development. Today I want to talk about proof of work in a roll-up environment. Syscoin was launched in 2014. It was originally decentralized eBay. We realized that that type of business application didn't really work for blockchains. So we went back to the drawing board and came up with a really unique architecture. We have two chains running in parallel, a UTXO and an EVM. The UTXO is merged with Bitcoin, recycling that hash rate and passing it to the EVM. And on the EVM side, we're running rollups. So essentially, we are pegging that rollup proof to the Bitcoin proof of work. We think this is a big deal because we see Bitcoin as the gold standard for security. For instance, proof of stake, the security in that type of consensus, is a measure of the level of collateral on the network. So in a proof of stake dominant world, where rollups are the dominant scaling type, we're going to see most chains posting their proof to Ethereum because it has the highest level of collateralization. We are offering an alternative product, which is extending the functionality of Bitcoin and allowing any EVM Geth type, Geth compliant application plug and play with our product. This has some really interesting implications because if you're in Bitcoin right now, your main method of DeFi is wrapping it and putting it in Ethereum. But it separates it from the proof of work, which is the most valuable aspect of Bitcoin. It's all that energy and effort that goes into verifying the validity of the chain. It's the difference between Bitcoin Cash and Bitcoin because the code bases are very similar, but the effort that goes into verifying all those transactions is very different. So we see ourselves as an agnostic, decentralized security layer for a roll-up dominated world. We also have some interesting symbiotic effects with Bitcoin because the Bitcoin proof of work is the security of Bitcoin is ultimately a function of the revenue that miners can generate. And when you are merge mining Syscoin on top of Bitcoin, you are generating more profit as a miner and recycling that hash rate and getting extra function out of it. That's kind of the product. I really want to open up to Q&A because I know there's a lot of nuance here and a lot of weird edge cases and implications, and I want to take this time to kind of answer questions anyone in the crowd might have.
Yeah, basically. I think people are already getting a bit tired, so that's why we don't have any more questions. But anyway, we've got like 2 more presentations to go, then lunch, and yeah, an interesting product actually. So I really have to read up a lot and probably visit you on the booth.
Okay, so we have a booth in the back. Our CTO will be here in 30 minutes. We love talking tech. Please come by. We're open to working with anyone. We're agnostic. We're here for the tech. We're here for the cause. We would love to work with you guys. Thank you.
Thank you very much.
Yeah, and we're inviting 1 inch.
One, two. Thanks. So hi everyone, my name is Sergey, I'm co-founder of 1inch Network. 1inch Network is a single point of entry for DeFi space. We started with the aggregation of decentralized exchanges back in 2019 on Ethereum hackathon in New York. It was just a hackathon idea what I came together with Anton Bukov, my co-founder, to just improve the space, to improve the usability of decentralized finances. Actually, back into the early days, there was no DeFi yet, the naming itself. So, so what we did, we just came to the idea to split the source amount, which, for example, 1,000 ETH, split in small pieces by using algorithm and swapping on different exchanges in the same time. We started with simple algorithm which just split it. Nowadays, we have very complex algorithm which use multiple market depths among a lot of liquidity sources. On Ethereum, we have more than 100 protocols integrated with more than 25,000 smart contracts, which we aggregate in just 90 milliseconds. Yeah. This is great work of my great team. We are more than 100 people around the globe already building on this open decentralized network. So we started with 1inch aggregation protocol. We have 1inch liquidity protocol. It was a small invention for 2020 in June. We came to the idea how to protect the people from sandwich attacks. So I still don't understand why Uniswap didn't implement it yet, but still hope that Hayden Adams will do that. We didn't push this liquidity protocol further after the Uniswap v3 release because, like this, Uniswap v3 has better, more efficient approach with the range positions. We have limit order protocols, a highly efficient order book protocol. You are familiar with maybe 0x protocol. It's more efficient. It's use small amount of gas and it's extendable. So. You can easily build on extension on top of this and avoiding huge efforts of security audits. We have, of course, also our 1inch wallet, DeFi wallet, soon also released on Android, right now on iOS. It's a highly efficient DeFi wallet right now there. And we have a 1inch DAO as well. With the 1inch token, you can participate in the DAO and yeah. Push proposals and everything. So here, why we are here? I and Anton, we were traveling around the globe from 2018 December to early 2020. We were participating on almost every hackathon out there, which was about blockchain. So we participate on 17 hackathons. So we are hackers. We know how it is to build something on a hackathon, how to ship in just 2 nights, like we did it with a 1inch MVP. Over 2 nights we built without no sleep a first MVP, and it was already working in production. So why we are here, we would like onboard more developers, of course, to building on 1inch network, or also for the DeFi. And we would like to give back what we didn't receive back into the time when we were working. I will come to this after the bounties. So the bounties itself, we are looking for someone who can build an NFT marketplace based on our limit order protocol. So if you see OpenSea, it consumes a lot of gas. We have more efficient protocol which offers you to exchange NFTs, also ERC20 tokens, between people without trusting to anyone except the source code, which is audited and used. You can build on extension for NFT auctions and Dutch auctions, so whatever you have in mind, just come to us and let's talk about that. Nft Aggregator is also one huge topic right now. We have a lot of NFT markets and it needs to be aggregated. We are aggregator innovators. We invented the aggregation DeFi space for ERC20 tokens. We are looking for a team who can also build something similar. And potentially can also join the 1inch network itself and get also first fundings from the foundation, but I will come to it later. We have also a topic about margin trading, so you can create leverage position by using limit order protocol. You don't have to pay any fees, you can just assign a message, and someone who is interested and maybe incentivized can create for you a leverage position based on Lightning protocol or maybe based on something else. Yeah. We have also margin trading aggregation as well. So there are already some protocols out there which can be also aggregated for margin trading. And also automated market making strategy based on our limit order protocol. Similar to Uniswap v3, theoretically you can create a trading position, very complex trading position. In the extension you can implement, for example, I would like to sell Ethereum to USDC for specific fees. But I'm also okay to buy back for higher fees, for example. So also I would charge potentially dynamic fees. If the pump, if a pump happens on the market, I can charge theoretically 20% fees because the arbitrage has to arbitrage anyway, so you can just earn a lot of this. So the idea is actually from our liquidity protocol, but can be also implemented in the limit order protocol itself. You can create range positions like in Uniswap v3 from $2,500 US dollars Ethereum to $10,000. I'm okay with selling Ethereum, but also okay by buying back, and all the time I earn fees on that. So it's like you can build very flexible, complex trading positions, and you can offer it to create for everyone. And we have a for sure open track. Just come with your idea to our booth. Let's talk about that. We have great software engineers, Kirill, for example, our lead software blockchain engineer. They can help with everything what you need, and can explain how it works. So if you're looking to get in touch with us, we have multiple social network channels. We have also docs.oneinch.org, where you can find also the documentation about the API itself for the aggregation, and everything about our protocols. Back to the foundation and the grant program what we have. I already said we would like to give back what we didn't receive. We applied for the grant to Ethereum Foundation, we didn't get it. They didn't care. And I know it's a very complex topic and everything, but we have a foundation. We have a lot of money there, and you're welcome to build something. Not only for 1inch, you can build also for the DeFi space. Just apply. You can get maybe $100,000 in 1inch tokens. It's like a starter. You can build something, a prototype, and we help also to introduce you to specific angels, VCs and everything. So and also you're welcome to join the 1inch network core contributor team. So if you are looking for a job in crypto space, doesn't matter where you are in the world, you can work with our guys because we are decentralized, distributed people around the globe who are working on the next iteration of financial system. So thank you very much. We have a booth. We have also small bounty for everyone. We have a physical airdrop based on Merkle trees. Come to our booth, get 1inch tokens to join our 1inch DAO. Thank you very much.
Thank you.
Any questions?
Not a question per se, but our tech guys that are in charge of like market making and stuff, they were like really fond of your algorithm. Like you're doing some magic there, like without like the graph search or something, but you, at the same time, like it's efficient and it's really fast.
It's unicorn magic, yeah. Our unicorn, it's a little bit different to Uniswap one. It's a manic, crypto manic unicorn, because we were like crypto manic team on the hackathons, and we thought like maybe it makes sense to build something highly efficient. And maybe if you ask about the 1inch itself, why 1inch? We are like martial arts fans, and the name comes from 1inch punch from Bruce Lee. And we are doing the same on the blockchain. So it's really kind of a little bit magic what we are doing. After our swap, there's no arbitrage opportunity on chain anymore in the network.
Yeah, that's really good because yeah, we've all been arbitraged when trying to start in DeFi, I think.
Any questions from people?
But definitely come by the booth and ask questions, especially since we've got like the tech guys here, so probably you can get some insight into that.
Thank you very much.
Thank you. And we've got the last presentation. Before lunch, everyone is free to go. It's Clayton, and here are the slides. We're ready to start.
Thank you. Okay, thank you. All right. Hello, everyone. My name is Sam, and from Clayton. I'm a director and chief Clayton officer. So I know this is the last presentation before lunch, so I know you guys are hungry, and just give me 5 minutes, okay? So for those who are not familiar with Clayton or have not heard about Clayton, so let me just briefly introduce what Clayton is. So Clayton is basically an EVM-based layer 1 blockchain, and we launched our mainnet Cypress in June 2019. So it's been running for about 3 years. And so we started our mainnet by forking the Ethereum version, but we modified the consensus and other features. And so we adopted Istanbul BFT. It's an implementation of a practical PBFT. And so to run this PBFT, so we form a set of validators, as shown on the right figure, and we call it Clayton Governance Council. So we currently have 32 Governance Council members, and they are running our validator nodes. And so with this consensus mechanism and performance optimizations, we achieved 1 second block time with immediate finality. So once your transactions are included in the block, and everything is done. So you don't have to wait for another 5 or 6 confirmations. And from the perspective of throughput, we achieved about 4,000 TPS, and it shows good performance so far. And we also have set a lower gas price in our network. So we recently announced the Clayton 2.0 initiative to focus on metaverse and games while expanding the DeFi and NFT ecosystem. So we were started as an EVM compatible chain in the beginning, but we made our own features and made some changes in Ethereum code. And we did not keep up with the changes and updates in EVM and the changes in the Ethereum interfaces. So as a result, we had some differences between Clayton's interface and Ethereum interface. So those some differences made hard for developers to port or integrate Ethereum's development tools to Clayton. So we realized that a slightly incompatible environment in Clayton requires lots of work for the development, and also could hurt the productivity of development. So we need to make the interface 100% compatible while utilizing the original functionality. So how we did it? To support Ethereum compatible in Clayton is to segregate the blockchain core architecture into Ethereum equivalent part and Clayton specific part. So we updated the EVM in Clayton to the latest version, the London EVM. Also separated the namespace of JSON RPC into the ETH namespace and Clay namespace. Originally, both these namespaces have the same semantic and syntax because they were just aliases each other. But we separate this namespace, so the ETH namespace is supported as Ethereum's syntax and semantics, but we also kept the original Clay namespace to give the users a full picture of Clayton. So this is also for backward compatibility. So we see the Ethereum equivalence in Clayton has three aspects. The first one is EVM and API. So the latest EVM and the Ethereum transaction types, the recently introduced, and the JSON RPC interface are supported in Clayton as well. And with this interface, any tooling that can run on Ethereum will run seamlessly within the Clayton ecosystem. Lastly, beyond utilizing Clayton Ethereum ecosystem in Clayton, we are also planning to contribute the Ethereum ecosystem and EVM development. So then, when is the Ethereum equivalence ready in Clayton? It's actually today. So interestingly, on the Clayton mainnet Cypress, the new version that supports Ethereum equivalence was activated just a few hours ago. So now Clayton can be used just like Ethereum. So that's all. And thank you for your attention. We have our booth out there, and so just come to us and ask us, and we can discuss further. Thank you.
Thank you very much. We should probably try deploying some dApps
Sure, yeah,
on your network. Yeah. Does it seamlessly work through MetaMask and Remix?
Yeah, MetaMask and Remix can be used, and they have been running with Clayton for a while, but now you guys can use them without any modification. Yeah.
Okay, I'll try it today.
Yeah, thank you.
Thank you. Yeah. Any questions?
Sorry.
Do you have any testnet ready?
Yeah, we also have a testnet called Baobab, and yeah.
Okay, cool. Thanks.
Okay, so it seems that we don't have any more questions, so everyone is free to go for lunch, and we come back here, I think, at 2 p.m. Is it correct? Yeah, at 2 p.m.
Thank you.
Thank you very much. Hello, guys. So we are about to start, and the first presenter is here. So yeah, probably it's about for you to introduce yourself because yeah.
Okay, hi. Thank you. Hi, I'm Luis. I'm going to present about Shutter Network, which is a malicious MEV and front-running protection mechanism, essentially. How even closer here. So how do I do it? Can I use the thing or? Okay, yeah. So no, it doesn't really work. Or maybe I'm holding it the wrong way. Oh yeah, there it goes. So yeah, so most of you maybe here or watching online might be familiar with the problem of MEV, which stands for minor or maximal extractable value. It's essentially the revenue that a block producer can extract via front-running, injecting, and reordering transactions. And it's an emerging issue that now commands up to $50 million sort of per month just on Ethereum alone, and it's also applicable to all other public blockchains. So as a very simple example, just to go through this, is front running, and front running is the practice of someone getting a transaction executed before someone else, and essentially being able to buy, for example, buy cheaper and then even sell more expensive to the victim afterwards by having some information advantage or being able to get your transaction executed before. The victim then suffers from higher price and potentially a failed transaction. Yeah, so that's sort of the simple example, but there's much more complicated arbitration techniques and things like this. Why should we care about this? So generally speaking, the problem isn't really arbitrage. It's generally considered a good thing. You want to equalize prices on dexes and everything, and so there's a large portion of MEV that we considered non-malicious. But what we can probably agree on, generally speaking, is that front-running is malicious, and then just generally speaking, the way how MEV is extracted and potential monopolies forming around the extraction of MEV, that's would be considered malicious, and that's the focus. That's our problem that we're focusing on. That's what we want to solve. So yeah, there's more concretely worse prices, failed transactions. Yeah, and then one more specific case is layer 2 MEV. So generally speaking, people don't think about layer 2 MEV yet so much because it's not apparent. Because generally we're trusting the roll-up sequencers to not to extract MEV because yeah, they're big teams and they have something to lose if they would sort of front-run their own users. But that's not an optimal case. You don't want to trust your operator. That's not how we do it in blockchain, essentially. So MEV does also exist in rollups, and might even become an even larger issue than on L1 because the rollup sequencers are more sophisticated and more centralized. And these are just some pictures. Probably you guys have seen some of these on Twitter and others. Very sophisticated arbitrage, or very people making $2 million per arbitrage. Yeah, So that was just sort of explaining the problem of MEV and maybe also layer 2, and now we come to what we are building, our solution, which is generally speaking is we're using threshold encryption and a DKG, distributed key generation, to combat front running. On a very high level, it works in a way that transactions are encrypted and signed by the block producer while they're still encrypted, so that neither the block producer nor anyone else can see what's in the transaction, so they can also not front run or censor. And then the issue with this, or if you were to trivially do this with your own private key, encrypt your transaction with your own private key, that would lead to a free option for the users not to decrypt afterwards. which we want to prevent. So the whole system is a little more complicated. That's why we use threshold encryption, and we use these keeper systems. So think about sort of a keeper, 50 to 200 crypto node providers that collaborate and run these, the threshold encryption mechanism, DKG, collaborate to generate the encryption key, which the users are using to encrypt, and then the block producer, or collator, we call him, signs the block, finalizes the order of transactions basically, and then afterwards the keepers collaborate again to release the decryption key, and that's why we ensure that the transaction is actually executed. So we solve this free option via threshold encryption. And here's another sort of look at this. Very simply speaking, is these keepers on the left, lower left side, they collaborate, and then on the top, the transaction can pass through this metaphorical dark forest. And then we are implementing Shutter. So there's sort of the first iteration we finished mid of last year. We built it as a smart contract system, which we call on-chain Shutter. It can protect any one or multiple smart contracts from front running, but it has some sort of downsides that I don't want to go into, but essentially, which is why we've switched our focus to something called rolling shutter, which is the same mechanism explained before, but implemented at the roll-up level, at the sequencer level, so that the shutter is integrated into the roll-up, making the entire roll-up MEV or malicious MEV protected and censorship resistant. And I will go into more detail on this. But just to say, on the other two other efforts we're also sort of pursuing on the side is we made a proposal to a ETH research forum to propose to implement this mechanism into the actual beacon chain, into the Ethereum 2.0. Which is it's a longer discussion. That's going to require discussion. We're going to require sort of experimenting. People probably want to first see how the rollups are experimenting with this and whether it works on that level. And then we have another thing that uses the same DKG threshold encryption mechanism, but not to combat MEV, but rather to encrypt DAO votes and to make DAO voting more fair. And we're working with Snapshot on this. There was the overview about what we're working on, and now sort of going deeper into each of the these things. As rolling shutter is sort of implemented into the rollup shutter, implemented into the rollup, and it ideally makes it possible to maintain a long-term centralized operator, a rollup operator. Without all these negative side effects that we would see with a centralized operator. So currently, if you have a centralized operator, again, they can extract MEV, they can censor, and then with Shutter, hopefully these side effects go away. And then to quote John Wang from Immutable Saber, he says, the rollups with the best MEV mitigation mechanisms will have an edge. So we think this could be a value add for any rollup. So yeah, and we're exploring and talking to a bunch of optimistic rollups so far, and see how this goes. Again, this is the Shatterized beacon chain. I'm not going to say a lot about this, but it's the same mechanism, but proposed to implement at the L1 level. It's going to be more sophisticated. Yeah, but feel free to look into this or comment. We love feedback on this. Yes, and then Shutter governance is what I talked about, is this encrypting DAO votes. So essentially there might be some misbehaviors that people in DAO votes in DAO voting are experiencing. So one simple example would be if a large whale can sway the vote last minute, because they see how many votes they need to sort of buy or borrow they know exactly how many votes they need to sway the vote last minute. Something we see quite a lot. And then so the idea would be, if we were to shield the voting, if we had encrypted votes, that would deter them from even trying to do so. And there's some other sort of game theoretical behaviors that we will hopefully improve with this encrypted voting. And yeah, so it's a commit and reveal scheme, and we're working mostly with Snapshot to integrate it directly into Snapshot. So any DAO can then any Snapshot DAO can then access it quite soon. And then also Claros. Claros is you guys should be familiar with this. It's a court system, arbitrage system, and their game theory benefits from having the votes be shielded. So they could also benefit from this in some early talks with them. This is just a small thing. My colleague Yannick built this. It's a game, as a DAO to DAO game based on Shutter. So it's a diplomacy implementation, but DAOs are collaborating, and DAOs are collaborating with the other to fight other DAOs. But it uses Shutter to encrypt game moves, so that the game moves aren't observable by the other DAOs before they even execute it. And then this is just a small announcement, or not announcement, but just want to do some advertisement for this larger event in the context of DevConnect in 3 weeks, I think, is this MEV day, which is a full day of exploring all kinds of MEV-related topics, and we co-organize with Flashbots and CowSwap on this. So if you guys want to attend there, would encourage to apply. So yes, you have to apply to it, essentially. Yeah. So yeah, again, our goal overall is to partner with especially those who need anti-MEV solutions or anti-front-running solutions, or if we're talking about the Shutter government and other things like this, UX-friendly commit and reveal schemes. So yeah, love if you follow us on Twitter or contact me afterwards. Yep. Thank you. Is it?
Yeah. So we are ready to take questions from the audience. So if anyone has anything to ask, we can give you the mic. Any questions so far? Well, probably I've got the question. Where exactly I work in? I work in prod already, and with which chains is possible to see your benefits?
So this first effort, what I call on-chain Shutter, so this smart contract system that you can deploy to protect any smart contract, that's working, and it's in fact deployed in the context of this game on Gnosis chain. But our main focus is what I call rolling Shutter. So the rollup implementation isn't live yet, but should be coming out very soon. So we actually haven't announced it yet. So this is a sneak peek here. So we'll announce it maybe today or coming days. So yeah, but it's also we're quite far in the development, so it's also going to be released quite soon. Yeah. And then where are we collaborating with? So yeah, we're exploring with all the major ORs. And then also talking to some of the side chains, so Gnosis chain, for example, because yeah.
But only ORs. Or
for now ORs, because again they're probably more quick to be viable. Yeah, we've talked to some ZK rollups in the past, but sort of for now the focus would be on ORs.
Okay. And what about L1s that work with them as well?
Yeah. So that's our track with the sort of publishing it to ETH Research forum. And getting feedback from the Ethereum Foundation there and some other people. And then, again, they're not going to be adopting it anytime soon. But smaller chains like Gnosis chain, they also want to create their own beacon chain, right? They are open or interested in prototyping it earlier than Ethereum itself, sort of, yeah.
But is it easy to implement rolling Shutter on chain, or
No, the rolling Shutter is easy for the rollups, and then implementing it into the L1 is it's a more involved process and going to take longer.
Okay. It's interesting because we are all here, so working on launching our own chain. So maybe we can try to integrate with you somehow.
Awesome, yeah. And one other path to this would be if it's an MEVM compatible chain, is to have a rolling Shutter, so have a Shutter MEV protected rollup on that chain as to first. So just try it out, and then yeah. So on Gnosis there's already Optimism and Arbitrum running on those as well. So that's also another sort of maybe smaller step other chains can take to prototype this.
Okay, great. Thank you very much.
Thank you.
So, no more questions? Okay, thank you. Oh, yeah, there is one question.
Sorry, I missed the earlier part. Can you explain the mechanism in short, in brief? Like how exactly does it work?
Yeah, so I'm not going to, none of this is like too detailed, but you can read on our blog posts. So yeah, very briefly, again, transactions are encrypted and then batched and signed while they're still encrypted and signed by the collator or validator or rollup validator while they're still encrypted, and then afterwards get decrypted. And then the complexity there, again, sort of the keepers that collaborate to generate the encryption key that's broadcasted, released, and then whoever submits the transaction uses that key to encrypt, sends that encrypted transaction to the block producer signs, and then keepers collaborate again to generate the decryption key, and that's used then to decrypt. And then it depends a little bit on the implementation who exactly decrypts, but yeah, either one of the keepers or we have another role called decryptors. Depends on which level we integrate it. Does that help the question? Yeah.
I have a question about the Claros integration. How would a dispute resolution layer work exactly in this regard? Like, how would that look like?
Same as before, just that you don't see what the current tally. So you would just say, you just submit your vote, and only after the voting period is over, it would be released.
Okay, thank you.
So it seems that no questions for now. No more questions. So we can let you go finally. Thank you very much for your talk. Yeah, very interesting technologies you're working on. And the next one on our schedule, it's actually a bit early. So we've got like 10 more minutes left before the next talk. So are we taking a little break or? Yeah. So the next one is Ellen Halpern, developer advocate at Alchemy. And so, yeah, we are ready to start once we find the speaker.
She's here. I can see her. Hi.
One moment, so we have to figure out what to do with it. Yeah, we are supposed to have it, for this. Do you need notes or? Oh, it's fine. Okay. So here it is, and here's the clicker if you need it. Yeah, so there you go.
Oh, my clicker, wow. Stocked up.
Can I see? You're not going to see?
Yeah.
Doesn't matter.
These are like my backup answers. All right, should I start?
Yeah, of course.
Oh, you did? Oh, yeah? All right, let me take this off. What's up, everyone? I'm Alon. I'm Alon. This is my backup dancer, Albert. Keep him up here to give me background noise. So I'm Alon. I'm from the Alchemy team. For those of you who have not heard of Alchemy, we're alchemy.com. And we're a developer platform for Web3 applications for the blockchain. My talk today is on building scalable, reliable, and data-consistent Web3 applications. So who am I? I am a developer advocate at Alchemy. I've been at Alchemy for almost 2 years now. So if you don't know what a developer advocate is, we basically just make sure that whoever is building with Alchemy and building in Web3 is having a really good experience and advocate for all the developers building in the space. So whatever tools, products, features you're excited about or need, it's our job to make sure that that happens. I also started an organization called We3 that's focused on women and non-binary education in the space to make it more inclusive. And I started an ice cream company called Crypto Creamery that makes ice creams, make ice cream on the weekends for fun. So building scalable, reliable, and data-consistent applications. I chose these words very specifically for a reason. And you might be wondering, like, why is this hard to do? Why is it hard to accomplish all of those things when you're building in Web3? And here's the problem. The blockchain is run by a network of nodes. And for those of you, most of you probably already know this. If you're not very technical, maybe this is still a little bit new. But the entire network is actually run by a bunch of nodes that are running software on their computers. Every node maintains a copy of the blockchain. So there's no like physical blockchain. It's just all of these nodes maintaining a copy of the state of the blockchain, right? And developers use these nodes to make requests. So any reads, any writes that you want to communicate with the chain has to go through a node endpoint. That means if I want to send a transaction, that goes through my node. If I want to read someone's balance from the blockchain, that goes through a node. So it's a really critical part of the developer infrastructure of building Web3 apps is this kind of node endpoint. And Ethereum was really designed for developers to be able to run nodes. Actually, like in an ideal world, all blockchain networks have individual developers running their own nodes. They run a piece of software on their computers, and they can connect and communicate with the blockchain. That is sort of how it was designed to make it as decentralized as possible, as accessible as possible, right? So you can just run a piece of software on your computer. And for a weekend hacker, for someone who's not sending a lot of requests, maybe I'm doing some MEV stuff, maybe I'm just kind of sending transactions here and there, that actually works okay. You'll still have to spend time syncing the node, right? Because nodes have to maintain the state of the blockchain, so you have to make sure it's up to date and sync all the previous history. You still have to maintain client updates. You still have to pay for the cost of running the node and a bunch more other stuff that kind of happens under the hood. But generally, if you're not sending a lot of requests, you should be able to run your own node. That's kind of how Ethereum was designed. But what if you're someone like OpenSea? What if all of a sudden, in the past year, your traffic looks something like this? How would that work if you were running a singular node and you were no longer just a weekend developer sending requests here and there every so often? This is where we introduce problem number one of it being really hard to build Web3 apps, and that's scalability, right? If you're someone like OpenSea, what are the implications of running node infrastructure? Whoa. Not sure what just happened there. I think I clicked the skip ahead button.
Yeah, the button stuck or something, so we have to get to the very beginning.
Think it works now? Okay, sweet. Sorry, technical difficulty. So nodes can hold a certain threshold of requests. And this is pretty logical. I don't know if you guys ever use your computer and you're doing too much on it and the fan starts to overheat and then it shuts down. Like, computers can only handle a certain threshold of requests before they start to fail. So if you get a huge spike in your usage, right, If you're doing an NFT drop, this is actually a screenshot from one of Alchemy's customers on the day of their NFT drop. This is what their traffic looked like. It was pretty steady, pretty slow, and then all of a sudden, they had a massive need to be able to handle an insane amount of traffic. So if you have this crazy spike and you're running your own node, it just won't work. It'll completely crash and burn, and all of a sudden, all these users that arrive to your application who are really excited about getting your NFT or using your product can no longer use it. What happens when a node goes down? Remember, it's a really important and critical part of the developer infrastructure of your application. So when a node goes down, your users can no longer make requests. They can no longer interact with your application anymore. And it makes your product virtually unusable. And that's because all information that goes to the blockchain has to run through this endpoint. So if it's not up and running, then you can't send information to the blockchain anymore. And you might be thinking, can't we just spin up more nodes, right? There's a very logical solution to scaling. It's like create more of it. When you create more of it, you can handle all of the requests. The problem there is that nodes actually can take weeks to sync. And one of our back-end engineers, Omar, is actually in the audience right now. He syncs Alchemy's node often, and he can tell you about how challenging it can be. So if your application crashes due to a large spike, and nodes can take weeks to sync, churn happens in seconds. I don't know if you guys are like this as users, but when an application isn't working for me, I completely close the application. I'll probably never return again. The same thing can happen with your Web3 application if it's not up and running. So you can't really spin up more nodes if you're in hot fire right now. And this introduces problem number 2, which is reliability. Your node reliability equals your product reliability. Remember, this is because it's such a sensitive part of your Web3 application's infrastructure. Even if a node is 95% reliable, right, which is like a pretty auspicious number, 95%, that's 1.5 days of downtime for your application. So an entire 36 hours every single month where your application is down if your node is just 95% reliable. Not only is that frustrating for your application, it's also frustrating for your engineers. Your engineers are now spending valuable time maintaining this back-end infrastructure and trying to upkeep this node endpoint instead of working on your actual product. They're just debugging. So maybe you get smart and you're like, all right, I know this is going to happen. I'm expecting a huge push. So I'm going to spin up a bunch of nodes ahead of time. You know, weeks ahead of time, I'm going to spin up all my nodes, and then I'm going to be ready for all the traffic that comes. This is where we get to problem number 3, data consistency. This is a little bit more of the trickier problem. It's kind of harder to get visibility into at first. And so we're going to look at it through an example. So why is data consistency really hard to do in Web3 applications? There's a logical scaling solution to reliability and scalability, and that's using what's called a load balancer. And for those of you who don't know what load balancers are, they're basically this in-between layer between your application and your nodes where you can funnel traffic to different endpoints. So if I'm getting a ton of traffic on my application and I know that one single node can't handle it all, I'll spin up a load balancer. When I get a request, I can funnel those requests to different node endpoints so that no single node can get overrun. This is super logical. It's a simple scaling solution. It's a very Web2 scaling solution. And in fact, a lot of node providers in the Web3 space use this to scale up, right? So they're running a bunch of node infrastructure under the hood. They slap a load balancer on top, and then that can funnel traffic to different endpoints. So it's super logical. What's the problem with this? Remember, blockchains are run by a network of nodes. And what implications do a network of nodes have on this data consistency issue? Well, every node, because it's run by a network, every node might have a different sense of what the latest block is. The way nodes communicate is, I'm a node, I have 10 peers, those nodes have 10 peers, those nodes have 10 peers, until we reach the whole network. And so if I find out about information, my peers and their peers might not also have that same information. And that's the implications of a network. That's how networks work. So depending on what node you're sending requests to, it might not actually have the same sense of what the latest block is because blockchains are run by this network. So this means that load balancing, right? So sending requests through a load balancer that funnel to different nodes can return inconsistent data. And this is where it gets a little bit tricky. So if I'm the green user, and I ask for the latest block through my load balance node infrastructure, maybe I'll get block 102. At the same exact time, if I'm the red user, and I ask at the same exact time for the latest block, maybe I get funneled to node 3, and they tell me the latest block is 101. This is the implications of using a simple load balancer. You might not get the same data because this is how blockchain networks function. Now, what does this mean for actual users, for your actual application? Let's walk through an example. So I'm a user. I buy a mutant ape, and I use a load balance node infrastructure to do this. And remember, load balancing is a very common solution in Web3. If you guys aren't using Alchemy, you might actually be using a load balance solution node provider or running your own nodes. So I buy a mutant ape. That gets funneled through the load balancer into node 2. So I get my mutant ape. The transaction's confirmed in block 102. I'm stoked. I'm happy. I have an awesome mutant ape, and I know it's in my wallet. Let's say I refresh my feed. I buy the mutant ape. I saw it there. I hit refresh button. Remember, all engagements with applications go through a node, right? Because you're querying from the blockchain. So even just a simple refresh on data, that read goes through. So I refresh my page. It goes through the load balancer. But this time, instead of getting funneled through node 2, it gets funneled through node 3. Now, node 3 in this load balance infrastructure isn't yet aware of block 102. And what that means is my purchase of that mutant ape is now gone. Not because it's actually gone, right? It lives in block 102, but the node I'm communicating with isn't aware of block 102, which means my application is telling me, hey, you don't have your mutant ape. I know we said you just bought it, but now it's not there anymore because we're not aware that that existed. So this is where data consistency is extremely important. And it's often overlooked in a lot of Web3 applications and a lot of node infrastructure platforms. So what do you do? I've been yamming about how hard this thing is and all the challenges that you face when running node infrastructure in Web3. So what can you actually do? Well, there's a simple solution to this. You build out a higher level infrastructure engine. This is what it looks like for you. You have one endpoint, and it's done. You don't have to worry about data consistency. You don't have to worry about scaling. You don't have to worry about reliability. That's it. This is all you have to use in order to make this happen. This is what's actually happening under the hood. And this is our kind of high-level infrastructure diagram for what we've built out at Alchemy. So we spent the past 2-3 years, 2-3 years ago, we've been live for about a year and a half now. But we spent the first 2 or 3 years just kind of in stealth mode building this out. Really thinking about what are the extremely challenging problems that come with running node infrastructure in Web3 and coming up with this higher level infrastructure engine that solves for these issues. So no, it's not actually really easy under the hood. It's really easy for you because all you have to do is spin up a free account and just get access to this endpoint. And it gets funneled through this larger infrastructure engine that we spent years and years building, refining, and mastering, and are continuing to iterate on to find those niche issues. So what are the key components of this? There's a coordinator service that kind of helps funnel different requests. There's a consensus mechanism that we built. And remember, this is all on top of the node. So yes, blockchains and nodes all have these things too. We built out our own versions of this that sits on top to make sure you don't hit any of these issues. There's a consistency layer. We use diversified node client. So I don't know if many of you know, but there's a bunch of different node clients out there. And if you're just running one and that one has a bug in it, then you can no longer actually serve requests and engage with the blockchain. So we make sure to run a diversified set of node clients. We index a bunch of data stores. We also provide a caching layer so that requests are served to you a lot faster than they otherwise would be. What does this mean for you? How does this implications for the end user? You get consistent data. You don't have to worry about users experiencing changes in their mutant ape purchases or their NFT purchases. You have instant scalability. So if you are OpenSea, we do power all of OpenSea. So if you are OpenSea and you have this insane spike, we don't have to worry about upscaling your nodes and running a bunch kind of instantly. You've increased reliability. We also have a bunch of enhanced APIs built on top of the platform to make indexing things a lot easier. and free archive data, of course. So if you don't want to spend $200 on archive data, it's completely free on the platform. At a high level, we've developed a proprietary distributed blockchain engine that provides infrastructure and solves for these three really challenging issues: scalability, data consistency, and reliability. Our platform has a bunch of other tools for developers as well. We're built on a bunch of different chains, but really the bread and butter here is this supernode, this infrastructure engine that I've been talking about this whole time. Other products that we offer for devs are Alchemy Build, Monitor, and those are both debugging interfaces like dashboards and more insights into your requests. We have a notification system, so if you want to get notifications on your blockchain applications, you can do that. The enhanced APIs that I've talked about. And we have an awesome support team. You never talk to a bot when you're using Alchemy. You always talk to real humans. So yeah, this is our product suite. The main premise of my talk was on our supernode engine, so I won't get into too much on the other tools that we offer, but happy to take questions from here. Yeah, thank you.
So I have a question. Is it safety to create some kind of Web3 apps only with front-end and contracts? So I put the link to the Alchemy in front-end, so the malicious actor can steal my link to the or to the Alchemy and try to use my paid node. So what is the best practices for it?
Yeah, that's a really, really good question. I was actually just yesterday we were talking about that with a bunch of people. And so this is, just to kind of repeat the question here. One issue that Web3 applications have is that they often don't have a backend, right? The backend in Web3 applications is the blockchain itself. So in an ideal world, you have a front end, you have a smart contract, and all of those requests go to the backend, right? So you're not actually controlling or storing any data because the backend is the blockchain. Now, if you're using something like Alchemy, then your key kind of lives in that front-end application. And so his question was like, what's the best practice there? Because you have this API key that I showed you guys earlier. And if it lives in the front end, then in theory, a bad actor could come and take it and use it. My short, kind of frustrating answer for you is that this is a really hard challenge to deal with when it comes to not having a backend in Web3 applications because you can't protect it. Some solutions that we do have right now, but like really, this oddly enough doesn't come up as much as I thought it would. So like surprisingly, not enough people are doing this, but again, our platform is free, so like you could always just spin up a free key and use it. But so there's things like whitelisting. So you can do whitelisting of domains, so that only requests from your domain can go through. So if I copy your key and then I try and send a request from another application, it won't work unless your domain is whitelisted. You can do IP whitelisted. So you can only take requests from certain IPs. There's ways to do IP blacklisting too. So if you notice an IP that's sending a lot of traffic and you don't recognize it, you can blacklist that IP. There's rate limiting you can do. So you can rate limit certain keys and users so that if you see people using a lot, you can start to throttle their requests. And then they're no longer incentivized to use your key. In general, it's a bit of a tricky problem that has to do with how Web3 apps, how their stack kind of works. But it's a really good question. There are a couple solutions to it right now that exist.
Hey, how's it going? Have you been thinking about zk EVM any in terms of like stateless, multi-chain proving so that you can serve data in a secure way? Because many of the EVMs will be compliant once they have native zk EVM, right? So you can have Alchemy type consensus around the fact that you've recursively proven a chain and then serve up data with Merkle proofs that the data or your transaction exists in that blockchain in zero knowledge with a small, like maybe 20 kilobytes proof or something like this. What are your thoughts? Like, would that be in the consensus layer? Would it be completely stateless? Or have you been thinking about it at all?
Yeah, that's a good question. So I'm not quite sure if I'm completely understanding what you're saying. Basically, like validating that data served is correct through like some sort of ZK proof. Is that kind of the thing?
Well, you can have a rolling recursive proof like through IVC or some other mechanism, but you can have like a system that just keeps track of the Ethereum blockchain and recursively prove it. Since native zkVM exists now, you can recursively prove it, and then a service in a backend could be trustless and censorship resistant in terms of giving you data that you know is correct. The only thing is you don't know if the blockchain's rolled back or not. So if the blockchain's final, then you know for sure that it cannot be rolled back and you can trust it. But I wonder across multiple blockchains, multiple EVMs, some service like that, like a decentralized Nfira, needs to be stood up that you can not have to trust a consensus or something like this.
Yep. Yeah. Yeah. Totally. No, I think that's absolutely fascinating. It's definitely something that our team talks about a ton. I think it's actually not a trivial problem to solve, which is a big reason why no one has solved it yet. And so the big need that we're hyper-focused on solving at Alchemy, at least for this moment, is making sure that like apps can scale and run and are served consistent data. So that's kind of first and foremost. Like, how do we make sure that Web3 applications can actually like scale and exist in the nature that they want to? And then that second layer is doing stuff like this. So we've absolutely talked about it as a team and thinking about what kind of ways we can do this, especially across multi-chain, which is some of the things that you're getting at in your statement. I don't have a definitive answer for you, like yes, X, Y, and Z things, but I think it's a really, really fascinating space and something that we've talked about a ton.
Sure, thanks.
Yeah, so can you blink once if there's going to be a token airdrop and blink twice if there's not going to be a token airdrop?
Yeah.
Or blink 3 times if, you know, yes or no, maybe something.
Yeah, I've never blinked in my life, so I can't.
I take your silence as a yes.
No, you know, truthfully, like, there's not really an eminent need for us to have a token right now, just the way our kind of platform functions. So, and I think as a company, I don't think we're super keen on like launching a token just to launch a token. And so if and when there becomes a strong need for us to do that and build out a platform where the incentives are aligned and things make sense, then like I'm sure we would. But I don't know what to blink anymore because I forgot your rules. So I'm just not going to avoid that. Yeah, so the short answer is no, but it's not like we're strongly against tokens or anything.
No worries. Thank you so much.
Oh, thank you. First of all, I would like to appreciate the way that you express your solution. It's an amazing way. I believe that this solution represents a single point of failure because at the end it's centralized solution, isn't it? How do you guarantee that all the time your solution is running? This is question number 1. And question number 2, this URL represents to me a way to get the data from blockchain. What's the guarantee that you are not tampering the data or nobody is tampering the data?
Great question, yeah, great question. So I'll take number 2 first. So the question was like, you know, we're serving blockchain data, right? So you're reading requests from us and we're serving it back to you. So what, you know, how do you guarantee that we're not tampering with that data when we do serve it back to you? And the short answer is like those incentives aren't aligned for us. Like we have absolutely zero incentive or like initiative to want to do that to you. And the reason being is because you can always, this is the nature of blockchains as they exist, you can always, always, always use something else. You don't have to use Alchemy, ever, right? If we're in Web 2 and you have these centralized servers, then, and I decide one day to be malicious and I shut your server down, maybe I stop feeding requests, maybe I you know, modify data, there's no way to recover or get that data in any other way, right? Because they're on centralized servers. In Web3, if you woke up one day and you were like, you know what, I don't want to use Alchemy anymore, you absolutely could, and all of the data, the whole history of your application, and everything that's going to happen next is still there. It's on the blockchain. You can access it by running your own node, you can use another provider, you can go through your wallet, like all the data still exists and is there. So there's no real incentive for us to like modify or tamper with your data because then you'll just turn off of us and you will no longer use us, right? We don't have a product anymore or a business if we do that. So that's kind of to answer your second question. And your first question is around like centralized point of failure. And so yeah, so if you think about like kind of the beginning parts of the talk around like running a single node, data consistency, all of these issues that occur when running node infrastructure, that happens all the time with applications. And that's kind of the reason why, that is the core reason why we built this out, is because now there isn't a singular point of failure under the hood. So, taking a step back, this is more a philosophical question of like, what is centralization, what is decentralization? And so from this perspective, we're not running a singular node, so we don't necessarily have a singular point of failure. We're running a bunch of node clients. We're running a bunch of software and consensus mechanisms above as well. So our infrastructure engine as it exists is just a lot more reliable than a traditional node infrastructure engine is.
I'm not talking about your solution is scalable, yes, I agree with you. However, at the end, if the infrastructure for any reason went down, the whole solution will went down. While the infrastructure is running, you have the guarantee that you will serve me. Got it?
Yeah.
So I'm thinking that if we think about, I'm not talking about that your solution is bad or not good.
No, yeah, I think I
I'm
understand
talking
your
here
question,
about an alternative scenario for like, for example, let's imagine a serverless node.
Yep. Yeah, so, okay, I see what you're saying. Like, what if the entire thing was done? Yeah, and I think this is like so the short answer is like, look, Polygon went down for like a week and a half, 2 weeks ago. The entire Polygon chain went down. And people were like, oh, like, stuff's not working on Infura, Alchemy, all these things. It's like, no, like, the entire Polygon chain went down. Like, shit happens, right? Like, things can just go down. So the risk is like, all right, what if Alchemy goes down? Like, how does that, what can you do there? Yeah, yes. The whole idea is that failures happen, things happen, Ethereum can go down, Polygon can go down, all these things happen. We're reducing that risk. I think you're exactly kind of summarizing it in a really clean way. By using stuff like this, by building kind of this higher level implications and stuff, it reduces the risk. Yeah, good question though.
Any more questions? Yeah, it seems that everyone's spoken. So thank you very much for your talk. And it was really educational. Yeah, probably both of them.
Oh, one last thing. We have swag over there. Bunch of Alchemy shirts. So these shirts, this shirt, and a bunch of stickers. Yeah. So if you want swag, there's not that much of it because people like took a lot yesterday. So definitely go grab some swag if you want to.
Thank you
now
very
we
much.
have a 30-minute break.
So we are going to be walking through some of the pros and cons of using Sway, what it's like to develop smart contracts for the Fuel VM, and just some general use cases through this talk. This talk does presume some level of elementary familiarity with Solidity, programming, preferably Rust, but not necessarily because this is the syntax is very Rust-like. This will also contain a lot of code examples and A/B comparisons, essentially amounting to tutorial or introduction to Sway for somebody who only knows Solidity. And yeah, I'll go ahead and get started. Cool. So we'll go ahead and start by kind of top down. What is the market that we're addressing? What is our motivation? Sway was motivated by both Solidity and Rust. So in Solidity, obviously it's like the prominent smart contract development language, and it brought the whole notion of smart contracts into everyone's mind, and it's extremely powerful. We believe in the Rust philosophy of language design, and we want to combine the ergonomic first-class smart contract and blockchain support of Solidity with the design philosophy of a language like Rust. What we generally mean by that is that we want to provide security and static analysis in exchange for auditing and being very careful. So the programming model is pretty similar to Ethereum, although we allow for multiple native assets. And this removes the error class of rolling your own token from your contracts entirely. There have been a couple of prominent vulnerabilities along that space. And that's kind of like what you would gain from coming from Solidity. But to talk about the Rust side of things, Chromium has done a study of all of the bugs that they have encountered over the past, I don't know, N years. We'll have to check the study. And most of them related to memory unsafety problems. And among memory unsafety problems, there's a couple different classes, but most of these are addressed by a programming language called Rust. Now, this is not a blockchain language. This is just a general purpose programming language. But what they were able to do is through language design and through static analysis, they were able to essentially eliminate an entire class of bugs, that represented 70% of the Chromium project's bugs. So just by virtue of language choice, your entire space of bugs is only 30% of what it used to be, which is huge. And we essentially want to do that for the smart contract development space. Obviously, memory safety bugs are not exactly a huge issue in the smart contract development space because it's a different problem domain. So we do not specifically tackle things like the borrow checker or use after free or things like that, mainly because they're not relevant. Instead, we provide blockchain first static analysis, so things that typical contract vulnerabilities that you would want to catch. An example of that would be a violation of the checks effects interaction pattern. We can provide static analysis to warn you and prevent you from doing that without ever having to hire a single auditor. And if you want to see, they also have a pie chart about the various memory unsafety bugs they had in Chromium. Right. So we're essentially, my thesis here is that we're combining a lot of aspects of Rust and a lot of aspects of Solidity. So from Rust, we get a statically typed, verbose, and friendly compiler. We get the syntax of Rust. We get trait-based inheritance. So I don't know how many of you have dealt a lot with Solidity inheritance structures. It can be opaque, and the evaluation of constructor order can be ambiguous at times. Not technically ambiguous, but it's difficult as the programmer to analyze. We also, from Rust, package our compiler with a lot of tooling. So one of the things that Rust does great is cargo. So before I keep going, has anybody here used cargo before? Maybe a show of hands. Cargo, okay. About like 15%. So cargo is a package manager, a builder, a documentation generator, a augmentable plugin system, a testing framework, a benchmarking framework, all of that in Rust in this one single binary. And what that gives you is that gives you one enshrined way to do things. So you get a unification of documentation. You just skip that whole decision process of your tooling for a lot of these things. It gives you one unified way to build your project. And it gives you a lot of ergonomic benefits. So we package Sway with something extremely similar to Cargo. We'll get back into that later, but essentially, it's a batteries included pack. You just download the single binary and you get going. In addition to that, we have a unified team. So our tooling team, our language team, our formatter team, our VM team, we're all in the same chat here, right? So we literally the same Slack channels. So we're able to share a lot of code. We're able to unify our tooling. The main dichotomy that I'm drawing here is if you're writing a Solidity smart contract, you also need to onboard into JavaScript typically and use Hardhat, and you need to decide which testing framework are you going to use. You need to decide, you have to make a lot of decisions, and you have to accept a lot more liability. Having one enshrined toolchain eliminates a lot of that. So what did we take from Solidity? Well, our language is designed primarily around smart contract development. We integrate contract storage as a built-in language construct. So with a lot of other Rust-based smart contract languages, you'll see essentially storage access or other contract primitives as library functionality or as syntax, syntactic sugar or something like that. We have contract storage as a first-class language construct, but we try to do it a little bit safer than Solidity. We want shareable contract interfaces. So if you're writing something to call a contract, or if you want multiple deployments to implement the same interface, we want that to be able to be shared. And we want that tool to feel like it was made for the task. So you want to use the right tool for the right job. There are a lot of other projects that essentially bolt into Rust or use LLVM or like an alternate LLVM backend for the task of writing smart contracts. And what ends up happening is your front end was engineered for an entirely different purpose. And so you end up throwing away a good chunk of functionality and bolting onto a very specific subset. And it's just not an ergonomic feeling. And when you don't feel ergonomic, writing code that is, deploy once, live forever, you're going to end up with vulnerabilities. So we are Fuel. And what we want to do here is we want to provide fast and efficient contract deployments and execution. And we want to provide safe code. We want everything to be easily auditable. We want you to feel safe when you're deploying any sort of contract written in Sway. We will maintain Semver and backwards port security fixes, which is something that has been a point of contention in the smart contract development space. And we generally just kind of keep an eye on Twitter, and we learn from angry tweets as well. I would like to mention that. And we unify the tooling and developer experience, as I mentioned before. So I'm just going to slightly tongue-in-cheek show a couple of angry tweets we've learned from. So yeah, so this one, well, I'll just play these really quick. So yeah, we also don't have that. And yeah, okay. So some people would say that Rust is definitely something that's hard to learn, but we're not writing Rust, so we aim to have a lot of really good documentation and a lot of really good developer onboarding. Okay, so I'm going to start getting into like the nitty-gritty language features. Specifically state variables. So when you're accessing contract storage or contract state, then in Solidity, it looks a little something like this. And this variable is essentially in your scope now. You have this stored data variable, and this in itself has, of course, led to some vulnerabilities, this ambiguity between which variables are storage and which ones are not. So what this looks like in Sway is we have this storage declaration, which looks really similar. It's a little bit different syntax, but we have the storage keyword, and we have, it looks like a struct declaration, essentially. And now to access that storage, you have to, in your function, annotate that you are accessing state with that annotation there that says storage read write. And you also have to prefix your access with the storage keyword. Now this seems like maybe something trivial. You're like, oh, it looks like a struct or an object access in any other language. But in reality, this would have prevented large vulnerabilities. Oh, I've done something to my presentation. In reality, this would have prevented quite a few vulnerabilities that are out there right now where there's ambiguity between whether or not you're accessing storage or whether you're accessing just a local variable. All right, and then we'll take another look at a couple code examples here. So, functions in Solidity, I'm sure nobody needs a refresher. They look more or less like this. You have attributes that you can attach onto your function signatures. You have things like pure, you have payable, etc. Just to give you a little bit of the syntax, in Sway, it's going to look a little bit different. So you define your ABI completely separately, your contract ABI, and this grants you a couple of things. So one is that you can share this ABI, you can export this ABI, and when you call this function, you can just import the ABI and use it directly, as if it was, just a library. And then we're going to implement that ABI for our contract, and you implement the functions. It looks a little bit like a trait, if you're familiar with Rust. And one final little thing is that we have implicit returns down there. So you see that there's no return keyword in the helper function. And then to go back a little bit to a different example, instead of having things like pure, payable, et cetera, we have these annotations on top of functions, function signatures. So that's just a syntactic difference. Yeah, and we've replaced the Solidity inheritance constructor system, as I mentioned before, with a trait-based inheritance system. If you're familiar with Haskell, it's kind of like a type class. If you're familiar with Java, it's going to be a little bit more like an interface. All right. Another thing that we want to look at is error handling and how you actually would handle an error case in a contract. So one thing that we really like and want to keep using from Solidity is being able to just revert in your control flow. This is not actually the case with all platforms out there right now, so we want to be able to retain that. So reverting in your control flow is great because you want to do one thing right or revert. That's like a really good design principle. So in order to keep this principle, we have retained that as well. And it looks like on this computer, my fonts are a little bit different. So we get a scroll bar, unfortunately. By the way, just since we see the scroll bar, if you ever want to look at this code right now or something, the URL is up there at the top. You can just browse to it and look along. You can even read my speaker notes. So that got louder. We have the panic macro, which I am. Okay, we'll move on from this one. We have here it is. Okay. So scroll bar is a little bit less bad here, but we have the transfer function here, which returns a result. So this is what's called a sum type, and we have enumerations in Sway. And what you do here is you can return an error, and if you're familiar with this, what this does is it instantiates one type of the sum type, and then that can return from your contract. All right, so another thing we have is along with our static types, we have a pretty advanced and robust type system. We have generics, we have type inference, we have structs and enums, which are also known as sum and product types. Or if you're particularly mathy and maybe even silly, they're called pi and sigma types. So what those generally look like is this. So struct, if you're familiar with Rust, this is almost the exact same syntax. The enums are a little bit different. But if you're familiar with Rust, a struct declaration, you're now declaring two U64s, unsigned 64-bit integers, that will be stored in memory contiguously. There's no overhead here, there's no runtime. The size of the not enough fun struct is 128 bits. It is two U64s concatenated together, and that's called a product type. And then for the sum type in the enum, you have one or the other. So instead of having memory being laid out contiguously, in an enumeration, you are either one or the other. This does have a little bit of overhead. There is a tag stored. So you have essentially 64 bits more than the size of the largest type. And as you see here, we have generics as well. So generic functionality so that you can share this sum type over all your other types. So our type system is essentially the same as Rust, but with a few differences. Primitive types are mostly from Solidity. There's a lot of primitive types in Rust that you don't really need when you're developing a smart contract. So our primitive types include unsigned integers, booleans, static length strings, 32 byte values, single byte values, and the unit type, also known as the MC tuple. And we also have tuples as well to compose these types. As mentioned before, we have generics and traits with inheritance. So if you're familiar with Rust syntax, this will be pretty familiar. If you're not, a quick explanation is that the trait is called foo. So this is, like I said, a type class. If you're familiar with Haskell or Java, it's like an interface. You're essentially opting into some interface for your type. So this trait here is essentially saying we're going to define a trait foo that is generic over two types. And the first type requires that it also implements the interfaces bar and baz. And the second type, E, requires the interface. I've actually never had to pronounce this out loud. Kooks. Yeah, we'll go with that. Yeah, so that's our type system. And then a couple of literal instantiations we have here. So generally, instantiating a variable, you can provide a type annotation optionally, or you can allow inference. We have B256 literals, et cetera, et cetera. So we can dive a little bit into the use cases of a union type, a discriminated union, which is a sum type, also known as an enum. So this is an example of composing those two things. So you have the structs with your contiguous memory layouts, and then you have the enumerations sale. So the struct service is the larger of the two because it has a 15-character long string, and thusly the size of sale, if you remember what I said earlier, is the tag plus the larger variant. So it's going to be the size of service plus 64 bits. Cool. Additionally, we have match expressions. So similar to Rust, you have control flow where you can put an if or a match on the right-hand side of an assignment. And what that does is it's a very expressive way of writing your code. And not only do we have matches as expressions, but we have exhaustivity checking. So there's actually, if you were to try to compile this, you would get an error because you are not covering the domain of numbers from 3 to infinity. And exhaustivity checking is another thing that essentially prevents vulnerabilities. Vulnerabilities oftentimes come from control flow that the programmer did not anticipate. And if the compiler is able to look at the control flow and say, hey, there's a case here that you've missed, you will not have an unanticipated case or undefined behavior in your control flow. So another quick example we'll dive into here is EC recover. So if you use EC recover in Solidity and it fails, you get a magic constant back. Doesn't quite fit with this font. And that magic constant is just a bunch of zeros. And this is generally considered as kind of a programming anti-pattern because what you have is a sentinel value that represents something. However, the sentinel value is within the domain of what could have hypothetically been returned from the function in a valid use case. And what this means is that the programmer has to remember to check for this every single time. If not, that's a potential source of vulnerability. And in Ethereum, this is not an issue, but in general, this is also a opportunity for somebody to like hijack whatever the sentinel value is, and that could lead to a compromised account or something like that. So one of the reasons we're really big on sum types and enumerations is that they completely prevent this. Sum types and exhaustivity checking together completely prevent this. So sum types enforce that all cases are handled properly. Exhaustivity checking enforces that you've handled all the cases that are possible in your control flow. And a sum type would fix this by essentially returning either OK or an error. If it's OK, you get the value just fine. If it's an error, then you know for a fact that the EC recover did not work. You don't have to check a magic constant. There's a 0% chance that you are going to accidentally treat the error value as an address and then proceed. All right. Okay, so just a quick speed round of language features. Time is coming to an end here. Ifs are expressions. We have unchecked arithmetic as well as checked arithmetic without runtime overhead. That's due to our VM architecture. We have pretty sweet underscore syntax, just another little thing. Matches our expressions. Okay, I'll skip over visibility for time's sake. Both Solidity and Sway support writing inline assembly, but Sway's standard library is implemented in this construct. The way in which we do this is a little bit lower level for now. So in Solidity, an assembly block looks something like this. And if you're an optimizer, you'll end up doing this a lot. And in Sway, assembly blocks look a little bit more like this. You initialize some registers to some values. So in this case, the register R1 is initialized to A, R2 is initialized to B. We add those two. So if you're familiar with like a MIPS or x86 style assembly, R3 is the destination. So we're adding R1 and R2, putting it in R3, and then returning R3 with an implicit return. A couple more assembly examples here. You can put any arbitrary expression in the initializer of your assembly. Let's see. Okay, cool. So the final point that I want to hit here in the last 5 minutes is our tooling, and I think this is honestly the biggest selling point. So the language itself, sure, it's like learned a lot from modern language development and modern language design, and it tries to make everything safe and it tries to make everything ergonomic. But in addition to that, we package it with good tooling. And one of our main points of pride is this thing called Fork. So our organization is called Fuel, and this stands for Fuel Orchestrator. And this is going to be your cargo. This is going to let you build. This is going to let you test. This is going to let you eventually audit your code. This lets you initialize new projects, et cetera, et cetera. And all of this is completely enshrined. It's all open source as well, but it's like the enshrined and recommended way of doing things. And we also subscribe to the Rust philosophy of one way to do everything, and that one way should be the correct way, and it should be also the most efficient way. We also have 2 SDKs available for dealing with our contract code. So the Rust SDK, what it does is it allows you to test, deploy to a node, do all sorts of things. Both of these SDKs allow you to do that, and you can do them either from Rust or from TypeScript. So this is going to also not quite fit on the screen up here, but this is just an example of the Rust code that you would, see if I can do this. The Rust code that would be used to, for example, load a contract. Can I do it from here? Load a contract and interact with it from Rust using our SDK. We don't need to delve into this in too much detail, but you can get a general idea for the fact that we have an ergonomic API that surrounds contracts in Rust so that you're able to programmatically deploy and test repeatably. And with just 3 minutes to spare, I will wrap it up. Thank you all for listening. Check out Sway if you're interested in using it. We have an email there, devprogram@fuel.sh. We also have a Discord server. We have multiple Twitters. Sway Lang has a Twitter as well. And yeah, that's all.
Thanks a lot. I wanted to ask, actually, what's your target audience for this language? So what types of products should be built with it?
Yeah, so that's a good question. So just to give you some context, I'm the compiler guy. I work on primarily the language, but we also have a layer 2 rollup, and we also have a modular blockchain execution layer. And so if you're interested in layer 2s and scaling in general, this is like a perfect chance to dive in. I know there's a lot of competing contract development platforms in the layer 2 space, but this is one of them. So that's one use case. Another thing is if performance is really key, so you have maybe high volume trading and you're worried about gas fees or things like that, that's a really good use case. But it is a general purpose contract development platform, so ideally any contract where you care about security and performance could be applied here.
Okay, but it's compiled, it's EVM compatible, yeah?
Actually, it's not. So we do have an EVM compatible VM, and that's part of the Optimistic Rollup project. However, this language targets specifically the Fuel VM opcodes. So that's, in that way, it would be EVM compatible. Although we've recently pivoted to essentially working more with Celestia, if you're familiar with a company called Celestia, and providing the first modular blockchain execution environment, and we aim to be the fastest in that space.
Great, thank you very much. Any more questions?
Hi. Oh, wow. Okay. How would you compare the language with Viper?
Yes. So Viper, for those not familiar, is like a Python-based smart contract development platform as well. Viper's really cool, and yeah, I mean, it's definitely a really cool product. We're kind of taking a different design philosophy, though, obviously, for 2 main reasons. One is we're targeting the Fuel VM and our specific layer 2, and that involves entirely different opcodes, and so we're not really able to leverage things like Viper for our toolchain, and that's just kind of necessarily why that justifies the existence of this project. But additionally, in language philosophy, like I mentioned, I'm like the language guy, and in language philosophy, very different. Python has a lot of pros about it, but we're definitely more interested in static analysis, security, auditability, things like that at compile time. So we want the compiler to be able to tell you, hey, this could be a vulnerability that could be in your contract. And that's not as high of a priority as far as I'm aware in like the Viper toolkit. All right.
Any more questions? Oh, yeah.
Something easy.
Thank you very much. In fact, I've got 3 questions very quickly. One about Remix. Is there any plan to support the language via Remix itself as an IDE? And question number 2, is there any porting tool? Like I already have my own Solidity smart contract and I would like to port it or convert it to be using Sway language. And question number 3, in the market there is a very famous library, OpenZeppelin. Is there any way to utilize it, or is there any chance that this library is going to be ported to Sway?
Okay, yeah. So just to give some context, we're still a pretty relatively early stages project. We're about a year in. And I'm going to kind of answer these, well, I'll start back to front since I remember them. So question 3, OpenZeppelin. It would be great to have tooling like that available. We're still a pretty early project, and we ourselves haven't invested the resources in implementing it inside of our organization. It would be great if once it's out there and we're seeing more adoption, it's entirely possible that somebody would implement that, or even that we would pay to have that implemented. But that's not right now. We're still working on core language development and the tool chain itself. Question 2 was a transpiler, so like going from Solidity to Sway. That is also something that would be obviously really good for us to have for adoption's sake, but that's a really hairy problem, especially when the destination language is still being developed. So that's one of those maybe someday things. It would be really great, but I know I believe there's one for Cairo, right? That you can go from Solidity to Cairo, I think, if I'm not mistaken. And that's like a really cool thing, but yeah, we don't have that yet. And the first one you said limits, is that what you said? Linux IDE? Oh, Emacs. Did you say Emacs? Oh, okay. Yeah, so as part of tooling, we have a Vim plugin and a VS Code plugin. Unfortunately, not Emacs, but we have a core language server. So for Emacs, if you have, I'm personally a Vim person, so I'm sure there's a language server protocol that's Emacs compatible that you could use, but we do have a language server. Yeah. Anything else?
Is that it? Or any more questions? Okay, it seems that we're done. Thank you. You're really doing cool stuff. Please check it out. And the next up is Arnaud from Polygon Hermes. Yeah. Yes, so I'm going to get the presentation done. Here's the mic for you. How do I run it? Like, do you need the notes or not?
Yeah, I do the notes.
Okay, then we'll have to do it a bit differently. There we go. Okay, so this, and this is the slides, yeah? Either they go over there. Full screen. And here is the mouse. So here it is. Yeah. It's ready.
Yeah, so good morning. I'm Marnau Ben Nassar, working at Polygon Hermes, and we are with building a zkVM rollup that it's compatible at opcode level. And today I'm going to talk about consensus for rollups. Yeah, so I'm not going to fully explain what a zk rollup is, but let's go through some basics just for the sake of this presentation. So essentially, a zk rollup, it's a smart contract on layer 1 on Ethereum. And this smart contract holds the different blocks that we actually call them batches to not create a further confusion. And so these batches contain basically a list of transactions and then a root. And the root is basically a hash of, so like the entire state, compress it into a tiny amount of data. But then again, like the main idea of rollups is to do not have to execute the transactions on layer 1. And so that's why we have the zero knowledge proofs, which actually take the previous root or the previous state and demonstrates the outcome of processing the transaction list. And hence, the layer 1 can trust that the root is actually corrected, processed correctly. Yeah, so how are those batches added into the layer 1? So definitely we need an entity that we call the rollup operator. And this operator basically collects the different transactions from the different users, like the layer 2 transactions. It builds a sequence, like it orders the transactions into a specific sorting. And then it generates this zero knowledge proof. Once we have that, we just have to send to the layer 1 the zero knowledge proof and the transaction list. And so this is how a new batch is added. And while this sounds pretty nice, it actually has some problems that I'm just going to explain now. So first of all, this is quite slow because generating zero knowledge proofs, it's very intensive in terms of computers. And even if you have a huge machine, it will take some time. Hopefully technology will get better and it will get faster, but still definitely we are talking about of minutes in order, like in time scale. The other tasks are relatively fast. So it's basically building the zero knowledge proof and sending the layer 1 transaction. And then it's very easily to fall into centralization. It doesn't have to be, but because zero knowledge proofs takes a lot of time to be built, and to build such a proof, you need to understand what is the previous state, the previous block. Like imagine you are computing this proof, and by the time you're done, someone else have sent another batch to the layer 1. So the zero knowledge proof is no longer valid. So you have collisions, and like you're wasting a crazy amount of resources. But still, the cool thing about the zero knowledge proofs is that it makes the whole thing trustless, because it verifies the signatures and so on, which means that this operator cannot perform any action on behalf of the user. However, definitely there is some censorship vectors here, and the network could just be stopped if this operator falls down. So in order to solve this, we came up with this consensus protocol that we call proof of efficiency. And the main idea is to split the sequencing from the proof generation, and that actually enables a permissionless system that anyone can participate. So now the smart contract in this protocol requires to manage two different states. The virtual state, which is actually just the transactions, only the list of transactions, and then the consolidated state, which is adding the root, so proving the outcome of processing the transactions in the virtual batches. So actually the virtual state is quite cool, because since this is available on layer 1, anyone can synchronize this. So you could have your own node and understand this state update without the zero knowledge proof at all. So you basically read the transactions from the layer 1, you process them, and then you have a node that understands what is the state, like the outcome of processing the transactions. And this obviously happens way faster than if you have to care about the zero knowledge proofs. So then, like this rollup operator I was mentioning, it's also divided into different actors. First one is the sequencer. And so the sequencer just collects the transactions, sort them, and send it to Ethereum. And as I was saying, this doesn't require to build a zero knowledge proof. And hence, this process is quite fast. I mean, it's very close to layer 1 transaction fast, which is actually the better thing that a rollup has to offer, because, I mean, the rollup is still inside layer 1. So we will not get faster than that, at least not in a super trustless way. And besides that, as I was mentioning, this system allows for permissionless, so anyone can participate at the same time. The reason behind that is that these transactions that we are sending, don't know or don't care about actually processing them. It's like indicating to the network like, hey, you have to execute these transactions. But you don't need to know the previous state before sending the transactions. So here in the example, we have 3 sequencers that they are all trying to send these transactions. And when they send these transactions, they don't know at which position this virtual batch is going to be added. So it may be the immediate next one, or it could be like farther on. And by doing this, because the system is permissionless, we effectively decentralize the network. So it's no longer stoppable because, I mean, you can just, I mean, as long as you have access to Ethereum, you can keep adding these transactions. And also because of that, this became censorship resistance. Like, even if some sequencer was bullying you and blacklisting you, you could become a sequencer without asking permission to anyone and just send your own virtual batch into the network. And you may be thinking, then why to bother with ZK at all, right? I mean, ZK is very complicated, and it seems that we have everything. Well, this is not exactly the case, because the layer 1 doesn't understand the outcome of processing these transactions. And because of that, it also makes hard for the users, for the node operators, to know that they are actually in consensus. So how could, if I host a node, how could I know that everyone is on the same page? Well, if we have this zero knowledge proof sent, we have the root on Ethereum, and I can just check if the root that I have built actually matches with the one on layer 1. And by the way, by having this, and by this I mean like the layer 1 being aware of the state on layer 2, we can build very cool things, such as on-chain bridge that relies exclusively on smart contracts. And like we all have heard like super sad news about bridges getting hacked. But if we are able to just rely on smart contracts, this gets more secure. And by the way, there is a very cool presentation by Jordi Bailina explaining it. If you are interested, you can just go to YouTube and search for Jordi Bailina at LeaseCon. Yeah, so how are these batches actually consolidated? Well, again, like the batches are on layer 1, so we have a new actor, which is the aggregator, which will synchronize the virtual batches to know which transactions are involved in the proof that has to be generated. And once the aggregator has that, it generates a zero knowledge proof, and it just sent to the layer 1, to Ethereum, and effectively consolidating the virtual batch. So we move from the virtual state to the consolidated state. Unfortunately, this doesn't place that nice in terms of concurrency, because for each virtual batch, we have only one proof. And so the first one who sends the proof is the one who actually consolidates the batch. And so here what we expect that will happen is that the player, the aggregator that has the best technology will end up winning all the time, because this is not like proof of work that has some randomness built in. This is very deterministic. So if you have the best hardware, the best software, you will end up winning always. But this shouldn't be a problem, because at the end of the day, what happens with zero knowledge proofs is that either they are correct or they are not. If they are correct, the network moves on. If they are incorrect, the transaction just gets reverted and has no effect on the state. And like even if we only had one player and this player just disappeared for some reason, anyone could come in again and become like another actor that still makes the network move forward. Yeah, so the overall picture looks like this. We have the sequencers sending the list of transactions that has to be processed, and they can make it in a concurrent way, so it's quite safe and fast. And then we have like the aggregators trying to have the best technology, the most efficient technology, and consolidating these blocks, or batches, sorry. So you may be wondering, why should people actually participate on the network, right? I mean, where are the incentives? And here what happens is that sequencers collect transaction fees, sorry, so the gas paid by the users. And so they are incentivized to build the most profitable batches, which means whoever is paying the gas at higher cost and whoever brings more transactions in a single batch. But then, what's in it for the aggregators? Well, the sequencers have to pay a collateral, which is a reward that will be collected by aggregators later on when they consolidate the proofs. And here what we aim for is, we don't have the final formula yet, but the idea is that the more unconsolidated batches there are, the most expensive is this collateral. And so the idea is that eventually we get into a stable point where there is no big delay between the virtual and the consolidated batches, because, I mean, it would be horrible if nobody's consolidating batches. So if apparently nobody's doing that, sequencer will just have to pay more tokens in order to be allowed to place these virtual batches in the first place. Okay, here's a bit more tricky stuff, more in detail. But this system could face front-running attacks, meaning that if you're a sequencer sending these virtual batches, someone could read this transaction from the layer 1 pool, just pay more gas, and make it before. And so effectively, the next batch, like the honest batch, will get fully invalid because the previous one will have processed all the transactions, and so the second time they will be just invalid. So in order to solve that, what we have done is we assign a different chain ID for each sequencer in a way that transactions are only meant to be included by a specific operator, a specific sequencer. So if anyone were to front-run these transactions will be just invalid. In particular, the signature would not match, and so this will not have any effect at all in the state. And by the way, yes, it's a different chain ID, but it's still the same network. So you are not losing interoperability or anything like this. It's the same chain. Okay, so like this chain ID thing actually opens the door for new constructs that are quite cool. Basically, because transactions are meant to be included by a specific sequencer, anyone anyone can become a sequencer, right? So what could happen is like you have a dApp, and you instruct your users to use your own sequencer, which, by the way, right now is quite easy to do. I mean, you could just have a button in the UI, and then MetaMask pops up and say, hey, do you want to switch to this network? And, well, users say yes. And what this means is that the fees of the transactions of a specific dApp will be collected by the dApp itself, which in my opinion is great, because sometimes it's hard for dApp developers to find a revenue model, or they have to come up with tokens that may not be very obvious in terms of utility. But by doing this, they are now able to collect the benefit of these fees. So if you are a dApp and you are able to bring transactions to the network, you will be rewarded by doing so. And by the way, being a sequencer, it's quite easy in terms of requirements. You need basically a layer 1 node and a layer 2 node, and that's it. You don't need crazy hardware. You don't need crazy staking. So the entry barrier for achieving this is quite low. And this is probably like the most basic use case that we can think of. But then things could get more complicated and more interesting. For instance, imagine if you have like a NFT marketplace that it already has great revenues by having a cut of the sales. And so this dApp, what could use is say, okay, I already have money, and then now I'm able to make transactions free for my users. And so the logic would like, if the transaction is directed to my smart contract, I will accept it, and I will accept it with gas fee 0, because anyway, I will later on be taking profit of this NFT sale or whatever. And I mean, this is probably not as easy as I'm explaining it. There are more challenges here, but we are starting to think on these different use cases that, I mean, we're excited to see what people could bring with this model. And yeah, that's it, guys. So maybe now we have some time for questions.
Thank you very much. Any questions from the audience?
Okay, thank you. Could you return to the slide with different sequencers? So when different sequences trying to send different transaction lists, yeah, these ones. So what will happen if two sequencers will send the same transaction, will include the same transaction?
Yeah, absolutely. So this effectively can happen. And what would happen is that only the first one will get executed. Because at the end of the day, executing transactions is deterministic. So like this is bad for sequencers in this case because they will be including a transaction that later on will be invalid. And definitely sequencers would have to have kind of logic to avoid this. So like yeah, like you have to take care of it and maybe try to ban bad users or whatever. But like this will only happen if the user is malicious in the first place. Because I mean, like if you are sending the same transaction to different sequencers, you are clearly misbehaving here. So this is a risk that sequencers have to manage, definitely. And it's a potential attack, yeah.
But do you already have the implementation of this sequencer or not yet?
Okay, so we are right now like developing like crazy, full speed. And like the ZKVM is not ready yet, but it should be relatively soon.
Okay, thank you very much. And also, I was a little bit confused about the part where like there is one validator that's basically doing everything because of the compute power. Why exactly can't he just like add some transactions that are malicious there, always verify them, and basically be like the main chain?
Okay, so here is where the zero knowledge magic comes into place. So basically what you have is an off-chain computation that cryptographically proves that the transactions has been processed correctly, but then verifying this on layer 1, it's super cheap and fast. And so part of this logic that happens in zero knowledge realm, it's to verify signatures. So,
but you're telling, so there are sequencers and then validators, how are they?
Aggregators.
Yeah. Aggregators. So the aggregators are doing the ZK stuff, is correct?
Yeah.
Yeah, but they can manipulate not the ZK proofs, but manipulate like what the blocks that they included over there.
Yeah, okay, so the idea here is that because the list of transactions that has to be processed, it's already on chain. So they have to wait for this data to be on chain, and then the smart contract ensures that only this data that is on chain is actually processed in the zero knowledge proof.
But if, aren't there going to be competitions in like those batches that are already on chain? Or do you trust that all of them are non-malicious? Like, how exactly does it happen?
Yeah, okay, so, so sequencers send transactions, but there is actually no check at all at layer 1. So you could send like even a picture of a cat there, right? I mean, you can basically send whatever you want. But the thing is that if you send like incorrect data, incorrect transaction, this will have no effect at the time of processing it. So as I was mentioning, like processing this list of transactions have a deterministic outcome, and part of the checks that are done is like, is this transaction correct? Yeah.
Okay, interesting. But anyway, like the guy who chooses, okay, I need to do more research probably before making new questions.
I have a question. So how this consensus algorithm is like different from the Mina's one? So where the sequencers or the block producers are chosen by the VRF functions, and then the snark builders are like doing the snark work. So the only reason that I'm getting here is that you are not, the sequencers are not staking here. Mm-hmm. So what's the difference between like pros and cons, and why this?
Yeah, so I'm not fully aware of what Mina guys are doing, but basically here is permissionless, meaning that you don't require any permission at all to participate. it's kind of first in, first served. And yeah, you can just go in and as fast as you can.
Any more questions? Probably not. Thank you very much. Yeah,
Sure, thank
it
you,
was
guys.
really interesting.
And now we're having another break.
Yeah, so half an hour break, and yeah, you can come in here. Later we're going to have more talks.
How many minutes? 30 minutes, again.
Do you need some speaker notes or just the slides? Okay, then just slides, yeah? Nice. Okay, so I agree, but some people requested, so.
No, when I visualize it, you're cheating, you pretty much make things.
Yeah, some people prefer to just read something. So yeah, you can use Clicker if it does works.
That's not me though.
Sorry?
That's not me.
Okay. Oh, yeah. Okay, I missed.
I don't
know. Okay. But sorry. Do you have your slides somewhere? Maybe you can create like a short link or something. Yeah. And got confused somehow because I'm not in charge of these spreadsheet. Yes, it is.
Just get his plugin in.
Yeah.
No,
his
wait.
Gmail. You
need to turn on the computer.
Let's do it this way. Yeah, so we can probably check the Gmail because it's in.
Look for form. Change dynamic. Yeah,
here it is. Done.
No, because I shared them. Go back to the search.
Okay. Yeah, it wasn't right. That's probably why. Okay, so this should be it, and let's switch back to the duplicates.
It's funny how which is the difference on the Mac and Windows.
Oh yeah. Which one do you prefer?
I don't know. That's a good question.
You've never seen the Windows one. Hello everyone. No, it's all good. Hello everyone. We are ready to start already, and here the Juan from MakerDAO, who is about to give you a great presentation.
Thank you. Thanks for raising the expectations.
I do.
Okay, guys, let's get started. My name is Juan. I'm the core unit facilitator at MakerDAO SES. That's Sustainable Ecosystem Scaling. And the facilitator, what they do in Maker is they are the point of contact between governance, which is the MKR holders or their representation, and the team, which has been appointed to do something, again, by governance. This is a bit my journey to the DAOs. I worked on different big firms doing consulting, some consulting for big clients also. Then I was fascinated by startups and scale-ups, both in Barcelona and Berlin, and I ended up in the DAO world, mainly in Maker, and that's a bit what I'll be discussing today. I'll be taking questions at the end, so if anyone wants to know about something, please let me know. So what is a DAO? I'm not a maxi, so I don't want to start a big debate about this is decentralized enough or not. There are different opinions about this in general. But basically, for those that don't know, which shouldn't be a lot of people here, but it's a decentralized autonomous organization. Decentralized usually means that there's no person to go to. There's no legal entity behind the DAO, and it's governed by a protocol. Autonomous means that teams are formed independently. They make their decisions independently, and they are mandated by the token holders or the voters. And finally, the organization part, it's a bit the joint purpose. It's the vision, the shared community, and it means that they need to report to the holders. So for me, if those aspects are there, at least present, or the intention to get there, we're getting somewhere. And again, it's not binary, it's a spectrum, so you can be trying to decentralize even more. But what really is a DAO, it's a structure that supports decentralized work, capital, and workforce. And these three pillars are quite important. So we're going to be reviewing them quite often, but it's basically people, the capital to incentivize them to finally do something, which is a vision or work or whatever we want to achieve. So at the very early stages, when we're bootstrapping a DAO, usually DAOs look a lot like this, right? So we have a core team which is being funded by a treasury. There might be some VCs outside, so we get the funds from there. They are developing a protocol. Hopefully they have some kind of product market fit, which means that they have actual users and they're solving a real problem. This protocol might or might not be controlled up to some aspect by the token holders, so they might be developing some kind of governance mechanisms, and the community pretty much helps the core team. It's like, hey, I have an idea, or maybe we should do this, but it's the core team which is actually developing and delivering on these ideas. So yeah, scaling a DAO. So what happens once that we move to the next step? And I'll tell you a bit what happened in Maker, but you might have heard that the Maker Foundation decided to dissolve last year. So a bunch of different core units popped up, which are directly funded by the protocol, which is governed by the MKR holders. And yeah, we do have real revenues. You can check them live on chain. But the users are, the vault users are funding the protocol through the stability fees. And then that funding is pretty much used for the core units to develop the protocol even more and to grow further. There's this little issue with DAOs that you need to be thinking about the final user of the protocol, but you also need to think about who your boss is. So in a hierarchical company, it's quite easy to understand who your boss is because you see the hierarchy pretty clearly. In this case, the MKR holders or any type of token holders, it's not particularly clear who they are. There are some delegates, so that helps a lot because you can at least have some conversations, get feedback, try to understand their vision or where they want the protocol to get. But that's the main issue that they have. And the delegates, when they are trying to get something done, they need relevant information, so they need to have these things ready. They need the experts to evaluate the proposal if it's technical. They need tools to evaluate if the work got done or not. They need the right incentives to vote. So in Maker, for example, you are paid to be a delegate. And they need to be able to cut through the noise. So we have this, which is a nice problem to have, I guess, but our forum is almost a full-time job, just going through it. There's a lot of content all the time, which is great. We love ideas, but at some point, that pushes the limits of any delegate or contributor. And the core units, on the other hand, they need to be, well, first of all, there's a flat hierarchy. So this means that no core unit can impose on another core unit. And this is quite important because if you want to become a core unit for Maker, you cannot say, I'm going to build, I don't know, financial structures so that the other core units need to do this, because the other core units are, first of all, already approved. And then you cannot be mandated to do something for the other person. So what you have to do if you're a support core unit is a bit try to cater to the users, lead by example, and say, hey, we built a tool which is really, really easy to report on your finances. Can you please start using it? And then it's a bit the delegates or the MKR holders that are going to be pushing for these tools to be used. So it's not like there's a boss that comes directly and says, hey, everyone needs to do this now, unless it's the delegates and they have the voting power to vote a core unit out. Yeah, they can coordinate with other core units. This is important. It happens a little bit in a generic way. It's like in every other DAO, if someone shows up and they want to do something, usually there's some momentum and coordination happens almost organically, but it's not something simple at all. And finally, they can be redundant, and this is also important. When we need to, or sometimes we criticize organizations for not being efficient. In a DAO, this might be a little less important, as redundancy might be crucial for a DAO to survive. So this is a bit what a DAO at scale looks like. On the left, we have the centralized organization, the hierarchy, as I was talking. You have an executive team, which could be the C-suite people, or the board members that are giving like more abstract directions. And then you have a bunch of middle management. And at the end, you have the execution or the people getting the actual work. So this is a little secret of the DAOs, but to replace that middle management, which serves to actually control and make sure that things are getting done, you need some core units that are focused on transparency and quality control. And this is quite important because when they propose things like that, it seems like it's a waste of money. So it's a waste of funds. Why are we doing this? But at the end, it will be quite crucial to give MKR voters or the delegates a view on what's happening across the DAO. So there are different frameworks or different tools that they can build for core units to either self-report or say they are doing what they're doing. Another example could be the engineering teams are actually documenting their code. So there's a bunch of different things that can be done from the DAO perspective to ensure that this middle management layer that disappeared has actually a way of still giving the value, providing the value that they were doing. So to recap a bit, sustainable ecosystem scaling, that's my core unit. And what we do is that we're helping MakerDAO to remove barriers between decentralized work, capital, and workforce. Again, these are the three pillars that I was mentioning, and they're quite important. And today I'm going to talk about three different challenges related to those three pillars. So the first one, you probably all suffered it, is getting talent. So it's getting the people, attracting them, making sure that there's a good culture. How do you lower the entry barriers for new teams? How do you reduce the opportunity costs? The second one, it has to do with the capital. So what challenge should be tackled next? Towards where should we grow as a protocol? How can I help Maker grow? What are the related costs? So those are other challenges that we've been facing. And finally, managing the work. As I was mentioning, how do we make sure that the work gets done? And most importantly, how do we coordinate people over the Dunbar number? And for those that don't know, up to 150 people, we're all supposed to be very natural and coordinated as humans. After 150, it becomes much more complicated. So we've been trying a couple of things. The first one is to set or improve frameworks that we already have. The second one is an incubation program, and the third one is applied research grants. And I mean applied research because they're very, very concrete in nature. So it's not like some crazy PhD grant. So that's what we're going to explore now. So on the frameworks, right before the foundation dissolved, I contributed to the MIP framework by giving a bit of feedback, and especially to the core unit framework, which, as you have guessed, it's the vision for a core unit, the funding or the budget, and finally the facilitator, which is the person responsible. But yeah, we have I think around 70 MIPs by now. This is not new to Maker. There's 100 protocols that have the same thing. Ethereum, Python, I don't know. And yeah, this is permissionless, so anyone could come and propose any MIP in the forum, and they would receive feedback, eventually get voted, and it could become the law, right? Our governance process, it has two components, the off-chain part and the on-chain part. The off-chain is very, very public. With public, I mean open, so anyone can come. You don't need MKR to participate. You can comment, you can give feedback, you can propose your own. And the on-chain is very much dictated by the token holders, the MKR holders, and especially the delegates. So that's a bit what we're doing. And it's delegated plutocracy, which means that if you have more tokens, or if a delegate has more tokens, he has more, they have more voting power. So on the MIPS framework, if you people are building something similar to govern your DAO, things that could have gone better on this aspect, well, first of all, the core units, we didn't plan much for an offboarding process. So when the community wants to offboard a core unit or fire a core unit, it didn't look very pretty for us. I mean, firing someone is never pretty, but it was quite dramatic, very public. So maybe thinking about how would that work as well. The second one is quite important, is better templates. So the templates that we did were quite generic and very, let's see what happens and how people use them. Right now we're working on improving them, but it will be good to direct contributors to give you the information that you need or that MKR holders need to actually judge the proposals. Then maybe include performance metrics, include a roadmap, include a plan, so that those are things that right now might or might not be there, and then the community might give feedback like, can you please include this? But it's not in the template, so that will be my key takeaway. And then we have the collateral onboarding. So this MIP set is, well, we also use the MIP framework to onboard collateral. So at the very beginning, we didn't think about offboarding processes, and we also didn't think much about the off-chain assets. So that's real-world assets. So those are things that we could have, yeah. I mean, in hindsight, it's quite easy, but we could have worked better on them. The second thing that, second thing that we tried is the incubation program. This is quite exciting for me. It was run by SES for the last almost year now. And yeah, why incubate? There are many reasons. So usually contributors don't know how to set up a core unit, what they should work on, what challenges we're facing, how they can contribute, how Maker works. So all these things are challenges and are barriers to entry that you do not necessarily need to impose on people that are interested in helping. So yeah, that's our governance process as I was explaining it, and a rough timeline. So basically a timeline without incubation for anyone wanting to form a new core unit for Maker would almost mean 3 months of the team going potentially without compensation for any of the work that they're being done to become a team. So that's why we decided to test the incubation program. The goal was to reduce this, provide them with education, capital, and support, and to make sure that they successfully got onboarded by the MKR holders to as a core unit, as an independent core unit. And this is quite important. It's not our core unit that decides if they're going on or not. It's really the token holders. So that's in one case, for example, we did not manage to incubate them. The token holders said that it was not that's not what they were looking for. So lessons learned from the incubation program. If you ever decide to run your own for your DAO, focus a lot on the facilitator. In some cases, we started with teams, and then leadership is not clear. There's not a lot of accountability, and it becomes quite chaotic. So make sure that they are almost an entrepreneur and someone very self-starter, because they will need to show the value to the MKR holders, or well, in your case, the token holders. They will need to recruit people to get help. They will need to do a bunch of admin work that they might not like. So someone that either started something or they worked in startups might have a good profile for that. Another thing is to focus a lot on minimum viable operations. So when you tell someone how much budget do you think you need, they will think big and they will explode the budget, which is great. But the governance might not like that. So the token holders might be like, that's a bit too much. We don't know these people. We don't know if they're capable. So try to start thinking on minimum viable operations, and then they can scale. So you can say, we are going to work on this problem. When eventually we prove that we're our worth, we can scale it up and go even further. And the final one, our incubation program was 5 to 8 months, more or less. And the community feedback, we got it quite late, almost at the time of the votes. So my advice would be try to get community feedback before, so you can adapt if necessary. It doesn't need to be binary at the end, yes, no, but you can adjust the path a lot more if that's what you're looking for in a successful incubation program. And the last topic that I wanted to talk, it's the grants program, which is it's quite yeah, I really enjoyed this as well. We didn't have a lot of structure, But this is a bit how it worked, right? So again, we have the three pillars: the idea, the funding that was provided by us, and the individual who was someone that actually wanted to achieve this. And then, yeah, hopefully the grant was a success. So again, important things about these specific grant programs, it was not based on bounties, so it was not very, very well defined, and I think that was a feature in our case. It was very much discretionary, so we could decide to whom award it and how, but it had to align with our vision, right? So if someone said, hey, I want to build a portal about that, if that for us was not going to scale Maker, then we would reject it and tell them to go get the funding in some other core unit. And finally, we are the ones, as a core unit, being evaluated based on the output of the grant. So that's why we had to keep a close eye on the program. So lessons learned on the grants program. First of all, focus on the long term. I think that getting someone good in the ecosystem that's interested is almost much more important than the scope. So the scope can be a little bit blurry in the beginning. Just make sure that you're betting on the right person more than the right idea. You don't need to over-define that. That takes a lot of time and effort, and that might make things harder. The other one is pick your words. The grant is the means, it's not the end. And as I was saying before, if it doesn't align with your vision or what you are trying to achieve, it might not be worth pursuing it. You're not there to run a grants program. You're there to achieve a vision, so you should focus on that. And the last one, well, I already mentioned it, but it's keep it loose and check in often. So ideally, even once a week is not, if that's good, and it doesn't need to be with you, it could be someone with your team, but having like a regular meeting where you can discuss how things are going, they can tell you, hey, I'm having a hard time finding this information, so you can maybe help them. So I think that that's something that's quite good in this context. So yeah, those are the learnings. I don't know if anyone has any questions.
Thanks. Yeah, I just had two quick questions, if you don't mind. One was, how do you ensure accountability within the DAO, that these grants or contributors are actually meeting their goals? What methodologies have you actually put in place for that? What mechanics? And the second is, how are you reducing the noise that you mentioned that's trickling down from the community, potentially, or the token holders to those core units? What methodologies do you have to filter that noise?
Thank you. So for the, what was the first one?
First one was accountability.
Oh yeah, so accountability, I think that depends a lot on the DAO. Right now in general, what I see in different DAOs is that you have a lot more funds than talent. So you might take riskier bets, meaning that you can allow for someone to scam you or not work for a couple of weeks. But in the example of the grant, if you're checking in every single week and you can see the progress, you can see if it's going on track or not. And again, because we are being judged as grantors, I don't want to have a grant that didn't go well. So I would cut that beforehand. Second thing, super important, is to set the expectations right. So again, that's something that maybe it's clear for one, but it's not, and it takes some time to get it right. And finally, as I was saying in the beginning, I think that there are some groups that could focus on developing either tools or mechanisms for everyone to report. And if everyone is following a best practice, and it's quite easy to do, and your team is not, then the token holders might come and ask you, why are you not doing it if it's so easy? Why are you not being as transparent as we would like to? So I think that's on the accountability part. And the second one
was in relation to the noise that can often come trickling down through token holders, community, and how you protect or how you what you set up for your core units to succeed?
I think that's a tougher one, or we haven't solved it yet. What we do have is some core units that are trying to produce summaries. For example, we have a group doing a forum at a glance every week. So they would release, hey, these are so you can get like almost an email that's like a summary of important things, and then you can dive deeper. The issue is that you are introducing a bias, right? Like maybe some issue that was actually important for you is not there, so you're missing it. So I don't think we have solved the noise yet. Again, I think that the important things need to be tackled almost by professionals. So yeah, right now we're trying to get people to join our transparency and quality control track, and to be able to produce frameworks, to produce reports, and to show the MKR holders, this is what's happening with the DAO, this is an overview of the DAO, ideally in some dashboard. So we do have a couple of really good dashboards, but not for that yet. So we're building that as well.
Great, thank you.
Thank you.
Any more questions?
Thanks. Oh, just if you're like a centralized type organization, kind of like a more traditional one, and you want to kind of, or you aspire to kind of transition into a DAO type model, how quickly should that occur? And like, what are the hallmarks of things going the right way? And what are like milestones that are kind of like emblematic of things going the wrong way with regards to transitioning from the centralized organization model to a DAO model?
So one of the things that a DAO is not a corporation on chain. I would find it quite hard to decentralize a company that was born centralized. That said, I do think that it's possible to be born centralized with the idea of being decentralized at some point. So you start preparing quite early. And there's a lot of things that you can start doing from the tokenomics part. How are you going to compensate contributors? Yeah, for me, one of the pillars, and again, we can go back to the 3 pillars, but you need to have a community that is going to take it up whenever you leave it running. The second one is that you have some kind of product market fit, ideally that can sustain that full community, and if you have even more, then even better. And yeah, the last one is the product, which is the vision realized. Ideally, you have some kind of draft of what's happening, and for me, those would be quite important hallmarks to hit before actually turning off the whole foundation parts. Otherwise, I see it quite complicated to manage something in a decentralized way. Thanks.
In your opinion, what are the strong signals to qualify this is a good DAO, a good performing DAO to join, or like this DAO is not doing well and maybe I shouldn't join it? Does that make sense?
Like which token should you buy?
I'm just asking on criteria and in general, like, you know.
Like what's a good DAO to join?
In general, like how I would know this DAO is promising and like there is sustainability, if that makes sense. Like,
yeah.
You know, I know a lot of DAOs, they are not there anymore, 1 year ago. So how can I early know these signals, if that makes sense?
What I personally look for is first if I align with the vision, and it doesn't need to be save the world or the oceans. It can be something like I like the product and I like the way they are approaching it. For me, the team is super important. So I will try to have a couple of conversations. If they're friendly and if they are smart, I think that's another good sign. And then another one that I would look at is the sustainability part and making sure that they are getting some kind of revenues, or at least that you say, okay, they are based from a foundation still because they haven't found product market fit, but they should have a runway for, and sometimes the wallet is on chain, so you can even check this is the amount that they're spending, so even if they double it, it should last for the next 2-3 years, so it might be a good bet to join. So I would look on those things, but it's very personal, and I think that's a bit the beauty of it, that anyone can almost work on the DAO that they want. And yeah, by the way, almost everyone probably knows it, but I think that the price of admission is wanting to be there, right? So when I interview someone, I'm almost trying to show them all the bad things. And if at the end of the interview they're still like, okay, I really want to join, then I know that I have someone. But if I need to go out and convince someone, I think that the hurdles and the fact that everything's so new, it's quite challenging in general for anyone. So that makes it harder. So I tried almost to dissuade them to join, even if I would like to do otherwise.
Thank you. Anything else? Because I've got questions of my own.
Shoot.
Yes, so I want to know, what are the numbers? So how many core units do you have? How many did you fire? And how many did you onboard through the process?
Thank God that I put my slide. This is a snapshot from last quarter. So yeah, SES is right there. Maybe the mapping is not perfect, but sometimes it's hard to group them in kind of groups. So the ones on the bottom right are the ones that graduated from the incubation program. The one on the bottom left is the one that was offboarded. And yeah, those are a bit the actual numbers.
So it's the only one that's crossed, yeah?
Yes.
And no more were offboarded?
Not yet.
Yeah.
We're working on it.
I see, I see. And do you try to offboard people and not teams in general?
No, that's a hard one, right? Because the DAO has an agreement, an on-chain agreement with the core unit and its facilitator. So it's up to the facilitator to get to that vision and make sure that they're delivering on what they promised. But we had, for example, a challenge when this core unit was onboarded. There was one contributor that said I didn't get paid by this core unit. They rugged me. So it's like, okay, should the DAO be responsible for that or not? Because the DAO doesn't have an agreement with the contributor. So it's a bit up to the contributor. But then you might be losing face. You might be losing reputation. So those are things that you need to balance. And again, if you're ever building a framework, try to think about that and make it quite explicit, because you'll be surprised to the length that people go to not follow things.
Okay. And one more question is regarding the remuneration. So how is it structured? What is the fixed price, and how many, do you pay in stables? Do you pay in your own token? How does it work?
So right now, you could potentially, so when you're proposing your MIP set, you propose the MIP for the vision, you propose the MIP for the budget, and the one for the facilitator. The one for the budget could be more than one, actually, and you could actually split it. So for example, you could say, okay, I need this MIP approved, and usually it's in DAI, which is the operational wallet, and this is how much I need to keep my team running. Then you have the MKR compensation, which is a bit like the token from the protocol. I would say most core units have that as well. And so that's a bit like a bonus, and you have vesting, and we're following those things. That's another interesting one for frameworks if you guys want to discuss later. And what some teams do is that they propose an additional budget. So it's like, I would also like to do this project. If you want me to do it, then I would need this extra amount. It could be in DAI, it could be in MKR. And if it gets approved, then it's a bit of a green light to go on and do that.
Okay, thank you very much. So it seems that we are done. Thanks a lot for your presentation.
Thank you.
For anyone who is building a DAO, it's definitely valuable. We are a DAO as well, so yeah, we have to learn. Yes, I do, but it's on file managed. So, do you need the speaker notes or something? So it's for you.
Can I put this on?
Yeah, probably here as well. Yes, so this is Lucas from Gnosis. So please welcome, and yeah, hope you have a good time.
Cool. Okay. Yeah, hi everyone. I'm Lucas. I'm from Gnosis. I'm leading the Gnosis Safe project there. Maybe to start off, a quick show of hands. Who knows what Gnosis Safe is? Okay. Most of you, like, who's actually using Gnosis Safe yourself as a signer? Or, okay. For those who don't know, Gnosis Safe is basically the most secure way to manage digital assets in Web3, to store and manage digital assets. And why is it important that you have like the most secure way to manage these assets? It's that Web3 still feels very much like Wild West, and that's in like the good and the bad way. Let me maybe elaborate a bit on that. The good way, like kind of how I would imagine the Wild West to be. I haven't been there, so I don't know. But it's like this new uncharted territory, which like allows to have a lot of freedom for everyone to kind of like build new things, detached from kind of the old structures. Yeah, lots of opportunities, and yeah, a lot of individual freedom. But this also comes with like the bad things. If kind of there's a lot of kind of individual freedom, this also means individual responsibility. And especially because it's kind of like a new territory, like a new systems being built, there's little protections that can kind of help the individual there, and that's also providing kind of like a incentive for bad actors to abuse this, to kind of yeah, abuse the responsibility everyone has and kind of attack individual ones. And that's kind of also the same we experience in Web3 today, is that, yeah, it's amazing, like we're building new technologies, new ecosystems, like we're exploring many new things, from rethinking how governance works, how digital identities work, like how we transact with each other, how we build marketplaces. We give a lot of freedom to individuals. Like people finally are able to kind of are being in control of their own assets, of their own identity, to transact with whoever they want. But then also this means that everyone is responsible themselves in kind of ensuring the security of their assets. And this, of course, provides kind of like a big attack surface for anyone to kind of attack and to kind of abuse this from, yeah, kind of, yeah, and to maybe share some examples there, and kind of the source problem behind it is really that most people using Web3 today are doing so using a private key-based account or externally owned account, EOA. And what this really is an account that's controlled directly by a single digital private key. So that means it's a private key that has full kind of root level access to an account, to all its assets on it, to all kind of its affiliations. And if a user has access to this private key, they can do whatever they please to do. They can transact freely. Yeah, they are in full ownership. But it also means that if a user does not have access to this private key, they cannot do anything. And also, on the flip side, it means if someone else gains access to this private key, they can also do whatever they please to do. There's no security protection there in between kind of the user and the transaction. And this leads to some challenges where, like, how do you then store this private key? And we came a long way kind of abstracting away this like random numbers and letters with seed phrases. At least this is something that you can kind of write down. You can store it securely offline. But yeah, just I personally don't think this is going to be the solution to it. I know too many people who still store their passwords in kind of like Apple Notes on their phone. And if they're going to do the same thing with their seed phrase, this is going to get quite messy. So yeah, seed phrases are still not the solution there. Also, some people say, yeah, this is just kind of an educational problem. We just need to teach people how to securely store seed phrases, how to kind of give them the tools to operate and to kind of have kind of security best practices. But in fact, even today, we see the most experienced Web3 users, the most technical users, still occasionally kind of being victim of of hacks or compromised keys. So if that happens, how should we then think that like a regular non-technical users should be able to do that? And yeah, I don't think this is a fair assumption to make. And especially because this is also a big honeypot for like phishing attacks to get more and more sophisticated. Whereas phishing attacks in Web 2 have been around, kind of compromising data. But in Web 3, attackers can directly compromise assets, can directly compromise money. So this is like a much bigger incentives for phishing like attackers to get more and more sophisticated, to build more and more ways to go around and kind of trick users into doing something they don't want to do, or like losing their assets. And one thing that's also amplifying there is that really no one really understands what they're signing if like MetaMask is popping up. Like we've also improved there. But in the end, like most people I would think are still, if MetaMask is popping up, they don't even read what's kind of displayed there, and they're just trusting that this is all right and just going ahead with it. Yeah, and this just means that you're always, because there's really just this one private key in between kind of you and your assets. It's just this one click that can compromise your entire account. And so technically everyone should read, kind of understand exactly what data they're signing, but in fact this is not what we see in reality. And this goes beyond like individuals. So like issues with compromised private keys are all around, with projects, with DeFi protocols, with companies also experiencing hacks and compromised private keys. So DeFi protocols, but also like very essential infrastructure such as bridges, which leads to multiple hundreds of millions of assets being compromised. And so there's, yeah, just kind of this huge honeypot out there. And like worst case, this leads to an incentive to even apply physical force to compromise private keys. Luckily, we don't see this too often nowadays, but I'm sure if kind of the adoption of private key-based accounts continues, so like everyone has somewhere like their seed phrase stored at their home, or like is running around with like their wallet on their phone, this just gets more and more of like a reason for criminals to use also physical force. And I don't want to live in a world where I have to run around with bodyguards in order to make sure that I'm not getting kidnapped or getting blackmailed. So what's really the solution there? So I've been kind of shitting on these accounts for 5 minutes now, but I should now have proposed something to make it better. And that's where the shilling starts, because that's where Gnosis Safe, that's what we want to solve by building kind of a solution for all these problems. And Gnosis Safe, for those who don't know kind of in detail, it's really a programmable account. Programmable, what does it mean? It means that you can kind of define freely how an account is being accessed, and you can build security systems around an account that can kind of protect you around kind of like this, these attack vectors that are inherent of private key accounts. And so most people might mainly know Gnosis Safe from kind of the multi-signature ability. So that's the idea that you have not just one key controlling your account, but you might have 2, 3, 4 keys that control your account, and you can even say, I don't need all of them to make a transaction. Maybe it's enough to have like 2 or 3 of the 4 keys to make a transaction. And what this allows is that you can say, I might have some keys that I have kind of easy access to. Maybe one key is on my phone, one key is on my hardware wallet, and they have access rights in an account. I already reduced this way kind of this single point of failure, where you just have like this one private key. But then you can also have keys that might be like very securely stored in like a Swiss bank account or something like that, which allow you to set up like a backup system in case you lose these kind of like carry on keys. That's kind of like the basic way how most users today use Gnosis Safe, and that already kind of makes it much more secure to interact with Web3 applications today. But actually the vision behind Gnosis Safe goes way beyond that, because kind of the programmability means that you can do anything that you can code in Solidity, you can use as a way to kind of extend the access control of your Gnosis Safe. So that means you can implement permissions. For example, many DAOs use Gnosis Safe, and in a DAO you might want to give permissions to the token holders directly, meaning you might have like a core team that's like managing a treasury, but you want to have the token holders also have some kind of impact on this treasury and trigger transactions. So you can add additional permissions there to do transactions. You can even do limited permissions. So you say you might have like a very secure setup, so with like multiple private keys, but you want to have like a less secure one, or like an easy access setup for smaller transactions. Say you want to have like a limit, like a daily limit to spend 500 DAI, and then you don't need to collect all keys. But if you want to make a bigger transactions of like 1,000, 10,000 DAI, you need to actually go and collect these keys to conduct the transaction. That's permissions. Then you can also implement transaction checks. What this means is that you can say for this particular safe, there's like a set of checks that need to be done with every transaction in order for the transaction to be executed. What you can do with that is that you can, for example, limit the scope of a safe, saying that this safe, it shouldn't be allowed to do anything. It should just be allowed to do like a certain number of contract interactions, or call like a certain functions in a contract, or something like that. You can also have transaction checks where you say you have full control over your account, but with every transaction you loop in like a third party, a trusted third party, and they need to also kind of attest to this transaction. So this third party cannot do anything with your account directly, but they can kind of attest a trusted transaction. And this could be, for example, be used for like insurance providers, where they say we insure your transactions, but only if you have our kind of go-ahead for this transaction, and you can build nice products out of that. That was transaction checks. You can also implement recovery schemes. Some examples there is that you might have control via your private keys, but in the worst case where you lose all your private keys, you don't even have your backup keys anymore. You might have a mechanism where you can go to like a group of friends, to family members or so on, coordinate with them and recover access to your account. You could have also, again, like a trusted party involved, like a financial institution, where you say, I can kind of go through like a KYC process, prove that this is actually my account, and then they might have some system to give you back access. Maybe they have to place a bond in order to, that there's ways to make this in a way that's actually also trustless, and where the third party cannot just kind of compromise your account this way, but this is just something that could also be explored. And finally, you can also do automations, where you say your safe might have some actions that are being done automatically in case certain other events happen. For example, that you kind of protect like the collateral that you might have in a lending protocol in case of the collateral ratio becoming too small. There's kind of an automated transaction there that kind of saves your collateral. These things can be done as well. So in the end, through this programmability, you really just have kind of this freedom of creating many different things on top of this kind of account standard. And so we think that we can never eliminate phishing, we can never eliminate user errors. These things are just there, and we rather kind of build better solutions to address them, better solutions that when these things happen, when someone signs a wrong transaction, when someone makes like a human error, that these things are not as detrimental. So you have safety nets, you have some mechanisms that kind of protect users in that way, and that's kind of the antidote that we see to these very simple private key-based accounts. That's where kind of the power of Gnosis Safe comes. And so we're building ourselves kind of this integrated solution, like a set of mobile and web app that allows you to create safe accounts, to manage your assets, to interact with Web3 applications. And this is kind of like a product that we are building. But actually, like the idea behind Gnosis Safe is that we're building this framework, this middleware where others can build upon. So we're kind of providing the protocol, and we're providing infrastructure, and we're also providing interfaces which others can then extend and can build very specific solutions, very specific experiences that might tailor to like NFT collectors, that might tailor to DAO treasury managers, that might tailor to enterprise clients, and that there's kind of this ecosystem of tools and solutions being built on top of what we provide. And there's already about, I think now it's roughly 20 front ends that kind of tap into this infrastructure that we build. So that's from Parcel and CoinShift, who are like focusing more on the DAO treasury use case. It's Linen, that's more for the retail investors. It's Rabby, which is a browser extension, which also integrates Safe. So we really want to kind of push others, such as wallets and kind of solution providers, treasury solutions, to integrate with the Safe and leverage this power of this programmable account under the hood. Yeah, and we actually set up now last week a designated foundation to kind of foster this ecosystem, to really have like an entity focused on providing help to building infrastructure for others to build upon. You might know kind of Gnosis as doing like many different things, and we just realized that we need something that's having like a stronger focus, and that's really kind of the sole purpose is building out this ecosystem, and this is building out these other teams that are leveraging Gnosis Safe. And we're already preparing kind of like a first campaign through that, the Safe Guardians campaign that's initiated by the foundation, that's kind of supporting these teams that are building on the Safe and providing the right incentives. But that's really just a sneak peek. It's still quite early on. So yeah, if this sounded interesting, if you like a wallet provider, or you think somehow you could leverage Safe under the hood, please approach me. I'm also going to be at the Gnosis booth afterwards, and also take any questions now. Thank you.
Thank you very much. So, yeah, we are ready to take questions from the audience. Anyone's got any questions?
Yes, thank you for the presentation. One question, do you have any mechanism considering a dead man switch, which is a way to trigger an owner losing something like that, where you could trigger a recovery of beneficiary or something, which could be configured in Gnosis Safe wallet?
We don't have this built by ourselves. I think that there was a project in the past that did like a proof of concept of that, but it's definitely possible. Like, this is the idea of this extensibility, this modularity, that you can build these recovery mechanisms yourselves, or like a company could go ahead and build these and provide this as a solution. I don't think there's like a production-ready solution at this point, but it could be quite interesting for someone at the hackathon or something to take this on.
Thanks much for the great presentation, but it wasn't quite clear how mature is the basic product?
Well, there's right now about $80 billion of assets stored on the Safe, and most of it via kind of the...
I know Gnosis Safe. I mean this smart Safe. How mature is it? Is it concept level? Is it production that people can build on? The smart Safe.
What's the smart Safe?
Well, weren't you saying that, or is this a new version of Gnosis Safe which would have all of these additional features?
Well, you're referring to this one, right? So, I mean, this is kind of the concept of the Gnosis Safe on kind of the protocol level. The product that we currently have out there built by ourselves, it leverages some of them. So we have, for example, in the permission section, we do have like a spending limits feature in our product to kind of showcase how this would work, how you can set like daily, monthly, yearly permissions. Like the others, we don't leverage too much today, but there's other solutions that do, that are also production ready.
But do they like integrate with the already deployed Gnosis Safe?
Sorry?
So how exactly, like, do you add those modules, or are they already the part of the product?
So I mean, the modules are added on a contract level. So if you deploy a safe, you can immediately add a module, but you can also add it later on. And this can be abstracted away from the user quite a bit, where kind of a module enables new functionality, and it just exposes the functionality, and they don't need to know that there's a module. Ideally, you show it so that you're not surprised if suddenly you see that there's a module attached. But yeah, in terms of the spending limit that we provide, like, this is something that users need to opt into. We don't deploy safes natively with this module. So if someone wants to use spending limits, they go into our interface, they see, I want to have this feature enabled. It says, like, you need to enable this module to do so. And after you've done that, you can add spending limits and do that.
Okay, thank you very much. Anyone else?
You mentioned about having the grant fund available to try and encourage ecosystem partners to build on top and make use of these different features. Are you planning to continue extending the Gnosis app itself to start using some of these features, or are you going to kind of like offload that to the community via the grant program?
Yeah, so our goal is that the safe interfaces part there becomes as modular as possible, so that it allows you to use the interface that we built and kind of add functionality to it, like build these, like customize it as much as possible, and provide kind of ways to kind of expose your solution to users. But we also want to encourage others to kind of build the full segregated, like separate solutions that are not living inside our interfaces. So yeah, like right now we have this way to create safe apps. That's like UI extensions in our UI that you can kind of build these use cases in our interfaces. But yeah, there's, as you see, also like others that build completely different front ends. And yeah, our goal is that the interfaces enable more and more that you don't need to build different front ends, that have the interface becomes more of like an operating system, which then can be customized however kind of what use case you have. But yeah, this is going to be kind of the long-term idea. I'm not sure, like in the next 1-2 years we will be there.
So it seems that we are done with the questions. Thank you very much. It was really useful. And I think like a lot of people are using your products already in the audience, as we've seen. I do as well. So yeah, really good to listen to you. Okay. And we've got one more big talk today. So let's go on with that. So this is William from Clearest Cooperative. And yeah, here's the presentation. Yep. Yeah.
Right. So should I wait until 6 or should I?
I don't think so. I think we can actually start. Yeah, okay. Because people are already in the audience, so why not?
Cool, thanks. Indeed, I'm William. I'm a researcher for the Claros Cooperative. So if you're not familiar with Claros, it's a blockchain-based dispute resolution platform. And I'm going to have sort of a more crypto economics mechanism design talk, where I talk about some of the research that we've done at Claros to try to make Claros resistant to certain kinds of attacks, called griefs, both sort of build on some of the general conclusions of this research, and have several examples, a couple of which come from Claros. So to illustrate what a grief is, I'll start with a real-world example, and because Claros is a dispute resolution platform, I'll use an example involving disputes. So in the real world, in traditional courts, traditional dispute resolution, it's sometimes possible to frivolously sue someone. So you can spend resources, lawyer fees, to force somebody else to defend themselves. You're imposing a cost upon yourself because you hire your own lawyers. But you're forcing this other side, your opponent, to defend themselves too, so that forces them to take on a cost. And this idea that I'm harming myself to harm somebody else, that's what we call a grief. And sometimes in some jurisdictions, maybe a judge at the end of the case will realize your dispute was frivolous and force you to pay the legal fees of your opponent. Maybe, maybe not. It depends on the case and the jurisdiction. And so why would anybody do this? Well, maybe they're your competitor. And they think they have a bigger budget for law fees than you do, so they're trying to drive you out of business. Maybe you live in a jurisdiction where you have some underlying case that has some payment at the end that you realize that morally you have to owe the other person, but you want to delay it because you think that whatever interest you might have to pay through the court will be less than the real interest rate, so you're reducing your time adjusted liability. Maybe you short sold the stock of the defendant. Maybe you have a non-economic ideological reason. You could be an NGO that just, as opposed to the business model of the party you're suing. So you have lots of reasons. So this idea of a grief was really sort of pioneered by Vitalik. And the first reference that I'm aware of, at least, where he sort of discusses it in these kinds of terms and uses these words, is in a blog post from 2016 called The Triangle of Harm, where he analyzes griefs on consensus algorithms. And he defines this measure of grief that he calls a griefing factor, which is the harm that you do somebody else divided by the cost that you do to yourself. So if and this can be monetary, so for example, it can be harm in euro terms or cryptocurrency terms. I'll have a couple examples at the end that'll be non-monetary. So for example, if I can spend €1 to do 5 euros of harm to somebody else, that has a griefing factor of 5. So to have a slightly more complicated example, this is a payoff table. So if you're not familiar with sort of game theory and economics literature, the idea is that it tells, we have a 2-player game, so each of Alice and Bob can take 2 actions, where Alice can play U or D, up or down, and Bob can play L or right, L or R, left or right. And then, so you have sort of possible outcomes of the game. And in each outcome, you have the payoffs for the 2 players. So for example, if Alice plays U and Bob plays L, then you're in the upper left corner of the table, so that the numbers in that box tell you what each player should be paid. Alice is the first number, Bob's payment is the second number, so UL gives you a payment to Alice of 1 and a payment to Bob of 2. If Alice plays D and Bob plays L, then you're in the lower left, and they both get 0. And a fundamental concept in game theory literature is the notion of equilibrium. Which is a strategy that neither player, if they're rational, would want to deviate from. Neither player regrets. So here, UL is an equilibrium. Because Alice, what can she do? She can play D instead of U, but that takes her payment from 1 to 0. Bob could play R instead of L, but that takes his payment from 2 to 0. So neither player wants to do that if they're rational. But not everybody's rational. So for example, Alice could look at this and be like, wait, why does Bob get 2 and I only get 1? Screw you, Bob! And decides to blow up the negotiation and play D instead of U, even though that cost her something to cost Bob more. And there's psychology research that shows that people actually often think like this. If they think that they're getting a raw deal and somehow a game is unfair, they're willing to take a loss to have sort of what they see as something of a more just outcome. But this is a sort of grief. Where here, if compared to the default of playing UL, and this is kind of an annoying technical point, you always have to consider a grief compared to the default option of doing something else. So there are 4 different possible outcomes of this game, and we consider one of them to be the default, the equilibrium strategy UL, and all the other sort of griefs are compared to that. But compared to the default of playing UL, Alice's grief of deviating, it costs her 1 and does Bob damage of 2, so it has a griefing factor of 2. Okay, so the term comes from gaming, sort of as you can see defined here. I'm not sure, it might be blurry. But a griefer in multiplayer games is someone who does harm to others without really having a benefit to themselves. If they had a benefit to themselves, it would be called cheating. I'm going to survey a few of the existing thoughts people have had about this idea, and then I'll touch on some of my own research and some of the ways I've been thinking about this. So there's a long traditional economics literature on sabotage. It's a basic concept. It's not like a surprising idea. And economists have analyzed sabotage, but usually it's built into the payoff matrices they consider. So if you consider that sort of like 2x2 matrix I had a couple of slides ago, most economists look at situations like, okay, like I have competitors, they benefit from sabotaging each other, and then I'll construct this game that builds in the sabotage to how the players benefit, to how the players pay off, and then I'll analyze that. And the power of the notion of griefing and griefing factors is you don't have to know how the other side's benefiting from the grief in order to do this analysis. You can say, okay, like this strategy, it has a griefing factor of X. I don't know why anyone would do it, but if they did, this is its griefing factor. And then you can just try to design your game in a way that keeps the griefing factors down without having to predict in advance how others benefit. So there's this flexibility in this idea. So another sort of point of existing research that relates to, again, work that Vitalik did is on the notion of discouragement attacks and relatedly evolutionary stability. So here the idea is you might have a game where if everybody plays normally, honestly, everybody gets some kind of gain. Everybody benefits. But one player can decide to deviate that, imposing a loss on herself, but also imposing a loss on the other players. I'll have an example of this in a couple slides. And then the idea being that the griefer is willing to take a loss so that the other players who were still performing honestly also take losses. And hopefully, at some point, they'll cite it themselves, well, why am I playing this game? I'm doing my best, and I'm taking a loss. And they'll just give up and leave. And the griefer will be left with control of the system. So a specific example is in proof-of-work mining. And there's this preprint paper analyzing griefs in proof-of-work mining by these researchers from the University of London and the Singapore University of Technology and Design, where they prove that, in fact, the equilibria in the game of how much mining power you decide to use, how much hash power you decide to use, is not, like, it has a discouragement tag. It's not, in their words, evolutionary stable. Basically, miners are incentivized to mine a little more than what this sort of cost-benefit analysis of their rewards would tell them to reduce the, so take a larger percentage of the total mining rewards, even though they're spending more electricity, so they have not maximizing their profit, but they take a larger percentage of the rewards. And because they took a larger percentage of the rewards, they reduce the rewards of the other players, which might drive them to a loss and maybe push them out. The people at the Ethereum Foundation have spent a lot of time thinking about grief in the context of like the proof-of-stake consensus algorithm. So in proof-of-stake, there are various actions you can do depending on the tasks assigned to you, if you're a tester or a block producer. And you can fail to do those tasks, which generally produces some kind of grief. And you can see that they've basically designed the system in a way that the griefs aren't too big, no matter which one of these griefing actions you do. And these numbers are based on the sort of real payoffs as of a couple weeks ago. They vary slightly based on the state of the network. Okay, so that's all interesting. But as I said, like, griefs exist in the old world. Why do we talk about them so much in blockchain world? And I have a couple theories for why they're particularly relevant to us. And why this is something that we've innovated and researched on that wasn't necessarily relevant in the past. So first of all, as we sort of already hit on with the litigation example, external incentives can lead someone to do something which looks like a grief if you just consider the internal incentives of the game. And that's very much a thing in crypto in blockchains. You as a mechanism designer can build your protocol and you can say, okay, I've done a good job. Whatever honest strategy I want people to do, UL, it's a dominant strategy, everybody's going to do it. And then you realize that somebody can issue some kind of atomic interaction via transaction, take a flash loan, I don't know, connecting you to a different app, a different DApp that changes the effective payoffs for the participants. Maybe this is maybe you designed like some kind of oracle, and in order to mess with the oracle, you have to take on some fees and take a loss. Nobody would do that, right? But when somebody manipulates your oracle to use false information on some other platform, they might be able to gain. And here, this payoff example that I had from a couple slides ago, now Alice, what looked like a grief before, is actually some kind of dominant strategy. A second reason why I think this is relevant in crypto economics is that we have particular issues with oracles, continuing on the theme of oracles. In centralized systems, some kind of benevolent dictator can make a subjective judgment that some behavior constitutes a grief or an attack, and they can punish accordingly. In a video game, if I go around griefing people, eventually I might get banned. In that court example, at the end of the case, maybe the judge orders me to pay the legal fees of the other side. In blockchains, this is really hard. It's generally not possible to have this kind of benevolent dictator that comes in at the end and makes everything right. And finally, some people just want to watch the world burn. Trolls are a thing, and maybe we have more of them than other fields. Maybe. Okay, so now I'm going to hit on some things that are more related to my work. So I apologize for the math. I promise there'll be pictures in a second. This looks at how equilibria change when you have griefing players. And the idea is, okay, take the formula that I defined for what a griefing factor was and expand it out a little bit. So like on the top, I have the sum of the harms that I do to the other players, the sum of the difference of their utilities based on my grief. On the denominator, I have the difference in my own utility. And then I'm going to rearrange that. And in the second line, I've rearranged the formula. And then you say, if the player is going to commit a grief, they have to have some reason they did that, even if they're just a pure troll. So they have to get some kind of extra utility when you think about a broader notion of their utility that's going to encourage them to take on this grief. So I'm going to define another auxiliary utility function that's going to add that in, basically. And in order to be willing to do this grief in equilibrium, they have to get at least enough utility from the grief to take on whatever they lost through the sort of internal utility function. So you define this U prime, which just captures that, basically. So you think of each player having some kind of griefing factor that they're willing to grief at, a lambda I. So like each participant might have different lambda i's depending on how trollish there are. Maybe my lambda I is 5. Some more trolly player would be willing to grief at like a lambda I of like 1. They're willing to do like a worse grief, and they still do it. And then you define the UIs in terms of this line at the bottom. That's sort of what gives you people being willing to grief in equilibrium. And what essentially happens is you take the old utility they had, and then you just add in lambda I inverse times the harm they did. So if I could do 2 harm, and I have a griefing factor of 5, I took my old utility, and the extra utility I got from the grief is 2/5. And another technical point, remember before I said that the base point, the outcome that you're griefing with respect to, term is important in defining your grief. You can actually get rid of that when you take this perspective of equilibrium. When you look at this payoff formula, utility formula, the term with that in it just cancels out, and you get this other auxiliary utility function, which is the second line. And here, basically, I've taken the perspective that instead of getting pleasure from harming others, I'm annoyed when others do well, which is kind of the same thing. If I look at the example at the bottom, in the upper left, each player gets 1 utility, and I can say, like if they weren't trolls, that would be the utility they have. But if they are griefing players, maybe Alice says, oh, like, I got a utility, but so did Bob. And, maybe I don't like Bob, and I want him to do poorly. So I lose a little bit of utility because Bob got utility. Okay, so I'm through the formulas. Sorry about that. Now, at each tuple of lambda i's, each list of trolliness of the different players you have a set of utility functions that defines the game, and as you change those lambda i's, you change the game. And you can consider the equilibria in each version of this game, which gives you a sense of how stable your system is. Like, how much do the equilibria change when you have super trollish players versus not so trollish players? And if the changes are really radical, maybe your game isn't so stable, and maybe you could be just destroyed by an army of trolls. So here in this payoff table abstract example that I had before, you get this picture of, as you vary lambda 1 and lambda 2, you have different regions that you pass through where you have different equilibria behavior. So each time you cross a dotted line, this sort of behavior of your game just radically changes. And this picture might seem a little artificial because I have a 2-player game and they're both trolls, they're both griefers. That kind of seems like spy versus spy. But you can take the same perspective where you have n players, k trolls, you still can do the same thing. You'd have like a k-dimensional space where you can look at the picture of how the behavior of the games change, even though you have n total players in your game. So this gives you a graphical way of looking at the stability of your system. And as an example, back to the proof of work mining example from that paper from the people from the University of London and the Singapore University of Design and Technology, I can extend their work where I look at that game in the same sort of analysis, only now I vary the griefingness of my players. And you see that the unique equilibrium in that game is this formula here, which determines the hash power and equilibrium of each of the mining players. And this formula is really nice because it's continuous in lambda I. Like ideally, the best case scenario would be that no matter how goofy your players were, that this behavior of your game just never changed. You always got the same equilibrium. But like kind of the next best thing that can happen is that if you have more or less goofing players, your game doesn't change too much. It changes really slowly in a continuous way. And if you look at this, for like all like reasonable lambda i's, the amount of mining that the players do barely changes, unless you have like a lunatic that's willing to grief at really small griefing factors, at which point then their QI changes. So you have this very continuous, very minimal change from the presence of griefing players. You're very resistant to griefs. Okay, so now just sort of hitting briefly on some griefs that cause non-financial harm. So in the Shanghai DOS attacks, the griefer spent gas to perform the attack. And as far as we know, they didn't seem to have any kind of financial benefit from doing this attack. But what they did was they increased the there were different sets of attacks. But generally, they increased the computational load on node operators using different node software. So here, the harm is in computation having to be done, and the cost is in gas. Another situation that we frequently have to think about is delay griefs, where the harm is done in terms of time. So now it's harm in terms of time divided by cost, which might still be monetary. And as an example, in Claros, again, it's a dispute resolution platform, we have a notion of appeals. Sometimes you can appeal frivolously, similarly to the kind of frivolous litigation in the real world example. So maybe your case starts with 3 jurors, you appeal, and next time there might be 7, 15, 31, doubling plus 1 every time, but the number of jurors roughly doubles. And each time you appeal, you increase the amount of time that it takes to resolve the case by roughly a fixed period. It depends a little bit on what case you're talking about. Maybe it's a week, maybe it's 3 days. But each time you appeal, you get additional appeal period, which is fixed. But the cost of doing the appeal is proportional to the number of jurors. So it's growing exponentially. It's growing as 2 to the n, which means that your griefing factor for appealing n times is n over 2 to the n. So asymptotically, it's not very big. Maybe the first appeal is cheap enough that you're willing to do it. It doesn't cost too much yet because you're only at 7 jurors, but you can still delay it for a week. But as you have more and more appeals, the cost of appealing for a month, for more, is prohibitive, which is not necessarily a kind of asymptotic behavior that you see with the real world frivolous litigation. So asymptotically, as you grow, the griefs aren't too bad. Some other prominent delay griefs, you can have frivolous challenges on curated lists, whether that curated list is using Claros or some other mechanism. In rollups, specifically in Arbitrum, you can challenge a state update, which starts an interactive game. That interactive game takes some amount of time. That results in a delay. And all of these examples touch on issues with oracles, the sort of broader point I made at the beginning about how our oracles aren't all that great, in that, like, Claros is a subjective oracle has to do with disputes. What is the right answer of a dispute? Arbitrum, if you sort of squint and think abstractly, when you're doing a state update on L1, you're kind of doing an oracle operation about what's happening on the L2. L1 doesn't know what the right answer to a dispute is. It doesn't know what the right state of L2 is until you tell it that information. And this process of telling it that information might be subject to delay griefs. That is one trade-off you can make when you're designing that game. Okay, so just to conclude, griefs can be results of hidden motives, or they might just be the results of trolling. This is particularly relevant for the interconnected world of blockchains because of external motivations. Griefing factor approach allows you to abstract away what those external motivations are and just try to optimize for your griefs. And thinking about the variation in terms of this like geometry diagram that I showed can give you a global sense of whether your system is stable to different levels of griefing. It's possible that your griefs might be explicit. Maybe sometimes they're the unintended result of like how much some operation costs in gas or something that you didn't intend when you created the design of your game. They can be financial or involve time or some other resource. And what you really care about is them not being too bad as you have sort of whales and larger players that could do real harm. Okay, so thank you, and I'd be happy to answer any questions if there's time.
Thank you very much. So I'm ready to take questions.
Could you explain the logic behind lambda inverse in your equation?
Yeah, like why is it an inverse versus like a lambda or?
No, I got the lambda in the last equation.
Mm-hmm.
Yeah, could you explain? I couldn't get that part. I got the equation, but not the lambda inverse part.
Yeah, so the lambda is, I replaced the GF thing. Like the idea is that I define a griefing factor in terms of this thing in the first line. In the second line, I've rearranged the first line. And in the third line, I take this perspective that each player has some griefing factor that they're willing to grief at now. So I assign to each player a lambda that is their level of griefiness. So you'll notice that it just like replaces the GF.
Yeah, okay. I got that. Thanks.
You're welcome.
Anyone else? It seems that we didn't have any more questions. Oh, yeah. One more.
So is it possible, right now we define harm and gain in scalar values. Is it possible that the values of the attacker and the attacked may be a little bit more complex or maybe valued at different, from different perspective in a different way? Is there a way to account that in those equilibria formulas too?
Yeah, so I mean, in order to do this kind of analysis with the pictures, you need to have some payoff table for how you think people or what utility they get from playing the game. It doesn't have to necessarily be like constant values like this. They can have like a continuum of different values for like infinitely different many outcomes of the game. But you have to be able to assign some utility to each player and each outcome.
Right, seems fair. So alternatively, we probably could just add multiple units there, right? That you just don't get paid in one unit, but like in 3 different units, I guess.
Yeah, you know, you could, if people have sort of complex motivations, you need some way to like smash them together into a utility function.
All right, seems fair.
Oh, yeah.
Is there any research on bribing on the DeFi ecosystem, the token bribes? Do they become griefing?
On bribing?
Yeah.
Yeah, so some of our other research is like related to special kinds of bribes in Claros, because another thing you might try to do is try to bribe the jurors. There are specifically very interesting bribes called P+epsilon attacks that we published a paper on recently. This is again based on like a blog post of Vitalik where he sort of introduced this attack back in the day on a system that was like a predecessor influencer of Claros. Of course there's research on bribing in the economics literature more generally. So yes, there's research on bribing. The kind of line where a bribe becomes a grief, or where like an attack becomes a grief, is where you don't know what utility the attacker is getting from doing the attack. So with a bribe, maybe you can have this perspective of having a specific outcome that they're trying to get, that you know the utility of that, and you can do like maybe a richer analysis of the game because you have this extra information about what their goal is.
So, Anyone else? Any questions? Yeah, seems that we're done. Thank you very much. It was very interesting.
Thank you.
And now we're going to have a series of really small talks of like 5 minutes each, which called the lightning round, basically. And the first one to go is Nikolai from Nexo. I'm not sure if he's present right now. He is. So we're ready to start.
No. Okay. Is the clicker working?
Yeah, it does.
Okay, guys. Hello from me as well. Nice to see you here. I will start and talk a bit and do this Voitanic talk to discuss something that is very hot nowadays, and especially I see it being very hot on this conference particularly, and that is DeFi wallets, or so-called smart contract wallets, smart wallets, or whatever naming there is for that. And the cool part is that we as community have started identifying that we currently lack very good solutions in that area, and the things we usually have, things like the cool MetaMask and stuff, are good for us as developers, but not very good for normal users and for UX on people that are joining the blockchain ecosystem and need to onboard very fast. So we need to find a way to actually solve this problem, and there is actually a lot of cool solutions. So I'll just briefly go over some things that people do, talk a bit about some visions and some challenges that we need to solve. Before continuing, just a few words about myself. I'm Nico Angelov, and I'm currently leading the blockchain department in Nexo, where we do a lot of financial things with crypto, currently mostly centralized, but we are joining the DeFi and decentralized space soon very strong, so looking forward for that as well. Besides doing blockchain stuff, I like to do public talks. I do a lot of gaming and stuff like that. So DeFi wallets or smart wallets, however we call them, in the end what they really are, and what I think people need to look at them, is actually that their identity. In the end, it doesn't matter if we use Gnosis Safe or Argent or Zapper or whatever smart contract wallet. In the end, you can view that as being your decentralized identity. So instead of just going and looking of how it's how it is actually guarding your money, we can look in the ways how we can view it as identity, improve it as identity, and have things like, let's say, feedback for users, rating systems that usually Web2 is based on. So how this work? You have a smart contract, or actually this is a big setup of different smart contracts that usually represent you. And with these smart contracts, you can actually interact with anything else on the network, and always you proxy through your identity. So for the world, or basically for the blockchain, the address of the identity is what you actually are, and not your wallets. And the other thing is that, you can interact with anything. And the other thing is that on the identity, you can actually add many keys. So you can have multiple wallets, different types of wallets like Ledger, MetaMask, whatever wallet you want to have, and control that identity. This gives us the ability to not only have multiple ways to interact with one thing, but actually to aggregate data. So instead of me going and proving on different sites that I'm the owner of the particular cold storage ledger or some other ledger, I can just group them and aggregate them by my identity, and then my identity is actually showing and verifying the ownership of everything I owe. And the other thing that it gives me is actually putting a domain name on the identity actually puts the name on every single wallet that is controlling the identity. So in the end, you have one big aggregated system that aggregates everything, things like hold, code, and so on and so on. So how this works for newbies and how do we solve the problem for people that are just coming to crypto? Well, you can introduce things like a relayer, which is a bit centralized, or there is other ways to do it. So essentially, when a user comes and he doesn't have keys, doesn't know what MetaMask is or what blockchain wallet is, you can then do some magic that is maybe centralized, maybe decentralized. It actually depends how you want to treat the user and give him the options to different things. So yeah, Relayer is one way, which is kind of centralized, but there's other recoverability systems that can give the user and abstract the user out the keys, out the stuff, and give the user the power of your system, your identity, to use it as he wish. And earlier today there was multiple talks with the new upcoming APs 37.4 and AP 43.37. They actually try to tackle these problems with newbies joining the network. So hopefully we'll see this soon. Are those two actually full solutions? I'm kind of skeptical. I think there still needs to be done. But in the end, they are definitely a step forward and moving forward the entire ecosystem. So if we view the entire thing as identity, then one of the biggest problems is how do you support multiple networks, right? So in the end, I want to have one address that is my identity, but I don't want to have it only on Ethereum. I actually want to have it on every single chain, and I don't want to be different, right? I want my identity to be global, everywhere on every single network. So this is kind of solvable very easy for things like EVM supported chains, like let's say Polygon, Avalanche, whatever, Binance Smart Chain. So you can have the same identity across all of those chains, and it will be fine and working very easy. The problem is actually non-EVM networks. So in a case you want to have identity in things like Bitcoin, or in things like Solana or whatever other blockchain, then it becomes harder because they either doesn't support the same address format or something else. But there is still a solution, and that solution is actually the domain names. So if you have an ENS or whatever domain, it is actually resolving on those chains. So you can support different identities on different networks. In the end, you will have different addresses, right? But they will be under the same domain name. So in the end, you achieve your goal of having those things on different networks. So we are actually building it. So if you're interested, looking for a new fresh bot, and because this lightning talk, it was quite fast. If you have any questions, I don't know, do you have questions now? Or?
Yeah, we can take a couple of questions.
Yeah, sure.
If we've got any.
Any questions? Okay, then we can discuss it afterwards.
Yeah, sure.
Yeah. Okay,
thank you very much. And the next up is, thank you. The next up is Adrian from Ledger. I don't know if we've got the speaker here for now. Yeah. Okay, so we are ready to start.
Thank you. How do I change the slide?
There's a clicker.
Oh, there's a clicker. Okay. So, hi everyone. So I'm gonna present you how to connect your project with Ledger. So me, I'm Adrien Faguet. I'm working at Ledger since 5 years. I'm a blockchain developer advocate there. And here you can scan if you want my Twitter or my Telegram if you wanna just speak with me or anything. You can just save the phone and the QR code because we will have like another one later. You will see. So we're gonna start. Or you will basically do it with your own documentation, and or as a project you can integrate yourself like a nano app, blockchain app, or anything. So basically there is like 3 points: the ease of use, the security, and the open source. So if you don't know, since December the last year, so basically 3 months, we quite like open source some of part of our code so you can develop on top of Ledger. So here you have like, the first thing is like the nano application. Quite simple. If you are doing anything like a blockchain or something like that, you can create your own application and use it directly from your Ledger. You will have the Ledger Connect, which I think like the most known, because it's like when you are using a wallet like MetaMask, Phantom, or well, Kepler, for example, you will be able to connect with your Ledger and interact with the application. The third one is the blockchain support. So with that, you will be able to integrate your application directly in the Ledger Live. So with that, you will have access for your user. Well, actually, they will be able to use like send, receive, and even like staking features if you are able to integrate them directly from the Ledger Live. So it will open like almost 2 million users from ourselves to use and interact with your application. And the last one is the live application. So it's called like a discover. So you will be able to add any dApp directly on it. So all user will be able to interact in a platform and just like play if you have like, for example, a game or anything. So they will be able to connect directly from the Ledger Live and use it. But well, there is like 4 things, so where do I even start? So we have developer portal. There you will be able to find all the documentation on how to integrate the 4 things we have seen before. And we have a Discord channel that you will see later, QR code as well. And there is like the whole community of developers that are building on top of Ledger. So basically, if you have you are just like a project, you can just come here and we will create like a dedicated channel, speak with you guys and see what we can do like for the integration and help you guys. So for the nano part, you can see on the screen, it's like the screen of the Ledger Nano X, and it's basically adding security on your application. Because what you see is actually what you sign. So with Ledger, you are able to see directly what you are signing on the device. You will see in a few basic steps what's the difference between a blind signing and a clear signing. So when you are like blind signing, for example, here you have the review transaction, the blind signing, and you accept and send. But basically, you don't know what you are doing, so it's wrong. You don't have to do this. But if you are building your own application, you will be able to put more steps, and with that, you will be able to see everything. So we call it Seifu. The second thing is connecting, as said, the application directly. So how does it work? There is like the 2 things, like the Nano S and the Nano X, which works kind of similar way, but the Nano X got the Bluetooth part. So there is like 3 languages you have to know: the JavaScript for the web, the Electron and Node.js only for the desktop application, and the React Native for the Android part or Apple part. So basically, it's like mobile part. I don't will go like deeper on this because it's quite technical and we have only 5 minutes. So what's the result of this? You will see like basically here there is like the algorithm application. There you can just connect with your Ledger device. The second one, you can directly, if I want, put my Ledger Nano S and Nano X as well. And the third one is like Phantom, and you can connect with your hardware wallet to add security. On these things, you have to know, like, using this, you are not exposing your private key. So this is why it's more secure than anything else. If you are connecting directly with your mnemonic or anything, it's like exposed, and it's called a hot wallet. The third one was the blockchain support. So here we will see like how you can get your coin directly put on the Ledger Live. So before, I said that we open it, so you were waiting for us to do it because everything was closed. So basically, we just like receive your request and like do priority if your project is known or not. But now, you are able to do it by yourself. So here is some application that already did them by themselves. So you can see like Solana, for example, that will be released soon. There is Celo as well that will be released soon. Crypto.com is just kind of new, but there is not the staking. Actually, there is only the buy and received. And some others, like you can see like ADA and Edera, for example. The third one is the live apps. So when you are, I don't know, if you have like any app or application, you can directly put them on top of the Ledger Live. So here you can see it's pretty easy. There is like a discover. It works basically with an API call. So it's quite simple. And then you can just add, for example, here you see like Lido, MoonPay, directly added on the discover. So who user will access to security and actually interact with your application at the same time. So everything is on our developer portal. You can read all about the documentation there, and if you want, you can just scan the last QR code, which will link you on our Discord channel. So you will have like 2,100 like people already here waiting for you, and if you have like any question, you can ask them. We are here. So that's it for me.
Yep. Thank you very much. Any questions? Probably I've got only one question. What about moderation? So is it possible for some of the developers to post something malicious?
No, actually we are reviewing the code actually. So yeah, basically you are doing almost the whole code, and after that we are reviewing the security part with our security team, which is called the dungeon, and they will like review the code and say like, okay, this is a go, we can. There is like no possibility there is malicious things inside.
Okay, great. That's great to hear. Okay, we can probably wrap up.
Fine.
And yeah, so we've got some more talks coming. The next one is from Alexis from Atlantis Labs. So do we have Alexis here? Not for now, it seems. Or like okay, since Alexis is not here, so maybe Annette is here to talk about the NFT part. Not yet. Okay, and the next one is actually me. So I'm gonna do a brief introduction regarding the Jeton Capital. Jeton is actually a sponsor and co-organizer of Ethereum Dubai. We held the opening party, if you remember, if you've been there 2 days ago. And yeah, I can do some brief info about like what we do. Probably some of you have already talked to people at the booth already, and like I've got almost the entire team there so talking to you, ready to answer the questions. But basically, at its core, Jeton is a DAO, and we want to learn how to algorithmically manage our treasury so that it doesn't deplete, it increases in size, and we are able to build new products. So there's a big portion of what a DAO does, and it's basically managing the token price, because you either have to be reliant on like market makers who are going to deal with the token price on centralized exchanges, or you have to trust what is happening on AMMs, because there's a big possibility of price swings when like a whale comes in, and if you token and the pool isn't deep enough, then it can easily go up and down no matter what, and it can be uncorrelated to the intrinsic price of your token. So we've created what's called a pathway protocol that aims to connect the price of our token to the fundamentals of the project. So we want to like decouple the pricing from all the trading that's going on with the token, and so that we are mainly focused on achieving some goals that we have. So for example, the more liquidity we have at our disposal that we can put in our pools, or the number of like whales or prominent people who might influence like the future of Gton. So we can, for example, set monitoring if people out of whitelisted like list of interesting contracts holds Gton, it might lead to the increase in price. And so basically we want to automate all the activities related to treasury management so that it's all incorporated in the price of our token. This is actually, like it's complicated to be done on AMMs, so that's why we are switching to what is called proactive market making pools, and basically it allows you to control the price and the slippage of the trades in the pool. And so this way we can incorporate an oracle price, and also like to get an average of like the AMM price, because we still are going to have some liquidity there. And like with this average, this is basically going to determine the price the token is trading at. And then like we basically want to see our project grow depending on like how well we deliver, and not how well it is being traded by some people who just want to probably, I don't know, like get some short-term investment and flip it a couple of days later. So yeah, our ultimate goal is actually like if we learn how to do it properly, if we can manage the treasury, manage the token price, etc., increase our reserves, then we want to expand and make sure that this money is spent well on like building new products. And the best place to do so is basically like to create your own chain so that other developers can join you and they can build upon the infrastructure you have. So this is the ultimate goal for this year. We are currently in the research phase for the what we call for now GCNet, which is going to be our own chain. So we look at different technologies, etc., and for the best technologies to utilize for our own blockchain. So yeah, so this is a brief introduction about the Gton. If you've got any questions, I'm ready to answer. But it seems that everyone is tired already, so we are about to, like, we've got one more talk. I actually like two more because we missed those, but people were not present yet. So the next one is Jyoti from MetaMask. Yeah, we already talked, by the way, at the booth. So, and I'm going to prepare the presentation. Do you have the slides? Big. To Patrick? Sorry for a slight technical difficulty, because, yeah, we have to find the slides.
Hey, hi everyone. Yeah, I know everyone is tired of the long day of talks, but yeah, the topic I'm going to talk about is really interesting. I'm going to be talking about the enhanced gas UIs in MetaMask. A bit about me. I'm Jyoti. I'm based out of New Delhi, and I'm a senior developer with MetaMask extension team. And I have been part of the project to improve our gas UIs. Now, gas on networks is one of the most interesting and complicated topic. And they're important. They're important because they're a cost for our users. And they are complicated because gases are highly unpredictable. They are volatile. There are spikes and slows. And as a wallet, it's a challenge for us to represent gas in a way which is least confusing for the users. So we need to ensure that our users' transactions are not stuck waiting for a block. Like, they have sufficient gas to find place on a block, and at the same time, we need to ensure that our users are not overpaying for gas. Now, during the course of this transaction, in next 20 minutes, I'll take you through what is Ethereum gas, as it might be a new topic for some of you. We'll see how gas pricing in Ethereum was done traditionally. Then we'll look at EIP 1559 and how that changed the gas pricing mechanism in Ethereum, and what MetaMask has done to adopt EIP 1559. Then we'll see what were our learnings from our initial implementation of EIP 1559 and how we have improvised upon that. Now, to begin with, what is gas and Ethereum? So gas in Ethereum is a kind of like analogy for fuel for your car. So you need fuel to run your car, and in the same way, you need gas in Ethereum network to run your transaction. So gas is a way of allocating expensive resources over the network. To run your transaction, you need these resources on Ethereum. So as you can see in the diagram over here, so every small network resource or any computational resource on Ethereum has a cost. That cost is calculated in terms of gas. So gas is a way of resource allocation in Ethereum. And since its implementation in Ethereum, a lot of other projects have started using gas as a mechanism of resource allocation. During the course of presentation, I'm going to be using the term gas fee and transaction fee sort of interchangeably. So yeah, don't get confused with that. Also, one important point, yeah, a couple of people also came over to the booth to us, and they were asking, like, when is MetaMask releasing zero gas transaction? So MetaMask is not who charges this gas. So MetaMask is just a wallet. We take your gas inputs, we send it over to the network. So it's a network that gives you these computational resources, and it's a network that is charging this gas for your transaction. So MetaMask, at least for 101 transactions, MetaMask is not charging anything. Yeah. So how would you calculate the total amount of gas your transaction is going to need? So it's similar, it's like, and again, an analogy to the fuel situation. So the unit of gas your transaction need multiplied by price per unit of gas. So consider like how much money you're going to spend to refuel your vehicle. So that will be the number of liters of fuel that you will take multiplied by the price of the fuel. So the number of unit of gas your transaction will need depend on the complexity of the contract and the size of the contract. That multiplied by gas price will give you your total spending on gas for your transaction. Now the unit of gas the transaction will need is going to be constant. So the magic lies with the gas pricing. In Ethereum, gas pricing traditionally was done using an auction-based mechanism. So users in their transaction will specify their gas fee bid, or what they used to call as gas price. The miners will choose the transaction with the highest gas price, and they'll mine it. Now, this looks very simplified. Your total expenditure on gas will be the units of gas, which we usually specify as gas limit on the UI, multiplied by gas price. And traditionally, the block size was fixed to 15 million gas. Now, this mechanism is very simplified. There's one variable, which is gas price. The miner will choose the transaction with the highest gas price. All of the gas fee will go to the miner. So simple as that. But the mechanism has drawback. In this mechanism, the gas pricing is totally controlled by the miner. So the network has no control over gas pricing. And the second drawback is that the bots competing for gas on the network can result in gas prices really surging. And there are spikes, sharp spikes, and everyone else on the network at that point has to suffer and pay more for the gas. So users were not happy with this auction mechanism. They were complaining. With the nature of auction, it was highly unpredictable. It was hard for user to know what will be the gas price in the next block and what they need to pay to be on the next block. Ethereum overhauled their gas mechanism with EIP 1559 in London upgrade last year. It was in August 2021. In EIP 1559, this auction mechanism and gas price was replaced by these two variables, which are called as base fee and priority fee. And the block size was also made variable. It was 2 times of what it was previously. So previously it was 15 million gas, and now it's 30 million gas. Now I'll tell you what is base fee and priority fee. So yeah, I hope everyone is with me so far. It's making sense. Okay. So base fee is the minimum price per unit of gas you need to pay for your transaction to be included on a block. Base fee is decided by the network. So it's not the miner deciding it. It's the network who decides the base fee. For Ethereum, it's always in ETH, and the base fee part is burnt out. So there are very important, significant consequences of these. Like the network finally has a control over gas pricing. And this also makes ETH a deflationary asset. And a big advantage is base fee is highly predictable. Since it's the network who decides the base fee, and there is a clear, so if the block is like more than 50% occupied, the network will increase the base fee by 12.5%. If the block is less than 50% occupied, the network will decrease the base fee by 12.5%. So that way, base fee is highly predictable. So if you see, like, here you can see, like, when the block size was more than 50%, the network, in the next block, so the gas fee for a block will depend on the block previous to it. So if the previous block was more than 50% occupied, the network will increase. And so an increase cannot just go on infinitely. So at some point, the base fee increase will stop, it will start decreasing, and it will eventually reach an equilibrium. Now, the second variable in 1559 is priority fee. Priority fee, or what we call as miner tip, is a way to incentivize the miner. And priority fee is your tool if you are looking forward to participate in the gas war. So if you are running a time-critical transaction, you are participating in an NFT drop or minting, or the market is highly volatile, and you need to ensure that your transaction is executed really fast, add a high priority fee to it. So miner will be happy to run your transaction. So now, so gas fee, in a way, priority fee is a bit similar to gas price pre-1559, but 1559 has introduced one more variable, which is base fee, and it has improvised the overall gas pricing mechanism. So now gas pricing for your transaction will be unit of gas, again represented as gas limit on the UI, into base fee plus priority fee. So if you look at the scenario like pre-1559 with auction-based mechanism, there was fee which was going completely to the miner. Now in EIP 1559, we have base fee, which is burnt out, and we have miner's tip, which goes to the miner. Since EIP 1559 was introduced in August last year, MetaMask was amongst the very first browsers to add support for it. So if you are creating a type 2 transaction, which is a transaction that supports 1559, on a network which is supporting 1559, you'll see this transaction confirmation screen in MetaMask, wherein you can see the max fee specified, and you can confirm your transaction. It will use the default gas estimate suggested by MetaMask. Or if you are an advanced user, you can click on the edit link. It will open the advanced gas fee model, where you can select one of our predefined estimate, low, medium, and high. Or if you are an even more advanced user, you can provide your custom estimates for max fee, priority fee, and gas limit. So by default, MetaMask will suggest you the medium estimates. Now, there are a couple of terminology here, which is always confusing. So I'll take a minute to explain that. So what is gas limit? Gas limit is the maximum amount of gas I authorize for consumption for my transaction. So suppose I specify the gas limit as 5,000. Now my transaction needs only 3,000. So the network will use only 3,000. It will not use 5,000. But suppose I specify the gas fee as 1,000, but my transaction needed 3,000. So it will run out of gas. Whatever gas is consumed will be lost, and my transaction will not be executed. So always specify a gas limit, like a bit more than what you think your transaction is going to need. Second, base fee. Base fee, as we saw already, is the minimum price per unit of gas, which is specified by the network, and it's ultimately burnt out. Priority fee is in theory optional, but yeah, practically priority fee of 2 GUI is almost always needed to run your transaction. Priority fee is, again, price per unit of gas. It is paid to the miner. It is decided by the user. Then we have this field called max fee per gas, which is a very confusing value. So max fee per gas is priority fee plus maximum amount which you are willing to pay for base fee. So the thing is, base fee can be changing. So I'm creating my transaction, and the base fee on the network might be, say, 50 GUI. But by the time that my transaction is executed, the base fee on the network might have got up to 75 GUI. So if I specify just a base fee of 50 GUI, and I send my transaction, when it's executing, the base fee has got up to 75 GUI. What will happen is my transaction will be stuck. It will be waiting for base fee to come down to 50 GUI, and then it will be executed. So what I can do is I can specify max fee per gas, which you specify in MetaMask. So that is maximum what I'm willing to pay. So I can, in my transaction, I can specify max fee per gas as 100 and priority fee as, say, 10. So what it will do is 10 GUI will go in priority fee, and rest of 90 GUI is what I'm authorizing the network to use for my transaction. So actually, the network might use only 50 GUI. It might use 75 GUI, and the rest will be refunded back to me. But if it's less than that, my transaction will wait for the gas on the network to come down. So yeah, just to give you an example. So suppose in my transaction, I specify max fee per gas as 100. My spending on priority fee is 20, and base fee is 80. So in all, 20 plus 80 is 100, and my transaction has sufficient gas, the transaction will be successful. Now, suppose I specify max fee per gas as 120. Then the priority fee part is 20. The base fee when my transaction is executed on the network is 80. So in all, I need 100 GUI. So 20 GUI will be, so the transaction will go successful, and 20 GUI will be refunded back to me. Now, suppose I specify max fee per gas as 80. Now, priority fee is 20. Base fee at the time of transaction execution is 80. So in all, I need 100 GUI of gas, but I specified only 80, so my transaction will be stuck. It will be waiting for gas fee on the network to come down to 60, and then only the transaction can be executed. So, yeah, I hope this max fee per gas is clear. Yeah, it's confusing. Now, ever since we introduced EIP 1559, we have been collecting data on the network. We have been looking at gas behaviors on the network. After 1559, we have been collecting user feedbacks, and we had some very interesting observations. So it is expected that with EIP 1559, the gas spikes will go down, but we found that the spikes were still there. User psychology on the network has a huge influence on gas pricing, and there are actually multiple factors, but they're highly unpredictable. And we found the gas spikes were there, and typically our users were falling into 3 categories. So there's a category of sit and wait users. They don't want to pay high for gas. They're happy to skip the spikes, but their transactions are not time critical. They're happy to wait and don't overpay. Then there's a second category of users for whom gas is not a concern. Like they're happy to pay whatever it takes, but their transactions are time critical and they want it to be executed really fast. And then there's a third category of normal user. They'll just go with what is the market trend at the point. So we have worked towards reducing the complexity of our gas UIs. We designed and technically implemented controls to reduce user confusion. In MetaMask, we call it EIP 1559 V2. Here's a little video.
The max base fee. Try out the new UI now on extension and.
Yeah, so as you all just saw, we have introduced new 3 friendlier level of estimates, which are called as low, market, and aggressive. So our new low, they are really low. So if you want to skip the spike, you're happy to wait for gas price to come down on the network, go with our low estimate. If you want to go with the current market trends, go with our market estimate. And if you're running a time-critical transaction, you want to win the gas war, your transaction is critical, go with the aggressive estimate. It will set your max fee and priority fee to really high, and it will ensure your chances of winning the gas war is high with that estimate. So if you create a transaction now in MetaMask, on the transaction confirmation screen, you'll see that market estimate by default. So whatever is the current gas field level in the market, it will show you that by default. Here you can click this market link, and it will open the added gas fee model, where you can select one of our predefined values of low, market, and aggressive. And you can select either of these. Now, MetaMask has done a lot of very good job in deriving these estimates. We look back on the blockchain, we look on the gas trends on the blockchain, we collect data from recent blocks on the blockchain, and we run our algorithms over that data to derive these estimates. Being one of the highest used wallets, it's very important that we come up with the right estimates, because if we are estimating on to the lower side, that will mean a lot of transaction on the network will be stuck waiting for gas prices to come down. And if we are estimating on an upper side, that will mean the gas pricing on the network as a whole will increase. So yeah, being the highest used wallet, it's our responsibility to ensure that our estimates are good, and we have done a good job at them. Like a lot of projects use our estimates as benchmark. Also, on this added gas fee model, at the bottom, we show you the current network status. So you can make a more informed decision at selecting the predefined estimates. You can see the current value of base fee, priority fee on the model, and how is the network currently behaving. So whether it's stable, or it's slow, or it's high. So you can accordingly decide the gas fee estimate that will be appropriate for you. Also, on our gas UI, we have added informative tooltips. They'll show you the breakdown of gas price that you're paying, and they'll give you more context of what a value is, and they're especially useful for new users. We have also changed the advanced gas controls, which allow you to set custom values for gas. So the new controls not only allow users to set custom value for gas, but they also allow you to save these values as default for you. So, you can save these values default. So if you're running a time-critical transaction, you want to execute it really fast, you can save these custom values as default. Come create a transaction. It's going to use these defaults, your default gas settings, and you can quickly confirm. Or if you want to edit these custom values, that will be a single click. So if you have these defaults set and you create a transaction, this is what you're going to see in confirm transaction page. It will use these advanced settings for you. You can click that advanced link and select one of the predefined gas estimates, low, medium, and low, market, and aggressive, or you can click the edit link. The edit link will take you to the advanced gas fee model where we allow you to enter custom value for gas. So you can set a custom value for max fee, which is like the maximum amount you're willing to pay for the transaction. You can specify custom value of priority fee, which you're happy to pay to the miner, and your gas limit. Also, in this model, we show you the current network values. So we show what is currently the base fee and priority fee over the network, what has been the range in last 12 hours, so you can make a more informed decision. Also, here we allow you to set these values as default for yourself. So whenever you create a transaction in MetaMask, it will straight away use these defaults. Yeah. The new gas UI has been released last month as of version 10.10.0. It's still in beta, so you can go to settings, experimental, and enable it and use it. The advanced gas UI on mobile side is still under development. Since we released EIP 1559 v2, we continue to collect user data. We continue to see the gas trends over network. And we continue our work on improvising the gas UI. With the beacon chain merger, we expect more changes in the way gas works on network. Not in terms of like the mechanism, it's going to be EIP 1559, but the user psychology is going to change. The network trends are going to change. And for us, improving the gas UI is a continuous effort. So we've already started thinking of EIP 1559 v3, which will improvise these UIs further. So during the course of the transaction, we looked at what is gas pricing and what has changed with 1559. And we also saw how MetaMask has adopted 1559, what we learned from it, and what changes we have done to our gas UI. We look forward to ensure that we provide great user experience and accurate estimates to our users. Now we have time for any questions.
So if anyone's got questions, please go ahead. Probably no questions so far. So thank you very much for your speech. And we've got several speakers that we've missed so far. So let's go through the list. So who do we have present out of the speakers who didn't talk yet? Okay, so the order was like Alexis from Atlantis Labs. Yeah, that's you. This is the private window, so we can just close it, and it's gonna be So now it's gone. Thank you very much. So here you go. Thanks. And this is yours. It should be. Nice. So here we go. There's a clicker.
Hi everyone. Hi. So DeFi's mission is to build an open, trustless, and capital-efficient market. And this market is being driven by DAOs, DeFi protocols, and together they build new products, features, and optimization to make that market expand and fulfill. And it's kind of funny and ironic to see actually that those protocols which are building cutting-edge financial products actually don't have access to the most basic forms of funding that exist in a traditional market. And that's why today I will be walking you through how Web3 actors can benefit from under-collateralized loans. First, a few words about me. My name is Alexis Masseron, and I'm the co-founder and CEO of Atlantis Lab, which is the main contributor of Atlantis, an under-collateralized lending protocol. I've been working in crypto since 2017. I was previously a software engineer at Consensus and active member of in the association, associative ecosystem and in various Ethereum-based DAOs. I'm also a firm believer that DeFi's mission is to bring a more open, trustless, and efficient financial system to people, Web3 entities, and Web2 entities as well. And if I want this mission to be fulfilled, we need to go over to look at the DeFi lending market as of today, the state, and it's really pretty. Most DeFi lending applications are actually over-collateralized, meaning that you actually need to deposit more funds into the protocol that you want to borrow in the first place. And that comes from the fact that those protocols are actually mostly peer-to-peer oriented, meaning that the default risk is actually pretty high. So that makes sense in that case, but that prevents actually most DAOs and DeFi protocols to finance their activities through debt, which is actually a very common method in the traditional ecosystem. And this is why we actually saw a lot of protocols and DAOs going through dilutive funding method, so raising funds through VCs and angels. It is a very efficient method and makes total sense if you are actually wanting to bootstrap your protocol or scale your protocol if needed. But that comes with a cost, right? And you can do that only a limited number of time. So that's why, like, if we want to have strong and powerful Web3 entities that can build and make these ecosystems thrive, we need to have those tools opened to such entities. And usually what they would do, they would actually, like DeFi, you would want to have DeFi protocols and DAOs opening some sort of credit lines to banks, right? But DeFi protocols don't have access to banks, and that is a huge problem. And that's why, and actually I think those Web3 protocols could actually be so much better actors than the Web2 counterparts, because by actually working on the blockchain, they actually have they actually are relying on a transparent ecosystem. So, for instance, most of their data are on-chain, so visible, transparent. Their income are actually streamlined for smart contracts, and so this is measurable. Their accounts are usually wallets, hot wallets, or multi-sig, and so everything are identified and can be monitored. And so also you could actually build loans which are trustless, because everything would be built through smart contracts integration, and you would actually reduce the underlying risk of the default from the protocol to actually the hack. The default would be the hack of the smart contract. And you can actually cover yourself from that by actually going on an insurance protocol to cover that. And for what? So the two main use cases are trading strategies, such as market making and arbitraging, and cash management, which are some kinds would be bridging or fast withdrawals, which actually are mostly use cases that are covering about talking about how you can basically send cover the cost of transaction from withdrawing funds from one layer to another to enable a better user experience for your users. And I don't know if you saw that tweet, but basically this is what happened for Binance, which built a bridge between the BSC chain and Arbitrum. And it actually took 20 hours in the first day of deployment to get this bridge drained. And it happened again actually 1 week after. And actually this is a real problem, because what this bridging is supposed to be done, it's covering the transaction cost of the users which are withdrawing from one chain to another. And if the ETHs which are on the chain, on the smart contracts, are depleted, you can't use the bridge anymore, which makes a very bad user experience for your users, right? And this is super bad for multiple reasons, because first, that makes you super vulnerable to market surge. So if there is a hot spike in the market, your bridge gets drained. The way that the bridge is being handled by Binance is actually manual. So they refill actually the bridge with a hot wallet. So this is super bad because you can't react by the market. Like if the you can't refill the bridge in advance if there is a huge spike. And also what happens is that actually you end up with a huge amount of money on your wallet because you are afraid, right, that the wallet, the bridge is going to be depleted again. So you end up with $6.5 million on the wallet sitting and basically doing nothing. So a better and ideal scenario would be actually you for your protocol to open a credit line of $6.5 million and use those only what is necessary to have the bridge working. And if there is a market surge, then you pull on the credit line to have this amount again. And this is like a way more capital efficient manner to work in DeFi. So this is like this were like very few examples, but there is many more, such as lien streaming, payments from DAOs to DAOs, etc., etc. If you guys are interested to talk more about it, reach me out on social medias or just talk with me after the conference. Thank you very much.
Yep, thank you. Yeah, and unfortunately we're a bit over time, so I think we'll skip the questions for now. And yeah, we can ask the next speaker. So the next on the list was Annette about NFTs. Probably not here. Okay, I see. Then Azone, yeah, here you go.
Good evening, everyone. I don't want to be the one stopping you from getting into the party, so I'll make it quick. So I'm Shiva from Ozone. I'm here to bring in software delivery platform which addresses developer difficulties for Web3 platform. So getting on to what are development challenges a developer face for Web3 development, we see, and what we understand as well, like how multi-cloud has become essential for the current world for compute. Similarly, multi-chain has become essential and critical for the Web3 world. And what we see challenges for the developers are going to be learning different smart contract languages for different platforms, different specialized skills for each of the platform. You need different deployment process for different platforms, and you have monitoring, notification, specialized infrastructure skills for different platforms. These are the problems which a developer might face and how we can solve the same. So what Ozone is able to bring in is a unified platform for all your Web3 endeavors. So you are able to develop, deploy, and monitor dApps in multi-chain using Ozone platform. So from developing aspect, we have an integrated IDE, Web IDE, and you can also have a code-ready container directly from our Web UI. You also can sync up your GitLab, GitHub, Atlassian, all those Git repositories directly to your interface. And you can deploy it using any provider you like. You can like Infura, you want Alchemy, any of the providers, you can use them as a node provider, or you can build your own node. We interface with all the cloud providers. So if it is, say, Ethereum node you want to run on a Kubernetes cluster, we enable that same thing for you. So this comes part of a pre-integrated Kubernetes integration. So you can run your own node, or you can select any of the highly available nodes from the ecosystem provider for as running as a Ethereum gateway, plus also for other solutions. Going on to, we also provide like package templates coming from different protocols, like OpenZeppelin, many templates from other ecosystem solutions. You can take it from Ozone, which has default templates for similar action, which you can monitor. Getting on to workflows for all these platforms are also available within our solution. You can also monitor how your transactions are performing. Is there any transaction getting missed out? All of it comes from a single interface for you. So some of the, and one of the key points, since we built on Tendermint BFT, you're also, the apps, if you build on our platform, it's going to be by default interoperable across Cosmos ecosystem and any EVM ecosystem also. So some of the benefits which we talked about, standardized pipelines, templates, and this is from phase 1. In phase 2, we are actually getting on to decentralizing application across all your tiers. Basically decentralized storage, decentralized compute, and decentralized database. And decentralized name service, basically you interact with ENS, HNS, or unstoppable domain. So you can have your website or any application running on IPFS or Filecoin or we integrate with the decentralized storage providers. If you have your front end sitting there and your code could be behind the blockchain, we can interact and provide you a default interface. We also connect any containerized application can be deployed in a decentralized manner. It's not just smart contracts. If an application can be containerized with solutions coming from Cartesian, we see some over here, and many of the platforms are being EVM compatible. So we have a solution where we are able to run your containers in a decentralized manner across any Kubernetes cluster around the world. So we run it in a serverless module. So we are able to sufficiently decentralize your application across cloud or on-prem, or you can even let us control the infrastructure. It's sufficiently decentralized with algorithms where you can't track where your workload is. So this is different from decentralizing from the TAR concept. We allow your application to be actually decentralized across all the tiers, which includes compute, of course, storage, data center, databases, as well as from the name service. We can achieve that. We're currently in a beta stage for the decentralized scenario. And phase 1, like you can connect multi-chain deployment. Currently, it's already available from our side. What more? So we see the challenges what developers face in the traditional world is clearly applied across in the Web3 world as well. That's where we are able to provide a solution which is being able to be applied in the Web2 world currently as well. So some of our solutions are used by governments and banking institutions to provide a blockchain as a service in Middle East, as well as several banks use our solutions to provide their Kubernetes services currently live. Blockchain is something we have already established. Thank you. Any questions? Yeah.
Thank you very much. Yeah, but unfortunately, I think we can't take the questions. And I think we've got one more speaker left. It's Akil. Are you ready? I'm going to run the slides. Yeah, we need access. It probably should be on your email. So it should be on your email. I've sent a request to give an access from Patrick at ETHDubai Conf. Oh yeah, here it is. So we are ready to start. Yeah, heard the mic. Everyone, welcome Akil.
Thank you. Which one's just the normal clicker? This one?
I'm not sure it works, so probably better.
Yeah, I'll just use this. All right, thank you very much. So today I just wanted to take a little bit of time to talk about demystifying Ethereum staking. And since we only have limited amount of time, wanted to give it a bit of a speed run through this. So my name is Akil. helping out with the Ethereum Foundation and a few other projects in the ecosystem, bring staking to the forefront and make it more accessible. If you have any questions or information that you require, feel free to scan the QR code or reach out to me on Twitter at QNOU. And if you have more information needs, be sure to check out the ethereum.org website. The team has been doing a very good job of updating information as necessary. So just walking through the event and having discussions with lots of individuals, it's quite clear that people are confused about the updates that are happening in Ethereum, what it means to be moving to proof of stake, what Ethereum 2 is, et cetera, and what the merge is. So the reason for moving from proof of work to proof of stake is clearly the fact that there's a relative energy consumption per transaction, especially when dealing with things like Bitcoin. So just being in Dubai, it's apt for us to kind of compare the Burj Khalifa to what the energy consumption looks like for POS or POW in Ethereum, which is maybe the Leaning Tower of Pizza. And then once you actually shift over to POS, it's even exponentially smaller than that. So essentially, you can run an Ethereum node with the energy consumption of a personal home computer. So people have a lot of misconceptions about why we are moving to POS. And the main factor is that there's a reduction in energy consumption, there's improved security and decentralization, and there's increased accessibility for participation within the network. And that this also allows for us to have secure sharding, which wouldn't be possible within the proof of network consensus algorithm that exists currently. So just going to run through quick items that I've heard through the event and other questions that usually pop up. Is Ethereum coming, E2 coming soon? No, but the merge is, and we can talk about what the merge is a little bit soon. Is Ethereum moving from proof of stake to proof of work as a consensus mechanism? Yes, very soon, as early as June. It might be delayed a little bit depending on the circumstances that we have to deal with. Will there ever be a new Ethereum mainnet coming? No. So the Ethereum execution layer will stay consistent as it is. The transactions, all the history, et cetera, will be the same, and then the consensus layer comes on top to build on top of that. Will there ever be a new E2 token for the stake ether? No. It's the same E token being locked up in the beacon chain, and then as soon as withdrawals are opened up, you can access to those tokens. Will proof of work consensus layer stick around after the merge? No. And will there likely be a Ethereum fork after the merge? Likely not. There hasn't been much as far as indications or incentives for one to happen. But most of you are still wondering, but really, when is E2 coming? The answer is that what you guys really frame yourself mentally as E2 or E1 is really the execution layer and the consensus layer coming together. And as soon as that happens, then the merge, it just becomes Ethereum again. There's no such thing as Ethereum 2 or a new blockchain at that point. And you can learn a little bit more about the great renaming of the merge, or what used to be the E2. You can scan this QR code to go to the blog post that kind of runs into this. So internally, we kind of look at this as more of a space mission where there's already an existing space station that's functioning, but we're improving things, we're changing things, and we're porting things as we go along. So this diagram concept kind of illustrates where we currently are at the bottom layer, where the Ethereum state and the Ethereum network has the execution layer and the consensus layer, which is currently powered by proof of work. But in December 2020, we also launched the beacon chain, which was powered by the proof of stake consensus mechanism. And in the merge, which it will hopefully happen in the next few months, you get rid of the proof of work chain and the proof of work consensus mechanism, and then the proof of stake mechanism comes in. But as you notice, the state and the transaction history, contracts, accounts are still persistent through the network. Nothing changes, and you still continue as forward. So some misconceptions that kind of lead from these upgrades are, will these upgrades reduce transaction fees? No. So this will have no direct impact on network activity or any of the fees. Will this increase scalability and throughput on the blockchain? No. Scaling on Ethereum will likely happen through a roll-up-centric roadmap, and layer 2s will kind of address all these issues related to scalability without compromising any of the decentralization properties of the network. So you might be wondering, will Ethereum still continue to work on sharding with all these L2s coming in? Yes, and this will usually come in after the merge, likely next year. Do you need to actively participate in Ethereum staking? Yes. So this is not a delegated proof of stake network. You need to actually actively validate, make attestations on the network to actually earn income on your staked Ethereum. And you don't need any expensive validator equipment. You can basically run these software with the right pairing on something as minimal as a Raspberry Pi with a decent hard drive. Most likely you still need 32 Ether if you want to be currently as an independent staker and have control over your keys, but there are solutions around decentralized pooling services like Lido, like Rocket Pool, and then there's some activity around shared secret validator services and distributed technologies from companies like Obel that you should follow up on. So one of the biggest concerns that people have when talking about Ethereum staking is, will I get slashed? I don't want to risk my funds. So slashing is actually a mechanism designed to punish bad actors, and the likelihood that you'll get slashed is very low, unless you're building redundancy systems where you're going to start double signing, etc., which isn't recommended for any small-time stakers in the first place. And people think that you have to have 100% uptime to remain profitable in the staking ecosystem, which is untrue as well. So if you're down a few times, you're leaking funds, you're penalized, but it's in conjunction with the state of the network. So one key fact there is that if you are with the majority of the network and the network goes down, you'll be penalized higher. So the fact of the matter is that you should be prioritizing using minority consensus clients, so if things go wrong, you're not penalized as hard. So currently there are 5 clients on the consensus layer. Luckily, in the past 2 days, Prism is no longer the 2/3 majority, and we're seeing a lot more diversification and efforts in this regard. So if you do plan on staking, please choose one of the minority clients, not only for your own benefit, but for the benefit of the network. Additionally, there's the same need for diversification on the execution layer needed. So right now, it's mostly Get situated. Need to Mine, Besu, Aragon are there. If you want to get started with staking or learning about these ecosystems, check out Launchpad and check out ethereum.org. Not only do we need diversification within the client validators themselves, we also need validator diversification in the rest of the world. So as you can see, there's not much activity happening in South America, Africa, MENA region, and South Asia. And it's important for us to kind of disseminate this information and make it easier for these individuals to come into the ecosystem. So things like shared secret validators and distributed validators, where you can put in lesser amount of Ether and pool it together with your friends and family, will make this a little bit more palatable. What can you do right now? So the Kiln testnet is live. This is the last testnet prior to the merge. So help stress test it, see how it works for you. And always try to participate and stake on testnets prior to staking your actual Ether. You can scan that QR code to learn a little bit more about the Kill testnet. Join the ETHDubai community. So basically, the ETHDubai community is a group of guys that do a very good job of onboarding stakers into the ecosystem and do a little bit more research on distributed validator technologies. And then finally, if you want some more spoon-fed information, sign up for the Validator Academy. It's a resource that I'll be creating to explain things in a very simple English manner. And then if you're into the Ethereum community, be sure to come out to DevConnect happening in April in Amsterdam, and obviously the biggest Ethereum event, which is DevCon in Bogota in October. So hope to see you guys there, and thank you for your time.
Thank you very much. Does anyone have any questions? Because we seem to be mostly done. If there are no speakers left in the audience, it seems not, then thank you very much for your time today, especially for those who stayed with us till the end. And yeah, you can go ahead and enjoy the Polygon party. And yeah, thank you. It was a great conference and was great talking to you today.